First of all, I'll give you the list of important topics that you should revise before your exam. So as you can find out here, the most important topics of nerve muscle physiology, nervous system, general physiology and GIT is given here. And in the next slide, I have listed the important topics of CVS, renal physiology, respiratory physiology and endocrine physiology. So all of this topic you must read and revise before your exam. So among all of this topic, first we are going to start with this nerve muscle physiology and the nervous system physiology, means neurophysiology, because you know that neurophysiology one of the important topics that you must have to revise before your exam. So we are going to start with the neurophysiology. The first part is the nerve muscle physiology. What are the important things that I should read? Okay. So first thing is that two MCQs are kept in front of you. So look at the first MCQs. Gibbs-Dunan equilibrium is mainly by. So all of you know that Gibbs-Dunan equilibrium is due to presence of some large impermeable molecule, like for example protein. So the MCQ, first MCQ answer is protein. Second question, the equilibrium potential of an ion is calculated by using which of the following equation? That is the question. So equilibrium potential is calculated with the help of the Nernst equation. So look at here, this Gibbs-Dunan equation and the Dunan equation, they are basically the same thing. It is not used for the equilibrium potential calculation. The Goldman equation or Goldman-Hodgkin-Cage equation, you know that Goldman equation, or which is also known as Goldman-Hodgkin-Cage equation. This is the equation which is used for calculating the resting membrane potential, not the equilibrium potential, but actually the equilibrium potential calculation is done by the Nernst equation. So we have to understand what is this Nernst equation, and we have to also understand that how this protein is responsible for Gibbs-Dunan equilibrium. So first thing is the Dunan effect or Gibbs-Dunan equation or Gibbs-Dunan equilibrium, whatever you say. So what is this effect? Look at, try to understand. So in this box, okay, I am dividing this box into two compartments. So this is compartment A, this is compartment B, right? Suppose this, in between this membrane, this is a semi-permeable membrane. The meaning of the semi-permeable membrane, you know that some of the molecule will penetrate through the membrane and some of the molecule will be impermeable through this membrane. So suppose I have given one permeable molecule, sodium, on both sides of the membrane. Suppose sodium 9 molecule here and sodium 9 molecule on the other compartment. So equal in amount in both the compartments, so there will be no movement of the ion, right? If I give chloride similarly in one of the compartments, suppose only compartment B I have given 9 molecule of chloride, that is also a permeable molecule. So chloride will try to permeate on the other side and there will be an equilibrium, equal distribution of chloride on both sides, means 4 molecule and 1 molecule will move here and there. That is the thing. Now in this equilibrium, if I give one impermeable molecule, one large molecule on one half of the compartment, suppose minus charge is there on the protein molecule, I have given 9 molecule of protein on one part of the compartment. So what is the specialty of this protein? It's a large molecule which is impermeable through the semi-permeable membrane. So sodium and chloride are permeable membrane, but protein is not. Now due to presence of this impermeable molecule on one half of the compartment, what will happen? This equal distribution of sodium and equal distribution of chloride, 4 and 4, that will be disturbed. Okay, and there will be a new equilibrium. So what is happening? Due to presence of this impermeable protein, impermeable molecule on one half of the compartment, there is change in the distribution pattern of other permeable molecule like sodium and chloride, and this effect was first time described by Donan, and that's why this is known as Donan effect. So what is Donan effect? Donan effect is due to presence of certain large impermeable molecule. This is the most important thing. It should be impermeable and it should be large. Obviously impermeable, large molecule will be impermeable. So large impermeable molecule, whenever it is present in one of the compartment, the distribution of other permeable molecule will change, and that change was first described by Donan. Now if you look at the equilibrium condition, so suppose due to presence of this protein, how this sodium and how this chloride will be distributed. I told that distribution will change. How it it will change? Now the sodium will be more on this protein compartment. Suppose this is 12 molecule. Why 12 molecule? Previously it was 9 molecule, now this is 12. Because protein being a negative charge molecule, it has attracted more positive molecule on the same compartment. This is due to presence of this protein molecule which is negatively charged, right? And what will happen to the sodium on the other compartment? Obviously you have taken 3 extra sodium from the compartment B, so there will be only presence of 6 sodium molecule on the compartment B. So A compartment is getting 12 molecule of sodium, B compartment getting 6 molecule of sodium. Now in the compartment B, if you look at the chloride will also be 6. Okay, so actually it should be 4 and 4, but here it is 6, and chloride here obviously it will be 3. So I can also find out that the chloride molecule distribution has also changed due to presence of this protein. Why negative charge is less on the A compartment? Because protein itself is a negatively charged molecule. So now if you look at this distribution, the sodium is unequal in both sides of the membrane. Chloride is also unequal in both sides of the membrane. But if you look at the pattern, then you will find out that the total positive charge on compartment A is equal to total positive charge in compartment B. So total positive is equal to total negative in compartment A, as well as total positive is equal to total negative charge in compartment B also, as you can find out here. Same, so this is the first point. Second point is that after this distribution is over, if you take the product of permeable ion, so sodium multiplied by chloride on compartment A is equal to sodium multiplied by chloride concentration on compartment B. Getting my point? So this is 6 into 6, 36, and here 12 into 3, that is a 36. So both are equal. That means product of permeable ion on compartment A is equal to product of permeable ion on compartment B. Okay, total positive charge is equal to total negative charge in compartment A, and similarly total positive charge is equal to total negative charge on compartment B. And the third is that osmolality or osmotic tension of compartment A will be greater than compartment B. So osmotic tension, we all know that depends on the total number of molecules which is present there, concentration of that molecule. So that's why we say that all these three, these are the part of Gibbs-Donan equation. So if you say that what is the equation, these three are the equations of Gibbs-Donan law or Gibbs-Donan equation, right? And what is Donan effect? Donan effect is simply the presence of impermeable ion on one compartment changes the distribution of other permeable ion. That is the Donan effect, right? So I hope now this is clear that why the protein is the answer in this question. So it should be large impermeable ion. Now second thing, you look at this Nernst equation, right? So Nernst equation, this is again a most important thing that you have to remember. I told that Nernst equation is used for calculating the equilibrium potential of an ion. So you have to remember that the equilibrium potential, if it is EQ, then it is equal to RT by ZF log of concentration of the ion outside the cell upon your concentration of the ion inside the cell. Okay, so this is the natural logarithm. So this is the actual formula which is equal to the Nernst equation. Now all of you know that I have discussed in detail in the actual lecture classes that this R, T and F, these are the constant. All of these are constant. This R is constant, this T is constant, this F is constant. So if you take the normal value of all of this constant, then this formula will change into plus 61 millivolt upon Z upon log base 10 concentration of the ion outside the cell upon concentration of the ion inside the cell. So this is log base 10. This is the equation that you must have to remember, that how to calculate the equilibrium potential with the help of Nernst equation. What is the Nernst equation? Nernst equation is equal to EQ is equal to plus 61 millivolt upon Z log 10 concentration of the ion outside the cell, concentration of the ion inside the cell. So here you have to remember this Z is the charge of the molecule, or you can say the charge of the molecule or valency of the molecule. So if it is sodium, then I will write down, if it is sodium, then I will write down positive 1. If it is calcium, then I will write down plus 2. So this way you have to replace this Z. Now suppose the question is given that the concentration of chloride ion into the cell is 110 milli equivalent per liter and concentration of chloride outside is 11 milli equivalent per liter. Okay, or in the reverse direction. Suppose this is given in reverse direction. So because chloride concentration outside is more, so suppose this is 110 milli equivalent per liter outside and inside is 11 milliequivalent per liter. What will be the equilibrium potential of this chloride ion here? So you will write down like this: Eq is equal to plus 61, Z is minus 1 because it's a chloride, right? Log of base 10, concentration of the ion outside, so this is 110 and here it is 11. So all of you know that this ratio 110 upon 11, this ratio is equal to 10. So basically this is equal to log 10 base 10, right? So this is log 10 base 10, that is equal to 1, we all know. So here this whole ratio will be converted into minus 61 millivolt. So in this cell, the equilibrium potential of the chloride will be minus 61, right? If you change the concentration of the chloride ion between inside and outside, then the sign will change from negative to positive or positive to negative. So what I am saying, that you go in step by step fashion and you will get to know what will be the equilibrium potential of this ion. So with this concept, what you understood so far? You understood the Nernst equation. I have to remember the formula and I have to look at what is the concentration of the ion inside and what is the concentration of the ion outside, and just put into this formula, you will get the equilibrium potential of the ion. So with the help of this concept, try to look at this question and try to answer. So the intracellular and extracellular concentration of potassium. So intracellular potassium ICF concentration is given equal to 140 millimole. Okay, millimole, and potassium ECF concentration is given 14 millimole. See, so now it will be very, very simple. If I want to calculate the equilibrium potential of potassium in this cell, what I will do? Plus 61 upon Z. Z will be here is plus 1 because it's a potassium, plus 1 charge. So log base 10 with concentration of the ion outside. So this is 14 and concentration of the ion inside, that is 140. So now this whole fraction will be log 10 to the power minus 1 with base 10. This is right. So log 10 to the power minus 1 base 10 is equal to minus 1. So now I can replace here that plus 61 multiplied by minus 1, right? So this is whole minus 61 millivolt. So again in this question, the equilibrium of the potassium is minus 61 millivolt. Got it? So please note down that in a normal mammalian cell, you have to remember the normal value. Although we are calculating that potassium equilibrium potential is minus 61 here, but actually this is a hypothetical cell, because all of you know that the potassium concentration inside is near equal to 140-145 milliequivalent, but outside potassium concentration is not 14, it is 4 to 5 milliequivalent per liter. This number has been given just for your calculation easiness, right? But actual concentration, this is not the actual concentration. So if you look at the actual concentration, then you remember that the potassium equilibrium potential is minus 90, chloride equilibrium potential is minus 70, sodium equilibrium potential is plus 61 or plus 63, and calcium equilibrium potential is plus 132 millivolt. So these are the four numbers that you have to remember, that what is the equilibrium potential of individual ion, what is the actual number in a mammalian cell, right? So potassium is minus 90, chloride is minus 70, sodium is plus 63 or plus 61, and calcium is plus 132. How this number has been calculated? This number has been calculated based on the Nernst equation. Now, Nernst equation, it is used for a single ion. See here, outside and inside concentration, we are finding out for a single ion. Now, if a cell contain only one type of permeable ion channel, then Nernst equation can also be used for calculation of the RMP. What I am saying? Suppose one cell contain only one type of leak channel, only one type of channel on the cell membrane, then RMP of that cell can also be calculated by Nernst equation. Okay, so in that cell, the equilibrium potential will be equal to RMP. Like for example, suppose I am saying that this is a glial cell. Glial cell contain only one type of leak channel, and that is the leak potassium channel. That is the leak potassium channel. So the equilibrium potential of potassium will be equal to the RMP of this cell. And how can it be calculated? It can be calculated by Nernst equation, right? So please note down most important thing. Nernst equation is used for a single ion only. And if a cell is permeable to only one single ion, only one type of ion, then the equilibrium potential of that ion will be equal to the RMP of that cell, right? Right. For example, this cell, the glial cell, has an RMP of minus 90 millivolt, which is the equilibrium potential of potassium, right? Okay. But generally, mammalian RMP is calculated with the help of which ion? I told you already the equation. Okay. Which equation? The equation is known as Goldman-Hodgkin. Okay. Goldman-Hodgkin Cas equation, and this is the whole equation. So no one is going to ask you this detailed equation, because you can find out here the Nernst equation ka similar type here. Okay, so here it is also RT upon F, and this is the natural logarithm. So you can find out here, this is the natural logarithm, then it is P is the permeability multiplied by concentration. So here you are considering the permeability as well as the concentration of the ion. Which ion? Potassium ion, sodium ion, and chloride ion. So basically, it is said that a mammalian cell is permeable to at least three types of ion: potassium ions, chloride ion, and sodium ion. And all these three ions are responsible for generation of the RMP. So if I have to calculate RMP, then I have to consider all of these three ions. In these cases, I cannot use the Nernst equation for calculation of RMP, because Nernst equation is only for only a single type of ion. So that's why we use this Goldman-Hodgkin Cas equation for calculation of the RMP. With the help of Goldman-Hodgkin Cas equation, if you look at the RMP, then all of you know that RMP of the neuron is this. Okay, generally we remember minus 70 millivolt. Then RMP of the skeletal muscle is this, but we generally remember minus 90 millivolt, right? Then RMP of smooth muscle, we generally remember it is a range from minus 40 to minus 60 millivolt, right? And cardiac muscle, again this is generally minus 90 millivolt. Hair cells RMP, this is minus 15 to minus 40, so minus 40. Genome is saying this is minus 60. Astrocyte, that is the glial cell, I already told you that this is minus 90 millivolt, because this is equal to the potassium equilibrium potential. Then erythrocyte RBC RMP is minus 10 millivolt. And look at here, the photoreceptor, that is the rods and cone cells of the retina, they are minus 40 RMP in dark condition, and in light condition that is minus 70. Means in presence of light is the stimulus for rod and cones. In presence of light, rods and cones are getting hyperpolarized. Please remember, whenever there is presence of stimulus, generally the receptor cells in our body get depolarized. But these rods and cones, the photoreceptor, are exception. Whenever there is presence of stimulus for this cell, that is the light, in presence of light, it will be more negative. More negative means hyperpolarized, right? But when the light is not there, it will remain in a depolarized condition. So dark means depolarized. So rods and cone, dark means it will remain in a depolarized condition, and light means it will be in a hyperpolarized condition. This has been asked in MCQ, so please try to remember, right? So this is all about your RMP and equilibrium potential. Now you know everything. Try to answer these three questions. So three questions, although looking similar, but they are not similar. So first question, resting membrane potential is close to. Okay. Second question, resting membrane potential of nerve is equal to. And third question is also equal to, but tissue here is the myocardium. So now we look at the three questions. The three questions are different. In the first question, nothing is mentioned whether it is nerve or myocardium, but the question is only close to. So please remember, whenever the question is RMP of a cell is close to, your answer is potassium, potassium, potassium. Always the answer is potassium. But whenever the question is equal to means you have to look at the number. RMP is same to same. That is the equal to. So here the nerve is given. What is the RMP of the nerve? Minus 70 millivolt. Minus 70 is the equilibrium potential of which ion? That is the chloride ion. So here the answer is chloride. But look at, in the second question, the tissue is myocardium. What is the RMP of myocardium? Minus 90. Which ion has an equilibrium potential which is minus 90? That is the potassium. So here again the answer is potassium. So please note down, when the question is close to means always the answer is potassium, because potassium is the most permeable ion in mammalian cell membrane in resting condition. Okay, but whenever the question is equal to, then you have to look at the number, same to same number, right? Equal to means same to same number, and then you have to look at which tissue they are asking about, right? So why close to answer is potassium? Because potassium is the most permeable ion in mammalian cell membrane when there is resting condition. What is the second most permeable ion? Chloride. And what is the third most permeable ion? Sodium. I told you already that cell membrane normally permeable to 3 ions, potassium, chloride and sodium, but most permeable is the potassium. Got my point? Right. So please note down that these 3 lines which are written here, they're the very important. Multiple times the question has been asked from here. RMP of all vertebrate cell is close to equilibrium potential of potassium. Okay, because permeability of potassium is maximum, okay, maximum in resting condition. And this permeability of potassium occurs through which channel? Movement of potassium occurs through which channel? Leak channel. The channel which remain open in resting condition, they are known as the leak channel. So basically leak channels are responsible for resting membrane potential generation, right? Then RMP of neuron is equal to, we have already discussed, that is chloride. Resting permeability through cell membrane, maximum is potassium, followed by chloride, followed by sodium. Got it? So this is all about the brief version of Nernst equation, RMP and Gibbs-Donan equation. Got it? Okay. Chalo, aage badhte hain. So now we are entering into the neurons. So in neuron, I'm 100% sure that you know the parts of a neuron, different parts of a neuron, okay, anatomically. So if this is the cell body, right? So from the cell body, there is a portion which is known as the axon hillock. Then this axon hillock will be attached with a long axon, right? And at the end, there will be an axon terminal. So the first portion of the axon, okay, where the axon hillock is mixing up with this axon, this portion is known as the initial segment of the axon, okay. Then if the neuron is myelinated, myelin sheath will be present, and in between this myelin sheath, there will be node of Ranvier. In between myelin sheath, there will be presence of node of Ranvier. Okay, we know this. Okay, now we have to remember certain functional properties of this neuron. What is this? Graded electrogenesis. So if the question is graded electrogenesis generation occurs in which part of the neuron, then your answer is dendrites and soma. So graded electrogenesis is a kind of local potential generation. So local potential generation occurs at the level of these dendrites, also at the level of the cell body. Okay, so here the local potential will be generated. Now all these local potential will aggregate and they can give rise to action potential generation at the level of initial segment, not the axon hillock, initial segment. So if the question is action potential initiation occurs in which part of the neuron, okay, action potential initiation or start occurs in which part of the neuron, then your answer, if it is sensory neuron, the answer is node of Ranvier. If it is motor neuron, initial segment is the answer. Okay, so please note down, just mock up this information, because the time is not there. The detailed version, why the answer is different, it has been discussed in main lecture. But here you remember that if the question is motor neuron, then initial segment is the first part where action potential is starting. But if it is a sensory neuron, then node of Ranvier, first node of Ranvier is the first part where action potential will be initiated, right? So first these two MCQ, you got it. Now the next question, that why the action potential is initiated in the initial segment or node of Ranvier? Because you know that action potential of the neuron is based on a channel which is nothing but voltage gated sodium channel. So now we have to answer that the voltage gated sodium channel concentration is maximum in which part of the neuron. Your answer is node of Ranvier is that portion where sodium channel concentration is maximum, whether it is motor neuron or sensory neuron. If the question is maximum voltage gated sodium channel is present in which part of the neuron? Your answer is node of Ranvier, and the number or the concentration is written here, but you may forget that. Second, if the node of Ranvier is not given, then the second highest sodium channel is present at the level of initial segment. At least you remember these two information. Okay. Third, here also is written that soma and dendrite contain lesser number of sodium channel, and the telodendria, that is the ending part of the neuron, okay, they also contain very less number of sodium channel. But if the question is that the least number of sodium channel, voltage gated sodium channel present on which part of the membrane, which part of the neuron, your answer will be surface of this myelin sheath. Surface of this myelin sheath, they contain least number of voltage gated sodium channel. Fine. Okay. Remember, please, these are the important information, functional information of neuron, right? Okay. Now we have to look at the action potential and the ionic basis of the action potential in neuron and skeletal muscle. So first I am drawing the y-axis and the x-axis, right? So this x-axis, suppose this is the minus 70 millivolt, means this is the RMP of the neuron, right? And x-axis denote the time axis. Y-axis denote the membrane voltage axis, right? So we all know that action potential means what will happen? The resting membrane potential will change towards the positivity first, okay, changing towards the positivity. Whenever it is raising up to minus 55 millivolt, this minus 55 millivolt is known as the threshold voltage of the neuron. This is known as the threshold voltage of the neuronal membrane. Whenever it is going beyond the threshold voltage, when it is going more positive than threshold voltage, then what will happen? Suddenly huge number of voltage gated sodium channel will open up, and because of which the membrane voltage will shoot up to the plus 35 millivolt, and this is nothing but generation of the action potential. This part where the membrane voltage is shooting up towards plus 35 millivolt from this minus 55 millivolt, this is known as the depolarization phase of action potential, and all of us know that this phase is due to entry of sodium ion into the cell, right? Then after entry of sodium ion into the cell, when the membrane voltage has rise up to plus 35 millivolt, what will happen? Now the sodium channel will get inactivated and potassium channel will open up. Whenever potassium channel opens up, we know that potassium will go out of the cell, and because potassium is going out of the cell, what will happen? The membrane voltage will start falling back towards the RMP. So this is the repolarization part. Repolarization is going on. Now one part of the repolarization will go even below the RMP. If it is going below the RMP, means it is more negative than RMP. So this part of the membrane voltage which is going below the resting membrane voltage, this is known as the after hyperpolarization. This is known as the after hyperpolarization phase of action potential, and this is the repolarization phase of action potential. So basically this after hyperpolarization is also part of the repolarization, right? But repolarization means it is starting at plus 35 millivolt and the membrane voltage is slowly moving down towards the membrane voltage, but it is not stopping at original membrane voltage. It is not stopping at minus 70 millivolt, but some part of the membrane voltage is going below the RMP, that is known as after hyperpolarization. So if I ask you what is the ionic basis of repolarization, this is nothing but exit of potassium from the cell, or potassium is leaving from the cell. If I ask you what is the cause of this after hyperpolarization, this is also due to exit of potassium ion from the cell, but actually this is the slow closure of the potassium channel, because you know if all the potassium channels are completely closed at minus 70 millivolt, then RMP will never move to minus more negativity, or it will never move to after hyperpolarization. But because potassium channels are very slow in nature, it will open up slowly and it will also close slowly also. So whenever it is closing slowly, what will happen? Some extra potassium will go out of the cell, and because of that extra potassium, what will happen? There will be after hyperpolarization. Getting my point? So these are the ionic bases. Now we have to understand the permeability of the ion in different phase of the action potential? Permeability. So if you look at the permeability of the sodium ion, okay, look at, so permeability means how many sodium channels are open in different phase of action potential. So initially when the local potential is generated, number of sodium channel opening is very less, slowly rising. See, look at the pink color curve. This is the number of sodium channel which are in open state. Okay, so initially the number of sodium channel which are in open stage are very less, but whenever the membrane voltage is crossing the threshold, suddenly the huge number of sodium channel will open up, and suddenly all of this sodium channel will get inactivated like this. So this pink color curve, this is the curve which is known as the permeability curve of which ion? Sodium ion, right? So initially it is opening up slowly during local potential, and then whenever the membrane voltage is crossing the threshold, suddenly the number of sodium channel rising to a very high level, and then it is inactivated quickly. If you look at the permeability of potassium ion, look at blue color. So potassium ion channel, they will also open up very slowly. It is also opening up slowly. So maximum potassium channel is opening up at which phase of action potential? When the action potential is falling back, means when the action potential is repolarizing. Then potassium channel is getting closer, but taking long time. So complete closure taking very long time. So this blue color curve is the curve of permeability of potassium. Why the potassium channel or potassium curve is behaving like this? Because potassium channel is very slow in nature, and sodium channel is very fast in nature. So now you look at this diagram. If I ask you a question that maximum sodium channel is open in which phase of the action potential, or if I ask you maximum permeability of sodium in which phase of action potential, answer will be here. That is the peak of the action potential. When the action potential is peaking, sodium channel number or permeability is also peaking along with the action potential peak. But if I ask you maximum potassium channel where the number is highest, okay, then your answer is at the mid part of the repolarization. These are clear? So please note down and look at this diagram. Suppose this is the question that action potential is recorded from a mammalian neuron, at which point the action potential, the potassium permeability is maximum. So sodium permeability, so in this question if I ask you maximum sodium permeability, what will be your answer? That answer is point number A, because we have seen that sodium channel open up like this and closes or inactivate like this. But in case of potassium, the potassium channel will also open up slowly, but maximum potassium channel will open up like this and then it will close like this. So this red color one is the potassium, right? So maximum potassium is open in which point in this action potential? In B. Getting my point? So answer of this question is point number B, where the maximum potassium channel is open. Potassium channel permeability is maximum. Now you look at, if the question from this diagram, if the question is asked that sodium channel permeability upon potassium channel permeability, this ratio is maximum at which point? And second question, the potassium permeability upon your sodium permeability, this ratio is maximum in which point from this diagram? So look at sodium upon potassium. So sodium is maximum, upon potassium is lowest. That is which point? Again your point number A is the answer, because I can find out that this is the point where sodium channel number are huge and potassium channel number are also present, but number is less. So if I take a ratio, highest ratio will be in the same, that is the point number A, where sodium permeability is maximum. But if the question is reverse, here they are asking potassium upon sodium. So if you say this point number B, then that is not correct, because at this point sodium permeability is also very high, although the number is decreasing. Okay, although the numbers is decreasing here, but permeability of sodium is still high. But if you look at this point, okay, take a different color. So here look at this point. So if I ask you at this zone where I have given this yellow color shading, at this zone, tell me how many sodium channels are open. Are the sodium channels are open in this yellow color zone? See, all the sodium channel has been closed or inactivated at which point? Point number C. So after the point number C, all this portion where I have given this yellow colored set, there is no sodium channel open during this part. So if there is no sodium channel open, so if I take this ratio, potassium channel numbers are present but sodium channel numbers are 0. So some number upon 0, what is this? This ratio is infinity. Infinity means obviously this is maximum. So in these cases the answer will be point number D, where potassium upon sodium permeability ratio is maximum. Not only maximum, this is infinity, because sodium channel numbers are 0. Only channel which are open is potassium channel. I hope this is clear. This is very important to understand, because questions will be given in future also. Okay, the question will be given from here. Okay, next. So now you answer these two questions. This is based on nerve fiber classification. You all know that based on the action potential, conduction velocity, we classify the nerve fiber. Also the diameter is also different, conduction velocity is also different. So depending on this diameter, myelination and conduction velocity, we classify the nerve fiber. Here the question is slowest conducting nerve fiber. So all of you know A, B and C types of nerve fibers are there, and the C fiber is the slowest conducting fiber. The C fiber is which type of fiber? The postganglionic sympathetic fiber. So that's why the answer here is the postganglionic sympathetic fiber is type C fiber, who is slowest or lowest conduction velocity. Second question, a patient slept keeping his arm by side. Now he developed tingling and numbness, right? So this tingling and numbness, when you compress the nerve, this is typical symptoms of paresthesia, right? Tingling, numbness, pain and needling type of sensation. This is the typical description of paresthesia when the nerve is under compression for some time. Paresthesia. Pinning, okay, needling type of sensation, pain and needling, tingling and numbness, this is the kind of sensation. So it is said that paresthesia is due to involvement of pain carrying nerve fiber. We know pain carrying nerve fibers are two. A delta fiber can also carry pain and C fiber can also carry pain, but it is said that paresthesia is due to large diameter pain carrying fiber. So A delta is the answer of this question. Got it? So along with this, you have to look at the ABC classification table, because you know that this table has been asked in multiple times in different types of MCQs. So try to remember as much as information from this table. So all of you know, I believe that you know this A fiber, B fiber and C fiber. This fiber type classification was done by scientists who are, what is the name? Erlanger and Grasser. Right? They first time classify the nerve fiber ABC, and we all know that A fiber is a myelinated fiber, B fiber is also myelinated fiber, but C fiber is unmyelinated fiber. Okay, then A fiber is again subdivided into A alpha, beta, gamma and delta. B fiber has no such subdivision and C fiber also has no such subdivision. So A fiber has A alpha, beta, gamma, delta. These four types of subdivisions is there. Now later on, all of you know that Lloyd and Hunt, they are the other scientists who classify the same nerve fiber, but rather than giving ABC, they gave some number. Like here, A alpha is also known as 1A and 1B type of fiber. Okay, this is similar to A alpha fiber. Then A beta fiber is similar to type 2 fiber according to Lloyd and Hunt classification. And A delta type of fiber is type 3 fiber in Lloyd and Hunt classification, and C fiber is type 4 fiber in Lloyd and Hunt classification. So as you can find out here that this B fiber has not taken into consideration in Lloyd and Hunt classification. Similarly, the gamma is also not taken into consideration. So this Lloyd and Hunt classification is based on some number. That's why we say that this is the numerical classification of Lloyd and Hunt. Right, but this numbers is basically the same nerve fiber is classified differently. Okay, but the most important thing, if I have to remember only one thing from this table, then I will remember this column, important. So A alpha fiber, okay, so this A alpha fiber, okay, or 1A or 1B fiber, where they are located, What is the function of this fiber? All the proprioceptive fiber in your body and all the somatic motor fiber, so motor neuron and proprioceptive neuron, they are the A alpha type of fiber. They has the highest diameter and they have the highest conduction velocity. So these two number, at least these two number you remember, that conduction velocity of A alpha type of fiber is 70 to 120 meter per second and diameter is 12 to 20 micrometer, right? Then A beta type of fiber, they are the fiber which carries your touch and pressure. So this A beta, look at here, they are carrying your touch and pressure. So touch and pressure carrying fiber is type 2 fiber or A beta fiber. Similarly, A gamma fiber, this is efferent to the muscle spindle. So muscle spindle contain an efferent, okay, efferent for a feedback. So this efferent is nothing but A gamma type of fiber, okay. Then delta fiber, very important for MCQ. So this delta fiber and C fiber, look at these two simultaneously. So this delta fiber and C fiber, both of them are responsible for carrying pain and temperature, right? But this A delta fiber is a myelinated fiber. So the conduction velocity of pain by this A delta fiber is faster. So that's why this pain will be known as the fast pain, A delta fiber, and the pain carried by C fiber is a slow pain. Similarly, the temperature which is carried by A delta fiber is the cold temperature and the temperature which is carried by C fiber is the warm temperature. Along with that, all of you know that the preganglionic autonomic fibers, they are the B type of fiber, and postganglionic autonomic fiber, particularly the sympathetic fiber, they are the C type of fiber. So conduction velocity will gradually reduce from A towards the C and the diameter will also reduce from A towards the C. But I have not written the diameter of individual fiber because they are very easy to remember. Just you divide this number with 6. So if you divide this 30 with 6, then it is approximately 5 micrometer is the diameter of this fiber, okay. Or if you divide this 2, so there will be a range. If you divide this with 6, so it will be approximately 2.5 micrometer is the diameter of this fiber. So this way you can remember the diameter, but that's not very important. At least you remember the functions part and the conduction velocity part of all of this fiber. Now from this table, after this classification, you have to remember the most important information from this table, that is cold sensation is carried by which fiber? It is A delta fiber. Warm sensation, burning pain and freezing pain is carried by C fiber. Warm, okay, burning pain, freezing pain, C fiber. Very important for MCQ, telling you, very important for MCQ. Now you know three sensation: the fiber which is most sensitive to local anesthesia, the fiber which is most sensitive to pressure, and the fiber which is most sensitive to hypoxia. These are the three questions which have been asked multiple times, and I hope all of you know that local anesthesia, this question is a little controversial because you know the physiology book is saying different, the pharmacology book is saying different, and local anesthesia book is saying different. But please note down, whatever I have written here, this is taken from anesthesia books, and try to follow it, okay. Why you should not follow the genome here, okay, I will not tell the detailed reason here because I have discussed this in detailed lecture. But please note down that the most sensitive fiber to local anesthesia is A gamma, followed by A delta, followed by A alpha, A beta, B fiber and C fiber, right? Most sensitive fiber to pressure is A fiber, followed by B fiber, followed by C fiber. Most sensitive fiber to hypoxia, B, followed by A, followed by C, right? Okay, so we remember like this, that P, that is the pressure, A, C, right? So most sensitive fiber is A and least sensitive fiber is C, okay. For hypoxia, I remember like this, that HSBC. So in H stands for hypoxia, most sensitive fiber is B and least sensitive fiber is C. So obviously in between A will be there, right? So in case of pressure, most sensitive fiber is A and least sensitive fiber is C. So obviously in between there will be B. So this way we remember the different types of fiber, okay. Now the spike duration, you know, spike duration means it is a part of the action potential. So basically this spike duration will correlate with the action potential duration, okay. Now if the fiber is a slowly conducting fiber, then the action potential duration, spike duration will be longer, prolonged. So if the question is maximum spike duration, then your answer will be slowest conducting fiber, that is the C fiber. And how much that is? 2 millisecond. Then B fiber, spike duration is 1.2 millisecond, A fiber spike duration is 0.4 to 0.5 millisecond, right? So spike duration correlate with the action potential duration. You know that action potential duration, actual action potential duration of neuron, actual action potential duration of neuron is 1 to 3 millisecond. Action potential duration of skeletal muscle is generally 2 to 5 millisecond, 2 to 5 millisecond. But action potential duration of myocardium is very, very prolonged, that is 200 to 400 millisecond, 200 to 400 millisecond. So please try to remember this important information. Fine? Okay. Now next, this is a question based on the skeletal muscle, okay, physiology. So one of the recent question that has been asked in MCQ is related to this DHPR and R wire coupling, right? So this coupled word, DHPR and R wire coupling. So if the question is in skeletal muscle, DHPR and R wire receptor are coupled by, your best answer is electromechanical coupling. But if the electromechanical coupling word is not there, then only mechanical coupling will be the best answer. Okay, only mechanical coupling will be the best answer. Okay, now look at the second question. True statement regarding skeletal muscle contraction. First option, extracellular calcium ion not important for contraction. It's a true statement, right? Calcium released from mitochondria for skeletal muscle contraction or myocardium contraction. Mitochondrial calcium is not important. False. Calcium releases from sarcoplasmic reticulum. Obviously, this is 100% true statement, because in skeletal muscle, the sarcoplasmic calcium is the only source of calcium, 100% source of calcium. So this is a true statement. Voltage gated calcium channel on sarcolemma has no role in EC coupling. Okay. EC coupling में there is no role, excitation contraction coupling, right? So voltage gated calcium channel, do you know what channel they are talking about? They are talking about this DHPR channel. They are saying DHPR channel has no role for coupling. This no word is very, very false. So obviously this is a false statement. Calcium channel on sarcoplasmic reticulum has no role. Calcium channel on sarcoplasmic reticulum, which channel they are talking about? RYR channel, ryanodine receptor channel they are talking about. Obviously this is also a false statement. So my answer is A and C. Okay, these are the two true statements. So now you have to understand a little bit about this excitation contraction coupling in skeletal muscle and cardiac muscle. I discuss this topic in all my classes, almost all my classes, right? So in skeletal muscle, you know that if I draw a cell membrane like this, okay, so this is the sarcolemma membrane, this is sarcolemma membrane, and this is the T tubules. So the T tubules contain a channel, okay, calcium channel. This calcium channel is the DHPR type of calcium channel, DHPR type of calcium channel. And just opposite to this, there will be sarcoplasmic reticulum. So this is sarcoplasmic reticulum. On the sarcoplasmic reticulum, the channel which is present here is RYR type of channel, ryanodine receptor channel. Now all of you know, I told you in my classes that this DHPR channel, this is a calcium channel. The recent name of this channel is CAV 1.1. This is voltage gated calcium channel. That's why it is written CAV. V stands for voltage gated calcium channel 1.1. And ryanodine receptor, which is present in skeletal muscle, this is RYR1. If I draw this same diagram in case of cardiac muscle, look at here. So if I draw this same diagram in case of cardiac muscle, the T tubules will be there, as well as this cell membrane will be there, and the sarcoplasmic reticulum will also be present like this. So obviously there will be presence of the DHPR channel here. So DHPR channel means dihydropyridine receptor channel. This is a voltage gated calcium channel written as CAV 1.2. So what is the difference you are finding out here? In case of cardiac muscle, this is CAV 1.2. In case of skeletal muscle, this is CAV 1.1. Got it? Right. Okay. Now in case of skeletal muscle, RYR1 was there. In case of cardiac muscle, if I draw RYR, then it will be RYR, ryanodine receptor type 2. Okay. Now you got the difference between this channel. So property of this channel will also be different. So now if you look at the skeletal muscle, Note down. Whenever there is action potential, means electrical activity has been started on the muscles membrane. So muscle membrane will be depolarized. This depolarization will move through these T tubules. It will activate the DHPR channel. Now this DHPR channel will interact with the RYR channel physically. These two channels are very close to each other. Whenever the DHPR channel is active, it will interact. It will extend towards the RYR and it will interact with the RYR physically, mechanically. So what is happening? In presence of this electrical activity, electro, the DHPR and RYR, they are contacting with one another. They are making a couple between one another. And this coupling is a physical coupling, mechanical coupling. That's why we say this word, that electromechanical coupling between DHPR and RYR channel here. Now whenever the DHPR is interacting with this RYR mechanically, RYR channel will be twisted, and because of the twisting, RYR will open up, and through this channel the calcium will release from sarcoplasmic reticulum. So where from the calcium is coming for skeletal muscle contraction? Only and only source is sarcoplasmic reticulum. That's why we say that 100% source of calcium for skeletal muscle contraction is sarcoplasmic reticulum, and this calcium will leads to contraction of the muscles by cross bridge cycling. Actin myosin interaction will be there, that will leads to cross bridge cycling, and contraction of the muscle will happen. Right? Okay. Now you look at and try to understand the difference in cardiac muscle. In cardiac muscle, the same thing, action potential will appear. There will be depolarization of the membrane first, then the DHPR channel will be activated. Now in cardiac muscle, DHPR channel activation means the channel is not going to interact with the RYR mechanically. No. Rather, this DHPR channel will open up itself. So now the DHPR channel is opening up. There will be creation of a pore in this channel. Through this pore, what will happen? The calcium will enter from outside the cell into the cytoplasm of the cell. So now this calcium is coming from ECF. Extracellular calcium is required. Right? Extracellular calcium is entering into the myocardium cell. But this calcium which is entering into the cell, amount is very less, only 20%. But this small amount of calcium, what is going to do? It is going to stimulate the RYR channel. Okay, so now this calcium is connecting, is making a coupling with the RYR. No physical contact, no mechanical contact, but the calcium is a mediator between these two. Calcium is going towards the RYR and it is activating the RYR channel. Whenever there is activation, RYR channel will also open up, and now the calcium will move from sarcoplasmic reticulum into the cytoplasm. So this calcium amount is 80% and the ECF calcium is 20%. Now combination of these two calcium will leads to contraction of the cardiac muscles. So now if I ask you a question, that in case of cardiac muscle, what is the dominant source of calcium? Your answer is sarcoplasmic calcium. But which one is the essential source of calcium? Essential means if you block that calcium, nothing is going to happen. Contraction is not going to happen. Then your answer is ECF calcium is the essential. Now here if I ask you that DHPR and RYR, how they are making a coupling? Is there any mechanical interaction or physical interaction? Answer is no. But in presence of electrical activity, so again this is electro, the DHPR RYR interacting with the help of this calcium ion. So calcium is a mediator, calcium is a chemical signal. So that's why it is said that electrochemical coupling occurs between DHPR and RYR in case of which muscle? In case of cardiac muscle. This electrochemical coupling which is happening in case of cardiac muscle, this is also known as calcium induced calcium release. So this C for calcium, it is inducing releasing of second calcium from sarcoplasmic reticulum. That's why this is known as CICR, or calcium is inducing further calcium release from the sarcoplasmic reticulum. Calcium induced calcium release. So this is all about the DHPR RYR coupling in skeletal muscle and in cardiac muscle. I am telling you, this is very crucial topic, very important topic, and this is going to be asked in future also. Please be ready for that. So what is the bottom line? Bottom line is that we have learned that this DHPR channel, this is actually a calcium channel. And what is the recent name to this calcium channel? CAV, voltage gated calcium channel, 1.1, 1.2, this kind of name. So I have to remember that there are other type of calcium channel in the body. We have heard the PQ type of calcium channel is there, N type of calcium channel is there. So is there any recent name to this PQ, N type of calcium channel? Answer is yes. So look at this table. Okay. So RYR1, ryanodine receptor type 1, it is present in skeletal muscle, and mutation of this channel, okay, when the channel is mutated and the channel will not be able to close automatically, so what will happen? The malignant hyperthermia is going to happen due to mutation of this channel. RYR type 2, this is present in myocardium and in CNS brain. And RYR type 3, this is present in smooth muscle and epithelium cell. So remember this, important. Okay. Now I told you that DHPR type of calcium channel, DHPR type of calcium channel, they are L type calcium channel. L stands for long lasting. Okay, means whenever the channel is open, it will remain open for long duration. Okay, and T stands for transient type of calcium channel. So L-type calcium channel is the DHPR channel. I told you that there is a recent naming, that is CAV 1.1 and CAV 1.2. So now the CAV 1.1 is exclusively in skeletal muscle. CAV 1.2 is present in both myocardium and in smooth muscle. PQ and N type of calcium channel. Look at the recent name to this. PQ and N type of calcium channel. What is the recent name? They are known as the 2.1 and 2.2 type of channel. So PQ and N, they are basically 2.1 or 2.2 type of calcium channel. And T type of calcium channel, they are the type 3 type of calcium channel. CAB 3.1, 3.2, 3.3. So this T type of channel is 3.1 or 3.2 or 3.3. They are present in pacemaker tissue, that is the nodal tissue of the heart, as well as osteocyte cells of bones. Right? So please remember, these are the different types of calcium channel that you have to remember for your future MCQ. Okay. चलो आगे बढ़ते हैं. So now there is a MCQ based on the sarcomere structure, electron microscopic structure. So the electron micrograph of human gastrocnemius muscle has been given below. The protein marked in A in the Z disc in the following diagram helps in binding of actin to Z line. Everything is given. Even if you don't understand this diagram, okay, the protein which binds actin with Z line is nothing but actinin, alpha actinin, which is also known as cap Z protein. So obviously the answer of this question is D, right? But we have to look at the other options. And if you have read my lecture, I hope all of you have read detailed version of titin, nebulin and myosin. But here I will tell you the brief version of titin and nebulin because they are important for future MCQ. But before that, look at this diagram which is given in front of you. So you can find out here that there is a dark area from here to here. The pink color diagram that I am drawing, this is the dark area of the muscles, dark region of the muscle, and the myosin will be present in all of this dark region. So whenever the myosin is present, the muscles under microscope looks like a dark region, and this region is known as the A band. So here the myosin will be present through and through. So A band means that is a myosin band. Okay. Now I can find out that at the center of this myosin there is a line. So at the center of the myosin there will be an elevated area here. There will be an elevated area at the center of this myosin, right? This elevated area will touches with one another and it will give rise to a line that is known as the M line. So this is A band. At the center of the A band there is a line which is the M line. Now we also know that some part of the myosin is overlapped by actin and some portion is not overlapped by actin. Okay, so if this is my Z line, suppose this is my Z line. Okay, now here is the Z line. So suppose that actin is here. Okay, suppose this is the actin attached with this Z line. Okay, this is actin, this is another actin attached with the Z line here. Okay, So I can find out that this myosin, okay, is overlapped by actin, but only on the lateral aspect here, only on the lateral aspect, two lateral aspect. But at the center of the myosin, there is no overlap of actin. So that's why the center of the myosin is looking like a lighter area, like a whitish area. This whitish area is known as the H band of the muscle, H band. Okay, so the lighter area at the center of this A band is known as the H band, and at the center of the H band we have already discussed the M line is there. Okay. Now the part of the sarcomere where myosin is not at all present, which of the area? So this area where the myosin is not at all present, this area myosin is not present here. This is nothing but your I band of the muscle, I band of the muscle. All of you know this banding, right? So I band means only the thin filament band. So if I have to write down only one thing, I band means thin filament band. Thin filament means not only the actin is present, along with the actin, tropomyosin, okay, tropomyosin, troponin will also be present, but no myosin, This is the important thing that you have to remember. And A band means this is the myosin band. Actin may be present, may not be present, but myosin has to be present for presence of A band, that is a dark band, right? Okay. Now, if you want to understand this titin and nebulin, then you have to look at the schematic diagram of a sarcomere. So all of you know that if this is your Z line, this is another Z line. So the length between these two Z line is the length of the sarcomere. This is actually the length of the sarcomere. What is the normal length of sarcomere? This is 2 to 2.2 micrometer is the length of a normal sarcomere. This is the optimum length of sarcomere. Okay, the length can be increased from here, can be decreased from here, but this is the optimum length of sarcomere, 2 to 2.2 micrometer. Now, first, the actin molecule remain attached with the Z line. So if this is my Z line and this pink color molecule is the actin molecule, it remain attached with the Z line with the help of a molecule which is known as the alpha actinin, or this is also known as the cap Z protein. Got it? Okay, so actin is attached with Z line with the help of protein, that is alpha actinin or cap Z protein, right? Okay. Now, actin molecule, they are composed of multiple sub-unit which are known as the G-actin. Okay, actin, it is a filament. Filament is made up of multiple sub-unit. Those sub-unit may disintegrated, but if the sub-unit is disintegrating, then the length of the actin will change. So, in a sarcomere, I have to fix the length of actin by giving some fencing, by giving some barrier, so that the length of the actin is not changing. So the fencing or the barrier which is present surrounding the actin from the tip of the actin up to the level of this Z line, there is a barrier. This protein is known as the nebulin protein. So what is the location of the nebulin? Nebulin is present from the tip of the actin up to the level of Z line. It is making a fencing surrounding the actin. If this is actin, surrounding the actin there will be fencing, that is nebulin. So what the nebulin is doing? Nebulin is basically protecting the length of actin. Length of actin is regulated by nebulin. Fine. Now if there is mutation of this nebulin protein or if there is mutation of this alpha actinin protein, both of this protein, actinin protein, will leads to a disease which is known as the nemaline myopathies. Nemaline myopathies, right? So nemaline myopathies is a mutation of nebulin, most common, or it may be mutation of alpha actinin also. Fine, okay. Now look at, I told you already that at the center of the myosin there is a line. What is the name of that line? M line. So now we look at, there is a protein which is present from the M line up to the level of the Z line, M to Z line protein, and this protein is a elastic protein. This protein is a elastic protein. So the elasticity of the muscles, whether it is skeletal muscle or cardiac muscle, elasticity of the muscle is due to presence of this protein which is connected from M line up to the Z line. This protein is known as the Titin protein. I told you in my lecture that titin is one of the largest protein in human, which has around 25,000 to 27,000 amino acid into a single protein, which has a molecular weight of 30 lakh kilodalton. So that's why this protein is very important for your MCQ, not only for the size but also for its function. It's an elastic protein of the muscle. So if you stretch the muscle will relax a little bit. Okay, muscle will recoil a little bit. This is elasticity of the muscle, and that is due to which protein? Titin protein. If there is mutation of this titin protein, you know the disease. Okay, this is also present in heart. So the dilated cardiomyopathy as well as the hypertrophic cardiomyopathy or the tibialis muscles, tibialis muscles myopathies is due to the presence of mutation of titin protein, right? So these are the in brief discussion, okay, most important protein and most important bands of sarcomere that you have to remember, right? Okay, right. Now the next question here is given that this diagram shows the length tension relationship of a sarcomere, single sarcomere. Why is the tension develop maximum between B to C? So first you analyze the curve. Whenever you are getting any curve, try to look at the x-axis. What is the x-axis? Length of sarcomere in micrometer. And what is the y-axis? Tension developed by the muscles. So along with the length of sarcomere, the tension developed in the muscle, that has been plotted here. We are finding out that initially the tension developed by the muscle is very less when the length of the sarcomere is little more than 1 micrometer. Then the tension is gradually rising, and from point number B to C, the tension is maximum, highest tension, B to C, flat portion. So the portion from B to C, when the tension is highest, this length of sarcomere is known as the optimum length of sarcomere. Optimum length of sarcomere. So what is the meaning of optimum length? The length of sarcomere at which the tension developed by muscle, the force generated by the muscles, the force generated by the sarcomere is maximum. That length is known as optimum length. So optimum length is 2 to 2.2 micrometer. I told you already in this discussion here, 2 to 2.2 micrometer. That is the optimum length of sarcomere. Okay. So this optimum length of sarcomere, after this optimum length of sarcomere, I can find out that if you stretch the muscle more and more, if you increase the length of the sarcomere more and more, then the tension is gradually reducing. Now you tell me, on which parameter the tension generated by the muscles depends on? Tension generated by the muscle depends on which parameter? At the sarcomere level. So why the tension is rising and then the tension is decreasing? Why the tension is generating by the muscle at all? You know that actin and myosin forms a cross bridge. The myosin head, okay, that's from the cross bridge with actin. More the number of cross bridge, more will be the tension generated by the muscles, right? So when suppose this is Z line, in between the myosin is there, and myosin contain myosin head like this, myosin contain myosin head like this. If more number of head is interacting with the actin, then the force generation by the muscles will be maximum. So you note down this thing, force generation by the muscles depends on number of cross bridge, okay. More the number, more will be the force generation by the muscles. So whenever the length of the sarcomere, is very less, 1.6 micrometer, the number of cross bridge, the cross bridge number is very low. Why? Because in these cases the actin will overlap with one another. Okay, when the length of the sarcomere is very less, the actin will overlap with one another, and because of that overlapping, myosin head will not be able to bind. So number of cross bridge will be lesser. But whenever you go to this length from 2.0 micrometer to 2.2 micrometer, in these cases, the maximum number of cross bridge generation will occur. The maximum number of cross bridge generation will occur. Okay, so that's why the tension is maximum. And beyond this 2.2 micrometer, again the cross bridge number will start decreasing, and because of this decreasing number of cross bridge, again the tension generated by the muscle will reduce. So basically, if I go back to this question and try to answer, then answer will be there is optimum overlap between the actin and myosin filament, optimum interaction between actin and myosin filament, right? Okay, so this is the answer of the question, that why the tension is maximum between B to C. So this tension is known as optimum length of sarcomere, okay, when this tension is generated. Fine. Okay, so the detailed version has been discussed in lecture, but I think this much is important for your MCQ. Okay, fine. Chalo. So now you try to answer this question. Most distinguishing feature between skeletal muscle and smooth muscle. How to distinguish between skeletal muscle and smooth muscle. So tropomyosin is present in both skeletal muscle and smooth muscle. Myosin is also present in skeletal muscle and smooth muscle. Actin is also present in both smooth muscle and skeletal muscle. So this is present in both the muscles. But you know that troponin is answer of this question. Troponin is only present in case of skeletal muscle and in case of myocardium, but not present in smooth muscle. So in case of skeletal muscle and in case of cardiac muscle, troponin is a calcium binding protein, but this is not present in smooth muscle. So in case of smooth muscle, we all know that the calcium binding protein, this is very important for MCQ, calcium binding protein which is present in smooth muscle, the name of this protein is calmodulin, calmodulin. This is the protein which is present in smooth muscle. It is a calcium binding protein of the smooth muscle, right? Now next question, which of the following acts to increase the release of calcium from endoplasmic reticulum? So if you look at the options, these are the basically second messenger system or some chemical signal and release of calcium from endoplasmic reticulum. These two indicating that the question is related to smooth muscles. Okay, because if it is skeletal muscle or cardiac muscle, then will develop sarcoplasmic reticulum will be there. In case of smooth muscle, the endoplasmic reticulum is the calcium storage organelle. Okay, so in case of smooth muscle, suppose this is the smooth muscle membrane. Okay, this is the membrane of the smooth muscle. There is a depression on the smooth muscle membrane which is known as the caveoli. This caveoli contain calcium channel. So this is voltage gated calcium channel, L type calcium channel, CAV 1.2. So whenever there is presence of depolarization of the membrane, the channel will open up and calcium will enter through this channel. Now this calcium which has already entered into the cell, it can releases calcium from endoplasmic reticulum, because endoplasmic reticulum contain channel. Which channel? The RYR type 3 channel is there. So whenever calcium is entering from outside, this calcium is going to stimulate this RYR channel, and RYR channel will release further calcium from endoplasmic reticulum. This mechanism is known as CICR. We have seen this mechanism in case of cardiac muscle also. Calcium induced calcium release in case of cardiac muscle also. But rather than these two mechanisms, so one mechanism is outside calcium, second mechanism is endoplasmic reticulum calcium. Now rather than these two mechanisms, there is another important mechanism in smooth muscle membrane. What is that mechanism? So smooth muscle membrane contain various receptor, the receptor for neurotransmitter, receptor for hormones, receptor for various drugs. Okay, receptors are present on the smooth muscle membrane. Now this receptor can produce a second messenger system, particularly if it is G protein coupled receptor, then it produces second messenger system. The second messenger system which is important for smooth muscle contraction is DAG, diacylglycerol, and IP3, inositol triphosphate. So whenever this receptor is stimulated by certain ligand, Then the receptor is a G protein coupled receptor which is producing second messenger system DAG and IP3. DAG has a different role. It will activate the different protein kinase. Now this IP3 inositol triphosphate has a receptor on this endoplasmic reticulum membrane. There is a receptor, okay, for this IP3. So this is known as the IP3R, IP3 receptor. This IP3 receptor is basically a calcium channel. So this is a channel. Which type of channel? Calcium channel. So whenever the IP3 is produced in the cell, this IP3 is going to stimulate the IP3 receptor, and via this IP3 receptor further calcium will enter in the cytoplasm. So this is known as IP3 mediated calcium release from endoplasmic reticulum. So please look at this question. Obvious answer is 125. Extremely sorry, that is inositol triphosphate is the obvious answer here. 125 dihydroxycholecalciferol, this is nothing but vitamin D3. Obviously that is not going to release the calcium here, okay, obviously not the parathyroid also. And diacylglycerol, I told you, although this is part of the second messenger system, but it activates protein kinase, not the calcium release. So only answer that is possible here is inositol triphosphate. Got it? So this is about two important questions regarding your smooth muscle physiology. Okay. So now next question which is presented here is related to skeletal muscle only. Motor unit consists of. Okay, motor unit consists of. So motor unit meaning is that one neuron. Okay. So the neuron will have an axon. This axon will be divided into multiple axon terminal, and each of these axon terminal will supply a single skeletal muscle fiber or skeletal muscle cell. So because there is three subdivision, because there is three axon terminal here in this diagram, each of these three terminal will supply separate skeletal muscle. So how many skeletal muscle fiber will be supplied by this single neuron? 1, 2, 3. So now this single axons, right, and this three muscle fiber is making a unit, and this unit is known as a single motor unit. So basically it's a neuron or it's a single axon, and the number of skeletal muscle fiber supplied by these axons is known as motor unit. So motor unit means one spinal motor neuron and a muscle fiber supplied by it, right? So this is the definition of motor unit, right? Now here it is written one sensory neuron and the muscle. Sensory neuron is not going to supply the muscle. Multiple spinal nerve and one muscle fiber. No, this is not the concept. One neuron, multiple muscle fiber. Sensory receptor and the single axon supplying them. So this is also not my answer. But apart from this motor unit, you also have to remember that what is the definition of receptive field? Receptive field. What is the definition of this? So receptive field is defined in terms of sensory neuron. Suppose this is a sensory neuron. Okay, this is a sensory neuron which is connected from the level of your skin up to the level of the spinal cord. So sensory neuron means it is connected with the receptor. A single neuron can senses or can take up sensation from which area of your skin, that is known as the receptive field. Suppose this neuron, it can take up the touch sensation from this area of the skin. So this area will be known as the receptive field of this neuron, right? Receptive field of this neuron or receptor. Right? Okay. So ये हो गया question. Now the second question, which of a single motor unit is activated? When this single motor unit is activated, then all these three muscle fiber will contract simultaneously. This is known as twitch contraction. So if I stimulate this single motor neuron, all of these three muscle fiber will contract simultaneously, and it will produce a muscle twitch, muscle contraction. This is known as fasciculations. So all of you know the fasciculation is a pathological condition. What happens when a motor neuron is about to die? Suppose this motor neuron is about to die, right? So this is a motor unit. Motor unit means it is supplying three muscle fiber, right? So when this neuron is about to die, there will be spontaneous activation of this neuron. Automatic activation will be there. And whenever there is automatic activation, all these three muscle fiber, they will contract simultaneously, they will produce a twitch, right? This spontaneous involuntary contraction of a single motor unit is known as fasciculation. Fasciculation, right? So fasciculation is equal to single motor unit contraction. Motor unit is contracting as a whole. But when the neuron is completely dead, suppose there is a degeneration of this axon is degenerated. Now these three muscle fiber, they are not part of the unit, because the neuron is now disconnected from the cell body. So neuron is dead. When the neuron is dead, then all these three muscle fiber, they will behave individual muscle fiber. They will behave like an individual muscle fiber because there is no unity. So now this individual muscle fiber will contract involuntarily. So this one muscle fiber, they can contract of its own. The second muscle fiber, it can also contract individually of its own without any unity, and the third can also contract individually. Single muscle fiber, when it is contracting individually and pathologically, involuntarily, then contraction of this single muscle fiber is known as fibrillation. This is known as fibrillation. So please remember, fibrillation is equal to single muscle fiber or single muscle cell is contracting individually, okay, and spontaneously. But fasciculation means it is a motor unit which is contracting involuntarily and automatically. Okay, so this is the difference between this fasciculation and fibrillation. Now this chorea and tremor. Chorea and tremor, we all know they are the involuntary movement, but this involuntary movement is due to contraction of multiple motor unit, not a single motor unit. Single motor unit involuntary contraction is known as fasciculation, right? Chorea, tremor, all other kind of abnormal movement is due to contraction of multiple motor units. Got it? Okay, very good. Now this question, again this is an image based question and very famous question. So whenever the question is asking you the calculating the titannizing frequency, okay, so the detailed version I am not going to discuss here. The formula for calculating titannizing frequency, okay, so titannizing frequency formula is 1 upon contraction period duration. Just remember 1 upon contraction period. So what is 1? 1 is 1 second upon contraction period duration. So 1 second is equal to how much millisecond? 1000 millisecond. So contraction period duration you have to take in millisecond, right? So now you look at this diagram. So this diagram, this is the contraction of the muscle, and then you can find out that this is the relaxation of the muscle. Contraction and relaxation. This contraction and relaxation, if you record, then this is known as twitch. This is a single twitch, contraction and relaxation. As a combination, this is known as simple muscle twitch. Okay, muscle ka contraction and relaxation, right? So this is the end of contraction. From there, if I drop a perpendicular, it is falling near to this 40 millisecond. That means if I have to find out what is the contraction period duration of this muscle twitch, then it is approximately 40 millisecond. So simply I will put 1000 millisecond here upon 40 millisecond is the duration of the contraction period. So if you divide this, it will be 20 Hertz. So answer of this question is 20 Hertz is the titannizing frequency of this skeletal muscle fiber. Got it? So this is all about the nerve muscle physiology in brief that you have to read before your exam. Respiratory physiology. So first we are starting with the MCQ. So the MCQ is maximum airflow resistance is seen in. So this is one of the important questions and concept in respiratory physiology, that whenever you are taking breathe in or breathe out, the resistance to airflow is maximum at which area. So please remember the answer to this question is bronchus. So actual answer will be medium to large size bronchi, right? So this is your actual answer, that maximum airflow, resistance to airflow is at this segment. But suppose this medium to large size bronchi is not given in the choices, then anatomically these medium to large size bronchi are nothing but segmental segmental and lower bronchus, right? So please remember that if the lower or segmental bronchus is given, then it can also be an answer. So if your total resistance to airflow is 100%, so this segment is responsible for 40% of the total airflow resistance. Got it? Now the other option that is given in this choice is, like for example, this respiratory bronchiole, the alveolar duct, these terminal bronchioles, they are the small size airway. Remember that small size airway responsible for only 20% of the total airways resistance. Got it? So 40%, that is maximum, is due to medium to large size bronchi, 20% is due to small airways, and another 40% of the airway resistance is due to upper airway. You know, upper airway means the trachea, the larynx, the pharynx, they constitute another 40% of the airway resistance. But always it is said that whenever the question is maximum airflow resistance, your answer is medium to large size bronchi. Now sometimes this medium to large size bronchi may not be given in the choices. Even the segmental lower bronchus also may not be given in the choices. You know, in respiratory physiology, we classify the lower respiratory tract into a classification system which is known as the Weibel's systems, Weibel's classification system. So where trachea is division number 0 and the first bronchus is division number 1 and so on up to the level of alveoli, and alveoli is division number 23. That is in brief. Okay, the detailed version is not required. But according to the Weibel's classification, if I ask you that this bronchus, which you are saying that this is the site of maximum airway resistance, this is which segment of Weibel's classification? Your answer will be division number 4 to 5, right? So please remember the division number 4 to 5 is the area where the airway to airflow to resistance to airflow is maximum. So look at this question, look at this graph here. So where y-axis is the resistance to airflow and x-axis is the airway generation according to number. So this is 0 number, this is 5, this is 10, 15, 20, and alveoli will be division number 23. As you can find out here, the maximum airflow resistance is here. So if I drop a perpendicular from this region, you can easily find out that this is almost division number 4 to 5. So that's why we say that maximum airflow resistance is division number 4 to 5 according to Weibel classification. This 4 to 5 division correspond to medium to large size bronchi or segmental or lower bronchi. Got it? So this is the first thing. Now second thing, on your right hand side, another graphical representation is given where velocity of the airflow. So when the air is flowing through the respiratory system, if I ask you velocity is maximum at which divisions, right, then your answer will be velocity of airflow is maximum in and around division number 3. So as you can find out here, so this is the maximum airflow velocity, this is division number 3. Always remember that the velocity of the airflow is inversely proportionate to total cross-sectional area of that segment. So obviously, if the velocity to airflow is maximum at division number 3, then what will happen? The cross-sectional area, the total cross-sectional area that I am talking about, that will also be minimum in and around division number 3. So division number 3 means trachea is the 0 division, then first major bronchus is the division number 1, then another division will be there, then third division, that is the division number 3. So that is the area where the cross-sectional area, total cross-sectional area is minimum. That's why the velocity of airflow is maximum. Got it? So at least you remember these two important biophysical property in respiratory system. Now next question, if the lung was allowed to recoil without the chest wall, so very important property regarding the lung and chest wall and your elastic tissue which is present in the lung. So question is, if the lung was allowed to recoil without chest wall, means if you remove the chest wall, what will happen? We all know that lung will be fully collapsed. Right. Now, when the lungs are fully collapsed, do you think that the volume inside the lung is 0? Answer is no. Okay, so whenever this alveoli is going for collapse, what will happen? It will collapse, but before the full collapse of this alveolus, what will happen? The smaller diameter bronchioles will get collapsed earlier than alveoli. That's why even after the full collapse of both lungs, some of the air will be still entrapped within the alveoli, collapsed alveoli, and this air which is still remaining inside the alveoli, this is known as the minimal volume. Minimal volume, it's not very less, it is approximately 500 ml is the minimal volume. So question answer here will be minimal volume. So what is minimal volume? After full collapse of both the lungs, the minimum air which remains inside the collapsed alveoli is minimal volume. That is not zero, that is approximately 500 ml, and this is the answer of this question. Now try to understand here. So if I show you a diagram here, so what you are finding out here, there are different sizes balloon, right? So suppose our respiratory system behaves like a balloon. Whenever you take a maximum inspiration, at the end of the maximum inspiration, the total volume of air which is present inside your lung is known as the total lung capacity, right? Your both lungs are fully aerated, and maximum volume that is present or entrapped inside your both lung is the total lung capacity. Now from the total lung capacity, when you remain in resting condition, when you reach at resting condition of the lung, so what is resting condition? Resting condition of the lung is that condition where your respiratory muscles are fully relaxed. What is that condition? If you hold your breath at the end of normal expiration, at the end of normal expiration, not the forceful expiration, at the end of normal expiration, then that condition is known as the resting condition. So in resting condition, I can easily understand that the residual volume will remain inside my lungs, as well as the expiratory reserve volume that will also remain inside my lung, and combination of these two volume is nothing but functional residual capacity. That's why we say that the resting lung volume is nothing but FRC. So from the fully aerated lung, if you go towards the resting condition, you are reaching a volume. Okay, it's not actually volume, it is a combination of volume which is nothing but FRC. FRC is the resting condition of the lung. Now from here, if you go on forceful expiration, what will happen? You will reach to a smallest volume. Okay, at the end of full expiration, at end of maximum expiration, the volume that you will be reaching is known as the residual volume, right? So when your lung and chest wall both are intact, this is the minimal volume this is the minimum volume that you can reach, and this is the maximum volume that you can expand to your lung, right? But when your chest wall is removed, then the lung will go for full collapsed of lung when the chest wall is removed, and in this condition the volume which still remain inside this alveoli is known as the minimal volume, which approximately 500 ml. Now rather than removing the chest wall, if I remove lungs, if I remove both the lungs, what will happen to the chest wall? That is my question. Getting my point? So if I remove the chest wall, what will happen? The lung will get full collapsed, and the volume which is still remaining is known as minimal volume. Now if I reverse the question, that rather than removing the chest wall, if I remove the lung from the chest wall, so what will happen to the chest wall? Chest wall will get collapsed or expanded. The chest wall will be expanded, but after expansion, what will be the volume of the chest wall? The volume of the chest wall will be 70% of the total lung capacity. Getting my point? So in between these two volume, in between this FRC and in between this TLC, if you remove the lungs, the chest wall will attain a volume which will be in between these two volume, FRC and TLC, and that is approximately 70% of the total lung capacity. Got it? So look back at this question. So if the question is lung was allowed to recoil without chest wall, then your answer is minimal volume. But if the question is if the chest wall is allowed to recoil without lung, then the volume of the chest wall will be 70% of the total lung capacity. Got it? So this is one of the important concept. I have explained the detailed version in lecture. Now next question. Now next question is very easy. I am 100% sure that all of you will be able to answer. So in children with respiratory distress syndrome, there is deficiency of which of the following? So basically this is the question, which is nothing but infant respiratory distress syndrome, IRDS, right, which is previously known as HMD, hyaline membrane disease, right? So hyaline membrane disease or infant respiratory distress syndrome. We all know that this disease is mainly seen in case of premature infant because of the deficiency of surfactant. So basically the question here they are asking that what is the main lipid which is present in the surfactant. So we all know the surfactant is mainly composed of lipid. All the proteins are there, but the main lipid is the phospholipid. Within the phospholipid, the main phospholipid is DPPC, that is dipalmitoyl phosphatidylcholine, right? So basically we have to remember certain information about surfactant, important information, very important. So try to concentrate here. So it is mainly composed of lipid. Also protein is there, 10% protein is there. Now within this lipid, the main lipid is the phospholipid. And within the phospholipid, the main phospholipid is dipalmitoyl phosphatidylcholine, DPPC, also known as dipalmitoyl lecithin. Please remember both the name because they has been asked in separate MCQs. Now the second most common phospholipid which is present in surfactant is phosphatidylcholine, right? So first you remember this DPPC, which is also known as dipalmitoyl lecithin. If that is not given in the choices, then phosphatidylcholine is the second option, right? Now the different types of protein which is present in surfactant is SPA, SPB, SPC and D, different types of protein, not very important for MCQ. Now because the surfactant is very essential for lung maturation, we always want to know that when the production of surfactant begins in the lung by type 2 pneumocyte. So the production begins in and around 20 to 24 weeks of gestation in the fetal lung, but the mature surfactant is produced in and around 35 weeks of gestation. So that's why we say that if the baby is born prematurely before 35 weeks of gestation, then mature surfactant may be deficient in the lung and the baby may suffer from this infant respiratory distress syndrome or hyaline membrane disease, right? Now it appears, this for surfactant appears in the amniotic fluid between 28 to 32 weeks of gestation. Why it is important? Because sometimes we do amniocentesis and we try to assess whether the fetal lung is mature or not. So in that cases, if you are doing amniocentesis, we measure the lecithin. So this is the phospholipid component of the surfactant. So we measure the ratio between lecithin and sphingomyelin. If the ratio between lecithin and sphingomyelin is greater than 2 to 2.5, okay, 2 to 2.5, then we say that the mature surfactant is already present in the lungs, means lungs are fully mature, baby can be born, right? But if it is less than that, then the lungs are not fully matured. So these are the crucial information that you have to remember, must have to remember for your upcoming MCQs, right? Now another MCQ, see, in the same NEET PG exam, another MCQ related to the same disease. Which of the following cells are deficient in premature infant with respiratory distress syndrome? So again the same question, IRDS, infant respiratory distress syndrome, right? So surfactant is deficient. We all know surfactant is produced by type 2 alveolar cell, type 2 pneumocyte. So all of you, I hope, remember that this type 2 alveolar cell or type 2 pneumocyte, it's not only produce surfactant, obviously it produces surfactant, okay, obviously it produces surfactant, but apart from surfactant, I hope you remember it also produces alpha 1 antitrypsin. Alpha 1 antitrypsin. I hope all of you know that if there is deficiency of this alpha 1 antitrypsin, then what will happen? The lung, okay, will suffer from or the person will suffer from pan-acinar emphysema, right? The whole lung will be destroyed, that is pan-acinar emphysema. So at least you remember this surfactant and alpha-1 antitrypsin, right? Now this type 1 alveolar cell or the type 1 pneumocyte, this cell is responsible for gas exchange, we all know. But apart from gas exchange, you have to remember that aquaporin channel 5 is also present on type 1 pneumocyte, which is responsible for water transport. Okay, at least remember the function of this type 1 and type 2 pneumocyte. Now in my main classes, I told you that apart from type 1 and type 2 pneumocyte, there is a type 3 pneumocyte also. This is the cell which contain many microvilli on the surface, and because of this cell is known as the brush cell of the lung. But what is the function of this brush cell? It is still not known. Okay, so these are all important things that you have to remember from this area. Now coming to the next question. So the question here is a little bit difficult. So the question is related to the ventilation perfusion ratio of the lung. So VA is the ventilation. A stands for alveolar ventilation. So this is basically alveolar ventilation. Okay, and Q is the amount of blood flow. So this is nothing but your perfusion. So the question is asking about the ventilation perfusion ratio. So normally we know that normally VQ ratio is 0.8. This is the average VQ ratio. But we also know that in a person who is in upright posture, in sitting or in standing posture, VQ ratio is maximum at the level of apex, which is 3.3, and VQ ratio is minimum at the level of base, which is 0.6. So please remember all this number. That normal VQ ratio is the average ratio, which is generally seen at the middle part of the lung, okay, in an upright person also. But if I ask you VQ ratio is maximum in which area? Apex, that is 3.3, and VQ ratio is minimum in which area? Base of the lung, that is 0.6. Now the question here is VQ ratio is infinity. Okay, so obviously this is a pathological condition. Let's see. So suppose this is the trachea. It is dividing into bronchus and multiple segment. For my understanding purpose, I am just drawing a schematic diagram. So this is one bronchioles with an alveolus, right? Bronchus, bronchioles and alveolus, and the blood supply to the alveolus is here. So this is the capillary which is supplying the blood here, right? So this is the perfusion. Capillary means blood flow, that is a perfusion, and ventilation means the airflow which is happening through here. So if I take a VQ ratio of this alveoli, right, and suppose the perfusion is completely zero. So why the perfusion will be completely zero? So suppose there is a embolus, there is an embolism which is obstructing this capillary. So this is nothing but an embolism. So whenever the embolism is blocking the capillary, so the perfusion to this alveoli is zero, but the ventilation will continue. So V is normal, but your denominator is 0. So we all know that something upon 0 is nothing but infinity. So now we can understand that when the VQ ratio will be infinity, if the blood flow to an alveolus is completely blocked, then the VQ ratio will be infinity. On the other hand, suppose there is another bronchioles with an alveolus here, and here rather than blocking of this capillary blood flow, so suppose this capillary blood flow is absolutely normal, right? It is continuing, but there is problem in airflow. So suppose there is a foreign body, or suppose there is a lymph node which is obstructing these small bronchioles. So what will happen at the level of these bronchioles, at the level of this alveoli, airflow will be 0. So in these cases, if I take a VQ ratio of this alveoli, so ventilation is 0, perfusion is maintained normally, so whole VQ ratio will be 0. Getting my point? So normal VQ ratio is 0.8. So this is to extreme version. The VQ ratio can be 0 when ventilation of the alveolus is completely 0, and VQ ratio can be infinity when the perfusion to the alveolus is completely 0. Now you try to understand, when the perfusion to the alveoli is completely blocked, what will happen? Whatever air which is entering at the level of your respiratory system, whatever air which is entering at the level of your trachea from the atmosphere, that air will enter in the alveoli without any absorption of gases or without any addition of carbon dioxide in this alveolar air. Getting my point? Because your capillary air completely blocked. So whatever air is entering at the level of this trachea or conducting zone of the airways, the same air will enter in the alveoli, but after entering in the alveoli, there will be no exchange of gases. So what will happen? What will happen to the composition of this alveolar air? I can easily understand that the composition will be equal to the conducting zone air composition. Conducting zone air composition is known as the dead space air. All of you know that the dead space air has a partial pressure of oxygen which is approximately 149 millimeter of mercury, and partial pressure of carbon dioxide is 0.3 millimeter of mercury. Got it? So if I ask you what will happen to the composition of the alveolar air in case of infinity VQ ratio, your answer will be composition will be same to same with that of the dead space air or inspiratory air. What is that composition? Partial pressure of oxygen is 149 and partial pressure of carbon dioxide is 0.3. Now let's go back to this MCQ and try to analyze each and every statement. So when VQ ratio is infinity, pressure of oxygens in the alveolar air is less than dead space air. No, it is not less than. It is same to same with that of the dead space. So this less than is not. It is the equal to dead space air. Partial pressure of oxygen and carbon dioxide are equal. Obviously they are not equal. Partial pressure of oxygen I told you 149 and partial pressure of carbon dioxide is 0.3. So this is also not equal. When the partial pressure in the alveolar oxygen is 159 and partial pressure of carbon dioxide in the alveoli is 40, so this 40 is completely wrong. Even this 159 is completely wrong. It will be 149, right? So this is also a false statement, right? No exchange of carbon dioxide and oxygen is possible in this alveoli. So this is absolutely true statement. Got it? So this is my answer. Now rather than VQ ratio infinity, if the question is given that VQ ratio is 0, so what will happen? In these cases, what will happen to the composition of this alveolar air? Please remember that in these cases, initially the gas exchange will continue. But whenever this venous blood partial pressure of oxygen is 40 and venous blood partial pressure of carbon dioxide is 46, which this partial pressure becomes same to same with that of the partial pressure of oxygen in alveoli and partial pressure of carbon dioxide in the alveoli. When they become equal to one another, after that no gas exchange will be possible. Getting my point? Obvious thing that the gas exchange occur by the process of diffusion. If the partial pressure is same to same between the alveoli and venous blood, then there is no question of diffusion. So initially diffusion will continue, but later on diffusion will stop. When the diffusion will stop? When the composition of this alveolar air, whenever the composition of this alveolar air is same to same with that of the venous blood composition. And venous blood composition means, what is the composition? We all know. Partial pressure of oxygen is 40, partial pressure of carbon dioxide is 46. Am I clear? So this is one of the important understanding that you must have to remember. Okay, let's move ahead. So next topic is compliance. So all of you know that compliance you have to read a little bit, particularly the mathematical formula of compliance, that is delta V upon delta P. Now what is delta V? It is the lung volume change. Suppose I am saying that during inspiration I am taking a 600 ml tidal volume. So I can easily understand that during inspiration, if you are taking 600 ml of air inside your lung, then how much is the expansion or how much is the volume change inside your lung? 600 ml, right? Now whenever you are taking this inspiration, suppose your intrapleural pressure changes from minus 4 millimeter of mercury to minus 8 millimeter of mercury. We know that during inspiration, intrapleural pressure become more negative. So what is the delta P in this condition? Delta P is 4 minus 8. That means I can understand 4 millimeter of mercury or 4 centimeter of water, whatever you say. So this is 4 centimeter of water. So if I divide these two, then what will happen? This will be nothing but 150 ml per centimeter of water, and this is nothing but compliance. So what is the meaning of compliance? Compliance means it is the volume change of the lung per unit change of pressure. Okay. Now normally, if the question is what is the normal compliance of lung and chest wall, you have to remember three separate things. Normal compliance of chest wall is in and around 200 ml per centimeter of water. Normal compliance of lungs only lungs, okay, it is 150 to 200 ml per centimeter of water. And normal compliance of lung plus chest wall means whole respiratory system. If the lung and chest wall both are intact, then the compliance of the combined respiratory system or compliance of the whole respiratory system is very less, that is 85 ml per centimeter of water. This you have to remember. Okay. Now we know that compliance increases in different pathological condition. Like for example, look at here. So this is the normal compliance curve. This is the normal compliance curve. I can easily find out here that one curve is located above this normal compliance curve. This is high compliance lung. So please remember, this emphysema is one of the important disease condition that we have to remember, where the compliance of the lung is very high due to rupture of the elastic tissue of the lung. So emphysema is a prototype of the COPD, but please remember, all COPD, they do not have high compliance. The emphysema typically have high compliance. Bronchitis compliance is almost normal. Okay. Asthma compliance is little higher, but emphysema, the compliance is typically very high. Now on the other hand, if you look at the low compliance condition, so here this is the curve where the compliance is low. How do I understanding? How am I understanding? It is below the normal curve. So below the normal curve means it is a low compliance. Remember, not only this fibrosis of the lung, any cases of restrictive lung disease, will have low compliance. Got it? So any cases of restrictive lung disease, whether it is pulmonary restriction or extrapulmonary restriction, it will have low compliance. But any cases of COPD will not have high compliance. Only the emphysema will have typically high compliance. Bronchitis compliance is almost normal. Got it? So these are the important things that you have to remember about compliance. Now next is one of the important area in the respiratory system, that is the measurement of the lung volumes and capacities with the help of spirometer. So we all know that the instrument that is typically used for measuring lung volumes and capacities is spirometer. So in spirometer, we all know that the typical instruction that is given to the subject is take normal inspiration, expiration, inspiration, expiration. So inspiration is upward, expiration is downward. So whenever the person is taking normal inspiration and expiration, the volume of air which is entering in the lung or going out of the lung is tidal volume, which is 500 ml. Now if the person is taking a deep inspiration, so the maximum air which he is taking with maximum effort, that is known as the inspiratory reserve volume, which is 200 ml. With maximum expiration, the maximum air which can go out of this lung, this is known as the expiratory reserve volume. Typically it is 1000 ml. And even after full expiration, we all know that there is one volume which always remain inside the lung, which you cannot wash out from the lung. This volume is known as the residual volume. So please remember that you must have to remember the normal value of all of these volumes. These are the statics volume. Apart from static volumes, you all know that there are some capacities also, like for example inspiratory capacity, which is TB plus IRV, vital capacity, which is TB plus IRV plus ERV, right? FRC, which is RV plus ERV, and TLC. TLC means basically visceral capacity plus residual volume. So you can understand from these lung volumes and capacities that all the lung volumes and capacities can be measured with the help of spirometer except your residual volume. You cannot measure residual volume with the help of spirometer. So whenever the residual volume is there in any capacities, like for example this TLC and FRC, so FRC also cannot be measured directly by spirometer, and TLC also cannot be measured by spirometer directly. So it is the residual volume which cannot be measured directly. So whenever in any capacities residual volume is a part, that capacities will also not be measured with the help of spirometer. So the pertinent questions is asked that what are the methods by which we can measure the residual volume. So please remember that the measurement of residual volume is done by number one, helium dilution method. Helium dilution method, this is one of the most common method for residual volume measurement. Nitrogen washout method, okay, multiple breath nitrogen washout method is also used, and the third one is the body plethysmography. It is said that this body plethysmography is the best method for measuring the residual volume. Got it? So what is residual volume? You all know that residual volume is that volume which remain inside the lung even after forceful expiration. So question is why it is not going out of the lung? Because you know that at the end of forceful respiration, almost all the alveoli, they get collapsed, they get closed off because of the collapse of the bronchioles. So what happens at the end of forceful expiration? At the end of forceful expiration, when all alveoli are closed off due to collapse of the bronchioles, when all alveoli are closed off, in this condition, the remaining volume in the lung, the remaining volume which is present in the lung is known as the residual volume, right? Why I am saying this definition? Because you have to understand another definition which I have discussed in detail in my main lecture, that is known as the closing capacity. So during forceful expiration, right, when only the basal alveoli are closed off, basal alveoli are closed off, but the apical alveoli are not yet closed. Only the basal alveoli are closed. So you can easily understand that during the forceful expiration, first the basal alveoli will get closed off, then the middle part, then the apical alveoli will get closed off. When all alveoli are closed off, the remaining volume in the lung is residual volume. When only basal alveoli are closed but apical and middle part alveoli are still open, in this condition the remaining air in the lung is known as closing capacity. It is known as closing capacity. Closing capacity is equal to residual volume plus closing volume. So I can easily understand that the closing volume is a little greater than residual volume. Okay, closing capacity is equal to residual volume plus closing volume. Please note down this closing capacity. Closing capacity is also measured by this nitrogen washout method, but single breath nitrogen washout method. Got it? So these are the things that you have to remember about static lung volumes and capacities. Now coming to the dynamic lung volumes and capacities. So all of you know that in case of dynamic lung volumes and capacities, what we measure? We measure the time into x-axis and we measure the volume into y-axis. Here we instruct the subject like this. First you take normal breathing, breathe in and breathe out, then take a deep inspiration, then do a forceful expiration. So whenever the person is doing a forceful expiration, the curve will go like this, the curve will go like this, right? And we measure that what is the beginning point of this maneuver. So this is the beginning point of the maneuver, and we also measure what is the ending point of this maneuver and what is the time taken by this subject to expire the air completely. So suppose this is the 3 second, total 3 second has been taken by the subject. Now I have to measure that within this 3 second, what is the total volume that the subject has expired. That volume, what the subject has expired, that will be known as the FVC, force vital capacity. So force vital capacity is the total volume that the subject has expired after taking a deep inspiration. Now if I say FEV1, then I have to measure that within 1 second period, how much volume the subject has expired. How I can measure that? So from this 1 second point, you have to make a perpendicular on this curve, and where this curve is cutting, okay, the cutting point or the junction point, you have to measure that what is the volume from the beginning of the maneuver up to this, and this volume will be known as the FEV1, right? So all of you know that normally this FEV1 is a volume and FVC is also a volume, but if you take the ratio between these two volume, then it is approximately 80%, right? And if you measure the FEV2 upon FVC, this is approximately 95%, and if you measure the FEV3, okay, upon FVC, means it is 99 to 100%. What is the meaning of this? Meaning is that at least 3 second time is required for complete expiration after taking a maximum inspiration. So to expire this FVC volume, how much time you require? At least 3 second time is required. Okay, so this way we measure the dynamic lung volumes and capacities. Now static lung volumes and dynamic lung volumes and capacities, whenever you measure all of them, then you can classify the various respiratory diseases. Okay, and all of you know that this respiratory disease means obstructive disease and restrictive disease. The typical examples of the obstructive respiratory disease is emphysema and asthma, and typical examples of the restrictive is parenchymal restriction and extraparenchymal restriction like myasthenia gravis. Now the difference has been given, but what is the main thing that you have to note down from this difference? Look at, you have to remember that if you want to diagnose a case of obstructive disease, the total lung capacity must be higher. Okay, total lung capacity must be higher. It may be a little bit normal, but typically it is higher. But other than total lung capacity, residual volume has to be higher always. Okay, so this is the two important thing, total lung capacity and residual volume. Between these two, I must have to remember that residual volume must has to be higher than normal if I want to diagnose a case of obstructive disease. In case of restrictive disease, there are other points, but if I want to diagnose a case of restrictive disease, total lung capacity must be lower than normal. See, residual volume may be higher, may be lower, okay, but total lung capacity has to be lower if you want to diagnose a case of restrictive disease. Okay, now apart from that, if you look at the FVC, that is the force vital capacity, and FEV1 as an individual volume, both FEV1 and FVC will be reduced in all of these disease conditions. See, in all of them it is reduced, whether it is FEV1 or FVC, everything is reduced. But if you take a ratio between FEV1 and FVC, then FEV1 reduced much more than that of the FVC. That's why the whole ratio is reduced in case of obstructive disease. Whole ratio may be increased or may be normal in case of restrictive disease. So obstructive disease means ratio has to be lower. But restrictive disease means ratio may be normal, ratio may be higher. Okay, ratio may be normal, may be higher. So this way you have to remember that the classification of these two disease condition based on different lung volumes and capacities. Now apart from that, the last 2 point is written airway resistance. In case of obstructive disease, obviously airway resistance will be high. In case of asthma, airway resistance will be more higher. In case of restrictive disease, airway resistance will be normal. In case of extrapulmonary restriction also, airway resistance is normal. Diffusion capacity of the lung will be reduced in case of obstructive disease. It is little higher in case of asthma. It is less in case of restrictive disease, whether it is pulmonary restriction or extrapulmonary restriction. So these are the things that you have to remember between these two diseases. Now we have seen the static lung volumes capacities and dynamic lung volumes and capacities. But apart from this, you know that there is something which is known as the flow volume loop of the lung. Okay, so this is known as the flow volume loop of lung, right? So in this loop, what we plot the volume in the x-axis and flow in the y-axis. So y-axis will denote the flow in both way. Okay, it will denote the flow and x-axis the volume. Now first you trace the normal flow volume loop. So normal flow volume loop during expiration, it will go like this, smooth downfall, and during inspiration it will go like this. So I can easily understand that inspiration means it is the lower portion of the curve. So this is the inspiratory portion of the curve, okay, and expiration is above the baseline. So this is the normal curve. Got it? Okay, this is the normal curve. Now in comparison to normal curve, I can find out one curve here, this blue color curve. Actually the blue color curve is not complete. This inspiratory portion has not been drawn here. Only the expiratory portion is drawn because that is more important. So I can find out here in this curve that TLC is more than that of the normal. So this is the TLC point. In case of this blue color curve, the TLC is higher. This is the TLC point. And there is a depression. There is a depression in the expiratory portion of the curve. This is typically known as scooped out appearance of the curve, and this is typically of obstructive lung diseases, typical of obstructive lung diseases. Got it? So scooped out appearance of the curve along with higher TLC than normal is typical of obstructive lung diseases. This is the flow volume curve. Now in case of restrictive lung diseases, the overall curve will be narrow. So you have to remember the curve will be narrow. Narrow means if you look at the normal curve is spreaded like this. The normal curve is spreaded like this. See, this is the normal curve. Okay, it has a long broad base. But if you look at this red color curve, so this is the inspiratory portion and this is the expiratory portion. So I can find out this red color curve is narrow, as well as this brown color curve is also narrow. So both of this curve is taken from restrictive disease patient. But this type of restriction where the curve is narrow but it is located inside the normal curve, this is typical of restrictive disease but extraparenchymal restriction. So RE stands for restrictive disease but extraparenchymal restriction. It is extraparenchymal restriction. And this typical brown color curve which is drawn here, this typical brown color curve, okay, so this is also a narrow curve, but this is located outside the normal curve. Outside the normal curve means here the residual volume is lower than normal, and this is typical of restrictive disease patient with pulmonary restriction, Got it? So please remember that normal curve and two other curve I have to remember. One is the scooped out curve, that is obstructive disease, and one is narrow curve, that is a restrictive disease. Now in this narrow curve, if the narrow curve is within the main curve, means where the residual volume is higher than normal, then that is the extraparenchymal restriction. But where the residual volume is below the normal, okay, then that is known as the parenchymal restriction. So this is in brief the detailed version. What is the reason of all this I have discussed in my main lecture classes. You can follow from there. Okay. Now, apart from this parenchymal and extraparenchymal obstructive disease or restrictive disease, the upper airways obstruction can also be diagnosed with the flow volume loop. Upper airways obstruction. So, upper airways obstruction can be of fixed type or it can be of variable type. Whenever I am saying upper airways obstruction is fixed type, it means the obstruction will affect the inspiratory phase of respiration also, as well as it will also affect the expiratory phase of respiration also. So normally we have already seen that the curve is smooth on. The curve normally looks like a smooth curve like this. So this is the normal curve. But if I look at this curve which is given in this diagram, I can find out that there is a flat portion in the expiratory portion also and the flat portion in the inspiratory portion also. This is typically known as a box shaped curve. So whenever you are getting a box shaped flow volume loop, then it indicates that fixed upper airways obstruction is there, typically by foreign body or scarring of the airways or enlarged thyroid gland. Got it? Now, whenever I say variable obstruction means either the inspiration will be affected or the expiration will be affected. So variable intrathoracic obstruction, so inside the thoracic inlet the obstruction is there, and variable extrathoracic obstruction, outside the thoracic inlet the obstruction is there. If the obstruction is extrathoracic and variable, remember extra means inspiration will be affected, inspiratory phase will be affected, and variable intrathoracic obstruction means expiratory phase of respiration will be affected. So that's why you see here that there is a flat portion in the expiratory phase here and there is a flat portion in the inspiratory phase here. But the expiratory phase is a smooth here and the inspiratory phase is smooth here, right? So this way you have to remember that if the variable extrathoracic obstruction, what are the examples? Paralyzed vocal cord, enlarged lymph node, flavipharyngeal muscles, obstructive sleep apnea, all of this condition will have a flat portion in the inspiration. But intrathoracic obstruction, like for example commonly tumor or tracheomalacia, the inspiratory portion is smooth but expiratory portion is flat. So this is typical of variable intrathoracic obstruction. So this is all about your lung volumes and capacities that you have to revise quickly. Okay. Now after this we are going to discuss this OHDC, oxygen hemoglobin dissociation curve. So all of you know that this is one of the important topic in every alternate exam, right? So look at the question here. All of the following will shift the oxygen dissociation curve to the right except. So we know the causes of the right shift of the curve. Okay. Increase H plus ion. Yes, this is a cause of right shift. Increase carbon dioxide, hypercapnia. It's also a cause. Increase 2,3-DPG is also a cause. But fetal hemoglobin, we all know that in case of fetal hemoglobin, there will be left shift of the oxygen hemoglobin dissociation curve, right? So you look at this oxygen hemoglobin dissociation curve. So if you look at this curve, all of you know that this is sigmoid shaped curve. Okay. So the sigmoid shaped curve, the 100% saturation of this curve require at least 120 millimeter of mercury partial pressure of oxygen, and 50% saturation of hemoglobin require at least 26 millimeter of mercury partial pressure of oxygen. So this 50% saturation of hemoglobin require how much partial pressure of oxygen? 23 to 26. This is known as P50 of hemoglobin. So what is P50? 50% hemoglobin saturation require how much partial pressure of oxygen? Your answer is 23 to 26 millimeter of mercury. If there is a right shift, this P50 will increase. P50 will be higher. Not only that, there will be increase a release of oxygen at the level of tissue, and there will be decrease affinity of oxygen for hemoglobin. Got it? So these three things that I have to remember about the right shift. Now what are the causes of right shift? We have discussed this in detail in main lecture, but here quick revision. So please note down: increase temperature, increase carbon dioxide, increase H plus ion acidosis. All of this will causes right shift. Okay. Now this increase carbon dioxide or increase H plus ion causes right shift of the curve. This is one part of the Bohr effect, right? Okay. So it is written here that during exercise, why there is right shift? There are two causes. That during exercise there is increased temperature, which is a cause of the right shift of the curve. During exercise there is also increases 2,3 dpg. That is also a cause of right shift of the oxygen hemoglobin dissociation curve. Important. Now whenever there is increase in 2,3 dpg, it also causes right shifting of the curve. Now what are the causes of the increased 2,3 dpg? Anemia, okay, hypoxia, so high altitude will also causes right shift, exercise, increased thyroid hormone, thyroid oxycosis, increased growth hormone, increased androgen, increased iodine, increased pyruvate, and increased phosphate. All of them can causes increase in 2,3 dpg, and increase 2,3 dpg means right shifting of the curve. Got it? Okay. Now for left shifting, at least you remember that fetal hemoglobin is a cause of the left shift. Myoglobin is also a left shift, but we generally don't say left shift. Rather, we say that myoglobin curve is a rectangular hyperabolic type of curve. Okay. And carbon monoxide is also a cause of left shift of the oxygen hemoglobin dissociation curve. Right. Please remember at least these three important things. Now coming to another MCQ. So here it is said that cited phosphate dextrose stored blood is better for hypoxic patient than acid cited dextrose stored. So whenever you are giving blood to an hypoxic patient, what you require? You require that hemoglobin will release the oxygen easily to the tissue, and that will be beneficial for hypoxic patient. So what kind of shift you require? You require right shift. But if there is left shift, then that will causes problem. And you know that whenever you store blood in blood bank, there will be left shift of the oxygen hemoglobin dissociation curve. Why? So look at this option here. So why this CPD is better than ACDP? Okay, acid cited dextrose solution. So whenever you add this acid extra, what will happen? Acid is an inhibitor of 2,3 dpg production. So what will happen? Your 2,3 dpg level will be less. If your 2,3 dpg level is less, what kind of shift will be there? Left shift. So that's why. So this is my answer of this question. Okay. And this is the true statement. So whenever you give acid, your 2,3 dpg will be less. But here the question is asking about that why CPD is better than ACD solution. So CPD means it is less acidic. Less acidic means there will be less decrease in 2,3 dpg. So why this acid is decreasing the 2,3 dpg? Look at this. We all know that 2,3 dpg is produced in a bypass process from the main glycolytic pathway. Okay. So look at here. So this is the glycolytic pathway which is going on. Okay. Glycerol 3-phosphate, then 1,3-bis-phosphoglyceride, then 3-phosphoglyceride. So this is a glycolytic pathway. From this glycolytic pathway, see there is a bypass pathway here which is producing the 2,3 dpg. But what enzyme you require for this 2,3 dpg production? Biphosphoglycerate mutase enzyme you require for production of this 2,3 dpg. And for breakdown of this 2,3 dpg, you require 2,3-biphosphoglycerate phosphatase. Now whenever there is presence of acid, excess acid, this excess acid basically inhibit this mutase enzyme. That's why whenever you store blood in acidic solution, this mutase enzyme will be inhibited and this 2,3 dpg production will be decreased, and there will be left shift of the oxygen hemoglobin dissociation curve. Got it? Okay. So whenever you store blood in low temperature, temperature low means this whole glycolytic pathway will be reduced. So if the glycolytic pathway is reduced, then 2,3 dpg production will automatically reduce because the bypass pathway. Plus acidity of the solution additionally inhibit the mutase enzyme. So again there is a second cause of decrease in 2,3 dpg condition. So that's why we say that whenever you store blood at low temperature, it already reducing the glycolysis process, as well as the acidity of the storage solution also reduces 2,3-DPG formation by inhibiting the enzyme mutage. Because of these two reasons, it is said in books that after 1 to 2 weeks of storage of the blood, the 2,3-DPG level effectively become 0. Severe left shift. So if you give this storage blood to an hypoxic patient, 2,3-DPG is less 0, and there is severe left shift, means oxygen will not be able to release at the level of tissue. So it is not very helpful. That's why you always prefer fresh blood rather than the stored blood, okay, because of this left shift. Okay, to overcome this problem, what is written, that blood is generally stored in CDP solution, which has additional advantage. What is that? It is more alkaline pH than ACD. It contains dextrose, which enhances glycolytic activity. More glycolytic activity means more 2,3-DPG production. Citrates acts as a buffer, and adenine and phosphate is maintaining the level of adenosine triphosphate. All of these are the benefit of this solution, which is CDP, which is better than ACD solution. Got it? So these are the things that you have to remember. Now moving ahead, the topic which is also important in respiratory system is regulation of respiration. Whenever we say regulation of respiration, you please remember that there are two main types of regulation you have to read. One is the neural regulation and the chemical regulation. So apart from this neural and chemical regulation, there are two important reflexes. One is Herring-Brewer reflexes and one is J receptor reflexes. Okay. Now coming to this neural regulation of respiration, we all know that neural regulation means neuronal centers. What are the centers that I have to remember? One is voluntary control of respiration, which is controlled by cerebral cortex, and one is automatic control of respiration. Now under automatic control, pons and medulla both are important. At the level of pons, there are two centers, pneumotaxic center and apneustic center. Pneumotaxic is mainly the controlling the rate of our respiration, and apneustic is mainly controlling the depth of the respiration. These are the basic minimum thing that you have to remember. Okay. Now at the level of medulla, there are two important areas. One is the dorsal respiratory group of neuron. It is nothing but a sensory integration center. What is the meaning of this? Meaning is that it takes input from peripheral chemoreceptor, peripheral stretch receptor and many other receptor, and give those input to the main center. What is the main center? Main center is the ventral respiratory group of neurons. So VRG is the main center. So VRG and DRG. DRG is the integration center. DRG will give all the information ultimately to VRG. Now there are different parts of the VRG. So what are the different parts of VRG? VRG is subdivided into 4 divisions: Bötzinger complex, pre-Bötzinger complex, rostral VRG and caudal VRG. There are different functions in different part of the VRG, but the most important thing that we have to remember that among these 4 subdivisions, pre-Bötzinger complex generate respiratory rhythm, and this is the area which is known as the pacemaker of respiration. So if the question is respiratory rhythm generation occurs from which area, your answer is pre-Bötzinger complex of neuron. This is pacemaker of respiration. The other area functions is there, it is written, you can remember, or they may not be very important for your MCQ, but at least you remember this pacemaker. Now coming to the chemical regulation of respiration, as you can find out here, chemical regulation of respiration is controlled by chemoreceptor. They are located in 2 areas, peripheral chemoreceptor and central chemoreceptor. Peripheral chemoreceptor is located in the carotid body and aortic bodies, right? And central chemoreceptor is located on the ventral surface of medulla. What is the stimulus for this chemoreceptor? I am coming to that, right? So this is all about the overview of the regulation of respiration. Now among this different overview, look at one question here. During exercise, rapid breathing is possible by which of the following center? So whenever you want to increase the rate of the breathing or the depth of the breathing, ultimately you have to go through the main pacemaker of the respiration, and main pacemaker is located at the level of pre-Bötzinger complex. Pre-Bötzinger complex is a part of the ventral respiratory group of neuron. So your answer will be here is the VRG.
Got it? Please remember this. Okay, now I told you that peripheral chemoreceptor and central chemoreceptor is there. Now at the level of peripheral chemoreceptor, there is a cell which is known as the glomus cell type 1. You have to remember this cell because this is the cell which contain the chemosensitive channels, which is known as the oxygen sensitive potassium channels. So these two names you have to remember, that inside the peripheral chemoreceptor, that is the carotid body and aortic body, one cell is there, that is the glomus cell type 1, and that glomus cell type 1 contain an ion channel which is nothing but oxygen sensitive potassium channel. Now this peripheral chemoreceptor is activated by, so activation of this peripheral chemoreceptor occurs whenever there is increase in PCO2, okay, partial pressure of carbon dioxide in the arterial blood, or there is increase in H plus ion, that is the acidosis, or there is decrease in partial pressure of oxygen in the arterial blood. So hypoxia, hypercapnia and acidosis. But the question they are asking again and again, that which of the following of these three is the primary stimulus. So please remember that among these three stimulus, this hypoxia is the primary stimulus for peripheral chemoreceptor, and this carbon dioxide is the most sensitive stimulus for peripheral chemoreceptor. But apart from these two, you remember that cyanide is the most potent stimulus for peripheral chemoreceptor. So these are the MCQ that you have to remember. Now regarding central chemoreceptor, I told you that they are located on the ventral surface of the medulla, and this central chemoreceptor are activated only in the presence of H plus ions, and that H plus ion has to be present at the level of CSF or the interstitial fluid of brain. Okay, that means I am saying that central chemoreceptor cannot sense H plus ion from the blood, because central chemoreceptors are protected by blood-brain barrier. So if your H plus ion is high in the peripheral blood, it cannot stimulate the central chemoreceptor. For the stimulation of the central chemoreceptor, the H plus ion has to be higher in the CSF, cerebrospinal fluid. So that's why in central chemoreceptor, again the same question is asked, that what is the primary stimulus for central chemoreceptor? Your answer is H plus ion of CSF. But if the question is most sensitive stimulus of central chemoreceptor, again your answer is PCO2. So the question is how carbon dioxide is affecting or stimulating the central chemoreceptor. You know, suppose this carbon dioxide is high in the blood, it is going to stimulate the peripheral chemoreceptor, there is no problem. It is also going to stimulate the central chemoreceptor, means this is the only stimulus, hypercapnia, carbon dioxide increment. This is the only stimulus which can activate peripheral as well as central chemoreceptor. How it will stimulate the central chemoreceptor? Carbon dioxide will react with the water in the CSF, and it will produce H plus ion at the level of CSF indirectly. So carbon dioxide will penetrate the blood-brain barrier because it's a gaseous molecule. It will enter in the CSF. Inside the CSF, it will generate the H plus ion by reacting with water. That's why carbon dioxide is the only stimulus among these three which can stimulate both peripheral chemoreceptor as well as central chemoreceptor. Got it? So please remember this important idea. Now another MCQ or the last topic in the respiratory system. At a high altitude of 3000 meter, a person complains of breathlessness. All of the following can be used for the management of this person except. Okay, so probably the person is suffering from high altitude pulmonary edema. Okay, the typical feature is not given, but probably the person is suffering from this. But whatever, whenever the person is suffering from this breathlessness or other kind of problem, oxygen is essential. Not only that, you have to rapidly descend to the low altitude condition because to improve the oxygenation. So rapid descents and oxygen, these two are the essential for any kind of problem in the high altitude. You have to remember. So oxygen supplement, immediate descent is always given. Now this acetazolamide, why it is given? It is given to enhance the acclimatization process Okay, you have to adapt to the altered environment in the high altitude. So that adaptation process is known as the process of acclimatization. If you give acetazolamide, the acclimatization process will be enhanced. So it can also be given in this patient, but this intravenous digoxin is not required in this patient. So this is my answer. So accept the question. So accept intravenous digoxin. So please remember, in high altitude, sometimes pathological event occurs. And what are those pathological events? One is acute mountain sickness. Severe form of acute mountain sickness is known as HACE. So why I'm saying severe form? Acute mountain sickness and HACE, high altitude cerebral edema, in both of these conditions, pathologically what happens in the brain, there is deposition of edema in the brain, particularly in the white matter. In case of acute mountain sickness, the edema is very mild. And in case of high altitude cerebral edema, frank edema developed inside the brain white matter. That is the difference. So one is a milder pathology, one is a severe pathology. Now how to diagnose that the person is suffering from high altitude cerebral edema or acute mountain sickness? You will remember that this is a clinical diagnosis. Okay. Within 24 hours of descent, this time period is very important. Ascent to the high altitude, if the person is developing severe headache, okay, alteration of the sleep in the night, as well as nausea and anorexia, then the person is suffering from acute mountain sickness. Apart from these symptoms, if the person is having additional ataxia, okay, sensory ataxia, then the person is suffering from high altitude cerebral edema, right? But within 2 to 4 hours of ascent to the high altitude, if the person is developing severe cough, severe dyspnea, then probably the person is suffering from high altitude pulmonary edema. I told you that whether it is high altitude cerebral edema or high altitude pulmonary edema or whether it is acute mountain sickness, oxygen is the mainstay of the therapy. Oxygen you have to give because the problem is due to hypoxia. Not only that, to improve oxygenation, you have to descend in a low altitude, and the descent should be as rapidly as possible. As per the drug intervention is concerned, in these two cases, particularly in high altitude cerebral edema, we prefer to give dexamethasone. But in case of high altitude pulmonary edema, we prefer to give calcium channel blocker nifedipine. So it is written here that in case of high altitude pulmonary edema, obviously the most reliable and effective treatment is, okay, immediate descent to low altitude to improve oxygenation. Immediate oxygenation by supplemental oxygen is also given in both HAP and HES. Keeping the patient warm, this is an additional measure. Calcium channel blocker nifedipine is given for this HAPE patient, and I told you that in case of HACE, dexamethasone is given in case of HACE patient as a drug treatment. And some drugs are used sometimes like phosphodiesterase inhibitor, which causes pulmonary vasodilation, because pulmonary vasoconstriction is one of the main important pathology for this high altitude pulmonary edema. So these are the important information that you have to remember about respiratory physiology.
Now we are going to quickly revise renal physiology. So let's start. So first there is MCQ. Question is, which of the following glycoprotein is found in glomerular basement membrane? So the question is very specific. So here the question is asking about the glomerular filtration barrier. You know that in filtration barrier there are three layers. One is the endothelium cell of glomerular capillary, second layer is the basement membrane, and the third layer of the food process of podocyte, right? So the podocyte. So these three are nothing but making a layer which is known as a glomerular filtration barrier. Now in all of these filtration barrier layer, there are presence of negative charge. So the negative charge is present here. Negative charge is also present on basement membrane, as well as the negative charge is also present on food process of podocyte. But here the question is asking that the negative charge on basement membrane is due to which protein, although they are not saying negative charge, but this is the protein, the heparan sulfate. This is the glycoprotein which is responsible for negative charge of glomerular basement membrane, right? So the answer is heparan sulfate. So you look at quickly, you have to revise here. So endothelium cell of the glomerular capillary, it's a fenestrated type of capillary with a gap of 70 nanometer. Second layer is the basement membrane. It also contains little bit of gap which is 10 nanometer, and the food process of podocyte contain a gap which is known as slit pore. This slit pore is 25 nanometer, and we all know that the slit pore is not completely open. It contains a diaphragm, and this diaphragm also contains multiple opening which has a diameter of 4 to 14 nanometer. Now we look at, so this endothelium cell is lined by glycocalyx, GAG, glycosaminoglycan, and this is negatively charged molecule. The basement membrane is covered up by heparan sulfate proteoglycan, which is also negatively charged molecule. And the food process of podocyte also contain various glycoprotein which are negatively in charge. So that's why I told you that the glomerular filtration barrier contain negative charge not only on endothelium, it is also present on basement membrane, it is also present on food process of podocyte, right? And because of this negative charge on barrier, filtration barrier, what will happen? We know that if the molecule is positive in nature, it will be easily filtered through the barrier, and if the molecule itself is a negatively charged, then it will be prevented from filtration by this negatively charged filtration barrier, right? So accordingly, we have classified the different substances according to their nature of filterability. Okay, we have classified the substances in freely filterable substances. So any substances which has a molecular radius which is lesser than 1.8 nanometer radius, these substances will be freely filterable at the level of barrier without any hindrance. What are the examples of those substances? Sodium, potassium, water, urea, chloride, glucose, sucrose, okay, glycol, inulin, all of them are freely filterable substances. Now, if the molecular radius is between 1.8 to 4.2 nanometer, then this molecule will be selected by filtration barrier, that whether the molecule is going to pass through or not going to pass through. Okay, so they are known as the selective permeable substances. Who are they? Lysozyme, myoglobin, lactoglobin, egg albumin, Ben Jones protein, hemoglobin, serum albumin. All of them are in the range of selective permeable. So if the molecule is selectively permeable, and if it is contain a positive charge, if the molecule contain negative charge, if the molecule is neutral, no charge, then we all know that positively charged molecule will be filterable maximally greater than neutral molecule, which is greater than negatively charged molecule. Means if the molecule is negatively charged and if it is a selective permeable molecule, then the filtration of this molecule will be very, very low in comparison to positive or cationic molecule, right? And if the molecular radius is greater than 4.2 nanometer, then the molecule is not going to penetrate through the glomerular filtration barrier, which is impermeable, right? Got it. Now next is the glomerular filtration pressure and how that is causing filtration. Okay, so the question is calculate the net filtration pressure in millimeter of mercury with the following data. So we know that glomerular filtration, okay, look at. So this is the afferent arteriole, this is the efferent arteriole. Glomerular filtration depends on 4 different types of pressure. What are these? What are this pressure? One is glomerular hydrostatic pressure, denoted by PGC, glomerular capillary hydrostatic pressure, right? So glomerular capillary hydrostatic pressure, PGC. Glomerular capillary, GC for glomerular capillary. Then this pressure is directed towards the Bowman's capsule, and the Bowman's capsule hydrostatic pressure is trying to oppose it. So Bowman's capsule hydrostatic pressure, suppose that is PGB, so it is trying to oppose the net filtration pressure. Plus, along with this, you also know that due to presence of plasma protein, capillary will have oncotic pressure. And oncotic pressure is a dragging kind of force, meaning it will try to drag fluid from Bowman's capsule. And the oncotic pressure of Bowman's capsule, suppose this is B. Okay, so this is not GB, this is Bowman's capsule. Sorry, so this is only B, PB. B stands for Bowman's capsule, right? So suppose pi B will try to drag fluid in this direction. So I can understand PGC minus PB plus pi B minus pi GC. This is the net filtration force calculation formula. So the net pressure is equal to this PGC minus PB plus pi B minus pi GC. So now we all know that this pi, or the oncotic pressure, this pi is nothing but the oncotic pressure. Oncotic pressure depends on amount of plasma protein. At the level of Bowman's capsule, the amount of plasma protein is very, very less because filtration of plasma protein is not going to happen. That's why we assume that normally that this pi B is equal to 0. So basically, the net force of filtration is calculated by this formula, PGC minus PB plus, okay, pi B is equal to 0, so minus pi GC. So this is the net formula for calculation of glomerular filtration pressure. And in Guyton, it has been given that normal hydrostatic pressure, or PGC, is 60 mm of mercury. So in Guyton, it is given that this is 60 mm of mercury. Normal Bowman's capsule hydrostatic pressure is 18 mm of mercury, minus glomerular capillary oncotic pressure is 32 mm of mercury. So the net pressure of filtration is 10 mm of mercury. This has been asked in another MCQ, that normally what is the net force of filtration at the level of glomerular capillary? Your answer is 10, 10, 10. But the question here has been given a different data. So here the PGC is given 42 minus, okay, so this will be pi, okay, minus PBC, Bowman's capsule, is given 16 minus pi GC. This is the formula. So it is given 42 minus 16 minus 12. So obviously the answer is going to be 14 in this question. Got it? Very simple. So glomerular capillary hydrostatic pressure minus Bowman's capsule hydrostatic pressure minus glomerular capillary oncotic pressure. This is the net formula. We assume that the pi B, Bowman's capsule oncotic pressure, is 0 because protein filtration is almost negligible. Here it has been given with the following data that assume that there is no protein were filtered, right? So that is the hint here in this question. You understood? Okay. Next is, which of the following is not involved in GFR autoregulation? So you know that there is something called autoregulation. What do you mean by that? Means certain organs in our body, okay, vital organs like brain, like heart, like kidney, they have autoregulatory capacity. What is that? The organ itself can regulate its own blood flow. So the autoregulation terms is related to constant maintenance of blood flow into an organ irrespective of your blood pressure change. That is the meaning of autoregulation. In case of kidney, the typical autoregulation curve that is drawn, it is given here. So look at here. So x-axis is the blood pressure. With the change in blood pressure, we can find out that initially there is rising of the blood flow into the kidney, but from a range of 70 mm of mercury up to this almost 200 mm of mercury, although the blood pressure is changing, but the renal blood flow or the renal plasma flow is not changing. So this is your autoregulatory range. So we say that in case of kidney, the autoregulatory range is 80 to 200 mm of mercury. Different books has given different value, but we will remember this 80 to 200 mm of mercury, or 220 mm of mercury. Okay. So this is the autoregulatory range. Now, when the blood flow is autoregulated, we know that blood flow autoregulation means your GFR or the filtration pressure will also remain constant. So your glomerular filtration rate or GFR will also autoregulated. So that's why we say that in case of kidney, because your renal plasma flow is autoregulated, GFR will also be autoregulated. Now question is, what is the mechanism of this autoregulation in kidney? So there are different mechanisms in different organ. Number one mechanism is myogenic mechanism. So from the name we can understand that this is a mechanism mediated by muscles. Which muscles? The smooth muscles of afferent arteriole. The smooth muscles of afferent arteriole is responsible for this kind of mechanism, and the mediator for this response is calcium, right? The second mechanism is known as tubuloglomerular feedback mechanism. So from the name we can understand that there is a feedback mechanism from tubules, renal tubules, up to the level of glomerulus. That is the meaning of tubuloglomerular feedback mechanism. This mechanism is operated by macula densa cell of macula densa cell of TAL, thick ascending limb of lobe of Henle, and the mediator for this is nothing but adenosine. And the third mechanism, which has included recently, that renin angiotensin aldosterone system, is the third mechanism for regulation of renal blood flow. So now if we go back to this question, which of the following is not involved in autoregulation? Myogenic mechanism, it's a true, responsible for the autoregulation. Tubuloglomerular feedback mechanism, this is also responsible, this is also responsible, but sympathetic is not. So our answer is sympathetic system. So sympathetic system, it can change the range of autoregulation. Okay, the curve will generally shift to the right side. Okay, what is the meaning of shifting to right side? Means range will be increased. The autoregulatory range will be increased in presence of sympathetic system stimulation. But sympathetic system per se is not a mechanism for auto-regulation. Got it? So this way you have to remember that sympathetic system can increases the auto-regulatory range, but it is not responsible for auto-regulatory mechanism. Got it? Okay. So this is about auto-regulation of GF. Now the next question is tubuloglomerular feedback is for. So obviously tubuloglomerular feedback is for controlling the GFR. It is an auto-regulatory mechanism for glomerular filtration rate. I told you that tubuloglomerular feedback mechanism will be activated when the macula densa cells is stimulated. So macula densa cell is the mediator. Again, I am repeating. Okay. Whenever macula densa cell is stimulated, it will release the adenosine. Okay. And this adenosine, with the help of the Lassus cell, is going to cause contraction of afferent arteriole, of the glomerulus, and by this way it is going to regulate your GAFR, and this mechanism is known as the tubuloglomerular feedback mechanism. The detailed version of this mechanism has been discussed in main lecture. Okay. Now next is, apart from autoregulation, the afferent and efferent arteriole constriction or dilatation can also changes the GFR. So this is one of the must know concept that you have to understand. So first you look at afferent arteriole. So if you causes constriction of the afferent arteriole as it is shown in this diagram, so the resistance of the afferent arteriole is high. Whenever you causes constriction of the afferent arteriole, your renal blood flow will also decrease proportionally, and your GFR will also fall proportionally. Means more you constrict the afferent arteriole, more will be the reduction in the blood flow in the kidney, more will be the decrease in the GFR in the kidney. Okay, so that's why here in the x-axis you are saying that afferent arteriole resistance, more you increase the resistance of the afferent arteriole, what is going to happen? There will be more and more fall of renal blood flow, and there will be more and more fall of GFR also. This is the meaning. Very simple. Okay. Now the problem arises when the question is about the efferent arteriole. So if you causes constriction of the efferent arteriole, obviously there will be increase in efferent arteriole resistance. Whenever resistance increases, whether it is afferent arteriole or efferent arteriole, the blood flow has to be reduced. So look at here, whenever you are increasing the efferent arteriole resistance, more and more increase in resistance of the efferent arteriole, more and more fall of renal blood flow is going to happen. More and more fall of renal blood flow is going to happen. But what will happen to GFR? GFR will increase initially. So when the constriction is mild, the GFR will increase initially, followed by there will be decrease in GFR when the constriction is severe, as you can find out from this curve. So efferent arterial constriction means GFR will increase when the constriction is mild. When the constriction is severe, then the GFR will start falling. Got it? So GFR has two effects. If the constriction of the efferent arteriole is mild, GFR will increase initially, followed by there will be decrease in GFR. Okay, that's why this you have to remember carefully. Okay, and if you causes dilation of the afferent arteriole, so GFR will increase, blood flow will increase. If you causes dilation of the efferent arteriole, your blood flow will increase, but GFR will fall. I hope you know. So you got the concept here that resistance, if you change, if the resistance is decreased, blood flow will increase. If you increase the resistance, blood flow will decrease. But GFR, you have to think and then you have to answer. Like for example here, GFR is increasing initially, followed by there is decrease in GFR. There is a reason for everything, but in quick revision, I'm not going to give you the explanation. Okay. Now next is question about the tubular functions. So the question here, in the proximal convoluted tubules or in PCT of kidney, luminal concentration of which of the following will decrease? All of the following will decrease except. So the question is very critical. Okay. So except is the question. The luminal concentration of all of the following will decrease except. That means they are asking which of these following substances will have their increase in concentration at the end of proximal convoluted tubules. So look at. So if this is the proximal convoluted tubules, right? We know that there will be freely filtration of the sodium, there will be freely filtration of the chloride, there will be freely filtration of the glucose, there will be freely filtration of the amino acid. So amino acid, glucose, all of them will be freely filtered. Now then what is going to happen? We all know that at the level of first part of the proximal tubule, almost all the amino acid, almost all the glucose is going to be reabsorbed, and how much? Almost 100%. 100% reabsorption is going to happen. So immediately the level of this glucose, level of this amino acid will fall at the end of proximal tubule. So it is level is decreasing. So it is not my answer. What about bicarbonate? Bicarbonate is also freely filterable substances in the proximal tubule. In the first part of the proximal tubule, you know, the sodium which has been filtered, that sodium is going to be reabsorbed. But how this sodium reabsorption is going to happen? This sodium reabsorption happens along with the glucose, along with the amino acid, along with bicarbonate. So in the first part of the proximal tubule, the hugely filtered sodium will be reabsorbed along with bicarbonate. So sodium and chloride, they has been filtered equally. Okay. But with this sodium and chloride, you are picking up the sodium along with bicarbonate, not with the chloride. So what will happen? You are leaving the chloride alone in the first part of the proximal tubule. So what will happen? The chloride concentration will gradually increase towards the end of the proximal tubule. Later on it will be absorbed, okay, in different parts of the nephron. But if you look at the end of the proximal tubule, the chloride concentration will be increased a little bit, because in the first part, sodium is reabsorbed more along with bicarbonate, leaving behind chloride. So answer here in this question is chloride. Bicarbonate level will also decrease. Got it? AIIMS entrance question. So very tricky question. Got it? Okay. Now next. ADH regulate which of the following aquaporin? We all know that ADH, that is the anti-diuretic hormone, or ABP, you say, it has main effect or only effect on aquaporin number 2. Aquaporin 1, aquaporin 3, aquaporin 4, they cannot be stimulated by ADH hormone, right? So answer here is aquaporin 2. What is the speciality of this aquaporin 2, which is not there in case of aquaporin 1, 3 and 4? So you know that the ADH has action on which part of the nephron? ADH causes reabsorption of water. In which segment of the nephron? You know, it is mainly at the level of distal tubule, particularly at the level of collecting duct. So collecting duct, suppose this is the luminal membrane of the collecting duct and this is the basolateral membrane of the collecting duct. You know that ADH has its receptor on this basolateral membrane, and which receptor? This is V2. So ADH will stimulate this V2 receptor, And in presence of stimulation of this V2 receptor, there will be increase in 1 second messenger system, that is CAMP. Now this CAMP is going to stimulate the vesicles which are present inside the cell. What is the importance of this vesicle? The vesicle contain one typical aquaporin, and this is the aquaporin 2. Other aquaporin, like for example aquaporin 1, 3, 4, all of them, they normally present on the cell membrane. They don't present inside the vesicles. They always present on the cell membrane. So this is aquaporin 3, okay. Aquaporin 4, they are constitutively expressed on cell membrane. So ADH cannot stimulate them. But aquaporin 2, normally when the ADH is not there, it will remain inside the vesicle. Then ADH will stimulate the vesicle. Vesicle will move towards the membrane, and then the aquaporin 2 will be inserted at the level of this cell membrane. So this is aquaporin 2. So aquaporin 2 will only be inserted on the apical membrane of the collecting duct cell when the ADH is present. Okay, so please note down, aquaporin 2 is present on the apical membrane or luminal membrane of the collecting duct cell. Basolateral membrane contain aquaporin 3 and 4, but ADH has only action on luminal aquaporin, that is the aquaporin 2. Although the receptor of ADH is present on the basolateral membrane, so how the ADH is acting on luminal aquaporin? It is acting via a second messenger, that is CMP. All of them has been asked in MCQ in different type MCQ. So please note down. So whatever we have discussed here, it is written here that ADH inserted aquaporin 2 on luminal membrane of the collecting duct epithelium cell. Aquaporin 3 and 4, they are the constitutively present on basolateral membrane, and they are not regulated by ADH. This is the information that you have to remember in your brain. Got it? Okay. Now next, impaired function of aquaporin causes which of the following? We all know that ADH, if it is secreted in lesser quantity from the CNS, then that is also diabetes insipidus, but that is central diabetes insipidus. But if the ADH is not capable of acting at the level of V2 receptor, then that is nephrogenic diabetes insipidus. So here the question is asking about impaired function of aquaporin causes which of the following? Your answer is nephrogenic diabetes mellitus. So when the ADH is not able to act on the V2 receptor, the aquaporin 2 will not be able to function properly. The aquaporin 2 will not be able to insert it into the membrane, and that is nephrogenic diabetes insipidus. We all know that this is Liddle syndrome, Bartter syndrome. This is due to different ion channels. The detailed version I have discussed in my main lecture. Okay, so for the timing, you remember this nephrogenic diabetes insipidus. So it is said that whenever the ADH functions is decreased 70% or more, okay, either due to problem in secretion or due to problem in action of ADH, then the disease is known as the diabetes insipidus, right? So if the problem is at the level of secretion or synthesis, okay, primary deficiency of ADH result from agenesis or irreversible destruction of the neurohypophysis. We all know the neurohypophysis is the posterior pituitary, right? If there is agenesis or there is irreversible damage of the posterior pituitary, then ADH secretion will be lesser. It is decreased more than 75% of the normal, then that is central or neurogenic diabetes insipidus. But when the ADH is secreted normally or maybe a little more than normal, but due to mutation of the V2 receptor, the ADH is not able to act on the collecting duct cell, then that disease is known as the diabetes insipidus, but nephrogenic diabetes insipidus. So this much of information you have to remember, at least for physiology, right? Okay. Now next is another important topic in renal physiology, that is the JG apparatus. So all of you know that the JG apparatus consists of three components, three parts. Okay. So one is JG cell. So look at here in this diagram. So this granular cell, what is written here, this is nothing but JG cell. So JG cell is also known as granular cell because it contains renin containing granules. Okay. So JG cell, juxtaglomerular cell. Where they are located? Look at here. It is located at the level of afferent arteriole. Got it? Okay. Then second is macula densa. So it is a basically distal tubular cell, but exactly the answer is macula densa is the cells of TL, thick ascending limb of loop of Henle. If it is not given, then your answer will be TAL DCT junction. Okay, please note down. It is the cells of TAL. And in between this distal tubular nephron and this afferent and efferent arteriole, there is presence of another cell here. This cell is known as the Lassis cell. So this cell is known as the Lassis cell. It is an anti-inflammatory cell. So what are the three components of this JG apparatus? JG cells. We say that JG cells is nothing but it is the modified smooth muscle cells of afferent arteriole. Very, very important. Afferent arteriole. And this is the cell which contain renin containing granules. So renin secretion is a function of this cell. Right. Second is JG cell also acts as an intra-renal baroreceptor. It can also sense as blood pressure. That's why it is known as JG cell is also known as intra-renal baroreceptor cell. Second, macula densa cell. I told you that macula densa cell, it's a kind of chemoreceptor cells, and it is located at the uppermost part of TAL, thick ascending limb of loop of Henle. If TL is not given in the choices, then TAL DCT junction will be your answer, but not the DCT. Okay. Now, whenever I am saying chemoreceptor cells, which chemical it can senses? It can senses sodium as well as chloride load in the distal tubular lumen. Okay. And whenever macula densa cell is stimulated, the transmitter, okay, or the mediator which is released by the cell is adenosine. I told you earlier that this macula densa cell is responsible for tubuloglomerular feedback. Got it? Okay. Now the last one is the Lassis cell. This is also known as extraglomerular mesangial cell. And this is an anti-inflammatory cell. So these are the important things that you have to remember about JG apparatus. Got it? Okay. Very good. Now next is one calculation you have to do with respect to tubular function. So here calculate the GFR from that. Oh no. This is a separate question. So here you have to calculate the GFR. So we all know that there is something called clearance. Okay. The formula of clearance is equal to UV upon P. So what is U? U is the urinary concentration of the substances. So here it is given urine concentration is 100 milligram per ml. That is U. Then V is the urine flow rate. Okay. ml per minute. That is the V. And plasma concentration is P. Right. So these are the three parameters. Now, if you measure the clearance of inulin, so we all know that these two information, clearance of inulin, okay, is equal to GFR, and clearance of para-aminohippuric acid is equal to renal plasma flow. These two important information you have to remember. Sometimes rather than inulin, we also use creatinine for the surrogate of GFR, but for calculation of the renal plasma flow, clearance of PAH is used. So here it is given that urinary concentration of inulin is this, plasma inulin concentration is this, and urine flow is given. That means I have to calculate the clearance of inulin and I am going to get the GFR. So how to calculate? You apply this formula, very simple formula. Before applying the formula, you just check whether all the units are in the same or not. Whether all the units are in ml or in dl. If it is in dl, deciliter, then you have to convert into ml. Okay. 1 deciliter is equal to 100 ml. So here all the units are same. So U is 100, right? V is 1. P is 2. So obviously 100 upon 2, that is 50 ml per minute. This D is the answer of this question. So calculation of GFR based on your clearance formula. Simple? Okay. Now next is, okay. So this is one of the tricky question. The main ion in thick ascending limb of loop of Henle responsible for reabsorption of divalent ions from the lumen. Very, very critical, tricky question, I would say. So they are asking that at the level of TAL, thick ascending limb of loop of Henle, we normally know that this is the segment where your furosemide diuretics, Lasix diuretics is going to act on a transporter. That transporter is known as NKCC, sodium potassium 2 chloride channel, right? So look at what is happening at the level of TAL. So suppose this is one TAL cell, thick ascending limb of loop of Henle cell, and this is another epithelium cell, right? And this is the luminal side, and this is the basolateral side. So you all know that whatever amount of sodium, chloride or other divalent ion like calcium, magnesium has been reached at the level of lumen of this TAL, they are going to be reabsorbed at the level of TL in significant amount. We say sodium reabsorption is around 25 to 30% here. So how this reabsorption is going to happen? We know that the main transporter which is going to pick up the sodium along with potassium along with 2 chloride. So sodium, 2 chloride and 1 potassium. This is the transporter which is known as NKCC. This is known as NKCC, sodium potassium chloride channel, right? After reabsorption of all of this, the potassium will diffuse back into the lumen again with the help of a potassium channel which is present here, which is known as ROMK type of potassium channel, renal outer medullary potassium channel. Got it? So whenever you were picking up one molecule of positive charge sodium, one molecule of potassium charge positive ion potassium and 2 molecule of negative charge chloride, the luminal charge is not going to be disturbed because you have picked up 2 positive and 2 negative charge. But whenever you are returning back this positive ion potassium into the lumen, what will happen to the luminal charge? The luminal charge will be positive. So this diffusion back of potassium causes lumen positivity. Lumen positivity. Now, if the luminal charge is positive, what will happen to the other positively charged ion? They will be attracted towards the lumen or they will be pushed out of the lumen. Obviously, it will cause repulsion of the other positively charged ion. That's why the other positively charged ion which are present in this segment, like for example, calcium, magnesium, okay, it will be pushed out of the lumen. How it will be pushed? It will be pushed through a pathway which is present in between 2 cells. This pathway is known as the paracellular pathway. This is known as the paracellular pathway, right? So with the help of this paracellular pathway, the calcium and magnesium will be pushed out of the lumen. That means there will be reabsorptions of calcium, there will be reabsorption of magnesium at the level of this thick ascending limb of loop of Henle due to this lumen positive charge. Who is giving this lumen positive charge? The potassium. That's why we say that if the potassium is not diffusing back into the lumen, the divalent ion like calcium, magnesium reabsorption will be decreased. That's why if you block this NKCC transporter by furosemide, your calcium, magnesium reabsorption will be decreased. Okay, because if you block this, then sodium, potassium chloride is not going to enter in the cell, and if they are not entering, then potassium will not diffuse back into the lumen. It will remain in the lumen. So that's why we all know that furosemide diuretics which block this NKCC transporter is responsible for decreased calcium and magnesium ion from the TAL. More amount of calcium and magnesium will be lost in the urine. Please note down that this paracellular pathway is responsible for reabsorption of very huge amount of magnesium here. It is said that 70% of the magnesium reabsorption occurs at the level of TAL and around 20 to 25% of the calcium reabsorption occurs at the level of TAL by this paracellular pathway. Paracellular pathway is always passive reabsorption, right? Got it? So this is the mechanism which has been asked in this question, that the main ion in thick ascending limb of loop of Henle responsible for reabsorption of the divalent ion from the lumen is nothing but your diffusion back of potassium, right? I hope all of you remember that this is the segment TL where mutation of this NKCC is responsible for the disease. What is the disease? The Bartter syndrome. Okay, Bartter syndrome type 1, Bartter syndrome type 2, ROMK. So this is the segment which is very, very important for your MCQ. Okay, so in the main lecture you have to read the detailed version of this. Okay, next is calculate the urine glucose in a diabetic person. The GFR is given this and blood glucose is given. So this is the question where the tubular functions you have to calculate. So try to answer the question or try to understand the topic like this. So this is your Bowman's capsule with proximal convoluted tubules, and we know that at the level of Bowman's capsule the capillary blood flow is happening. So suppose this is afferent, this is efferent. Blood glucose amount is given 200 milligram per dl. First of all, you convert this dl into ml. So 200 milligram per dl means it is 2 milligram per ml. Okay, and then it is said that the GFR, okay, mean filtration of the plasma in 1 minute is how much? 90 ml per minute. So I can understand from this that within 1 ml of plasma 2 milligram of glucose is present. If there is filtration of 90 ml of plasma, how much glucose will be filtered? That is a simple thing. So GFR is 90 ml. What is the meaning of that? Means there is filtration of 90 ml of plasma in 1 minute. Ultrafiltration of plasma. And 1 ml of plasma contain 2 milligram of glucose. So how much will be the total amount of glucose in 1 minute at the level of this Bowman's capsule? So this is nothing but 180. How 180? So 1 ml plasma contain 2 milligram glucose. 90 ml plasma will contain 2 into 90. So this way we have got 180. That means this 180 milligram glucose that has been filtered at the level of Bowman's capsule, this amount is known as tubular load. So this is known as tubular load, means how much is the total amount of load on tubules. So how we are going to get this tubular load? We have to just multiply the plasma concentration of the substances with GFR. This is the formula for getting tubular load amount. Now within this tubular load, we all know that glucose is going to be reabsorbed with the help of transporter protein, that is SGLT. And the amount of glucose that has been absorbed in these cases is given is 150 milligram. Okay, that is known as the maximum amount of glucose that has been reabsorbed by tubule is Tmax, total maximum amount of glucose reabsorption. So total 180 milligram of glucose has been filtered. Within that 180 milligram you have reabsorbed 150. How much glucose will remain? The remaining glucose will appear in the urine, and that is nothing but 30 milligram per minute. Got it? So this is the way how to answer the question similar to this kind of MCQ, right? Okay. Next is, so we have just discussed that glucose reabsorptions occur with the help of SGLT. Now we have to remember one important thing. Glucose reabsorption occurs in the early part of the proximal tubule also and late part of the proximal tubule also. Early part of the proximal tubule is known as the proximal convoluted tubules, and late part of the proximal tubule is known as the proximal straight tubule. Proximal straight tubule, right? Maximum glucose reabsorptions occur in the proximal convoluted tubule, 90%, and little amount of glucose, that is remaining 10% reabsorption, occur in the proximal straight tubule. Both of them are part of the proximal tubule only. So proximal tubule reabsorb 100% of glucose, but first part of the proximal tubule 90%, later part of the proximal tubule 10%. In the first part, the transporter which is present is, see here, SGLT2. In the second part of the proximal tubule, the transporter is present, SGLT1. Right? So major glucose reabsorption in the kidney is done by SGLT2, that is the 90%. And 10% glucose reabsorption occurs by SGLT1, that is in the proximal straight tubule. Now sometimes they also ask that this SGLT2 and 1, what is the coupling ratio? Means these are the symporter. Symporter means glucose will be reabsorbed along with sodium. Now look at here. SGLT2, it reabsorbs 1 molecule of glucose, 1 molecule of sodium. 1:1 is the ratio. But SGLT1, it reabsorbs 1 molecule of glucose with 2 molecule of sodium. Okay, so 1:2, 2:1. That is the coupling ratio. So SGLT2 means ratio is 1:1. SGLT1 means 1:2. Okay. Now, These are the transporter which are present on which side of the cell? It is present on the luminal side of cell. At the level of basolateral side, the transporter for glucose reabsorption is different. At the level of basolateral side, for proximal tubule, the transporter is GLUT, GLUT2. Look at here, GLUT2. And in case of proximal straight tubule, this is GLUT, GLUT1. So here, this is GLUT1. So if it is SGLT1, it will be coupled with GLUT1. If it is SGLT2, it will be coupled with GLUT2. GLUT2, these are the examples of facilitated diffusion. So if the question is transporter in the basolateral aspect for glucose reabsorption in the kidney, facilitated diffusion. But this SGLT1 and 2, they are the part of the secondary active transporter system. Got it? So this is very, very crucial thing that you have to remember. Okay. Next is counter current flow. So counter current flow means, there are 4 criteria that should be met. What are those 4 criteria? There should be 2 tubes which are parallel to one another. This tube should be very close to one another. So the tube should be very close to one another. The flow, of fluid in this tube should be opposite to one another. If the flow is downward here, it should be opposite. And the tube should be selectively permeable for different substances. Means if it is permeable to water, then this should be impermeable to water like this. Selective permeable. If this kind of arrangement is present in any part of the body, then we say that counter current flow is happening. What are the examples? Intestinal villi, skin, testis, kidney, including your lungs. All of this area has the counter current system or counter current flow. This has been asked in MCQ. Now, in case of kidney, the counter current system has 2 parts. One is counter current multiplier and one is counter current exchanger. Counter current exchanger happens at the level of vasa recta, right? And counter current multiplier, the loop of Henle is also responsible for this loop of Henle, as well as the medullary collecting duct is also responsible for counter current multiplier. In case of loop of Henle, which part of the loop of Henle? The thick ascending limb of loop of Henle is the main part for counter current multiplier, although ascending thin segment of loop of Henle is also there. Medullary collecting duct is also important because this is the segment from where urea reabsorption is going to happen. And from the level of TAL, sodium and chloride reabsorption is going to happen. So basically, if you look at counter current system, what the counter current system is doing? Counter current system is responsible for increasing the tonicity of the medulla, increasing the tonicity of the medullary region of the kidney. Why? If you increase the tonicity, what will be the help? The help will be that there will be increased reabsorption of water from urine. So your urine will be concentrated if you increase the tonicity of the medullary region of the kidney. Now, how the tonicity is increased? What mechanism? The mechanism is known as multiplier. So multiplier is responsible for generation of the hypertonicity of the medulla, and counter current exchanger is responsible for maintenance of the hypertonicity of the medulla. And what are the substances that is making this medulla hypertonic? 3 substances. Who are they? Sodium is responsible for increasing the tonicity of the medulla. Chloride is also responsible for increasing tonicity of the medulla, and urea is also responsible. It is said that the maximum tonicity of the medulla that can be reached is approximately 1200 milliosmol per liter or to 1400 milliosmol per liter. 1400 milliosmol per liter. Within this 1200 milliosmol per liter, it is said that 50 to 60% contribution is done by sodium chloride and 40 to 50% contribution is done by urea alone. Okay, so sodium chloride in combination for 50% to 60%, urea alone for another 50%. So if I divide this 1200, so 600 milliosmol is due to sodium chloride in combination, NaCl in combination, and 1600 is urea alone. But if you separate this sodium and chloride, So sodium and chloride you have separated. So sodium will be responsible for 300 milliosmol per liter. Chloride will be responsible for another 300 and urea will be responsible for 600. So if the question is like this, that which of the following is the most important substances for medullary hypertonicity? Sodium, chloride or urea? Your answer will be urea. But if sodium and chloride is given as a combination, sodium and chloride both, then that is the more important than urea alone. Okay, but if sodium, chloride and urea given as three separate options, then urea is the single most important substances. Got it? So this is all about which you have to remember about countercurrent system. So the MCQ related to this system, the primary driving force for countercurrent multiplier system. Multiplier, I told what is the main segment. The main segment is the TAL. At the level of TAL, which transporter is there? NKCC. NKCC reabsorb what molecule? Sodium molecule and chloride molecule. So reabsorption of sodium in the thick ascending limb of loop of Henle. This is the main segment. This is the primary driving force for countercurrent multiplier. Okay, next question. Which of the following is not a component of countercurrent multiplier mechanism? So the question is about multiplier. Vasa recta is not responsible for multiplier because this is countercurrent or cardiovascular system. Some important topics and some important MCQ. So now let's start. So first there is a MCQ here. A PhD student is measuring the specific effect of cardiac drugs on the initiation and completion of action potential. So first of all, the question is related to the action potential of myocardium or cardiac tissue. Now the question is specifically asking that the channel contribute to the initial rapid repolarization. So initial rapid repolarization. All of you know that there are two repolarization phase. One is known as the initial rapid repolarization and one is final repolarization. So the initial rapid repolarization, as the question is asking here, this is nothing but the phase number 1 of the myocardium action potential. Although you know that there is a final repolarization phase which is nothing but the phase number 3. Right. So we will look at the cardiac action potential. But before that, if I ask you what is the ionic basis of phase 1 in myocardium action potential, then all of you know that it is nothing but exit of potassium through potassium channel. Right. So the answer of this question will be potassium channel. So now let's look at the myocardium action potential. So the myocardium action potential, all of you know that the shape of the myocardium action potential looks like this. So this is one of the important topic you have to read. Okay. So this is the RMP. So this flat line, it indicates the RMP of the myocardium. All of you know that this is minus 90 millivolt is the RMP. Now from the RMP, the phase where the membrane voltage is rapidly shoot out to the plus 35 millivolt, this is the phase number 0, right? So we all know that the phase number 0 is also known as the phase of depolarization of the myocardium, and this is due to sodium entry. Which type of sodium? This is the very fast sodium channel, so the fast sodium entry. Then there is a initial rapid repolarization phase, this phase where the pink color is applied. So this is nothing but the phase number 1. We say that phase number 1 is the initial rapid repolarization. Initial rapid repolarization. Rapid repolarization. This is due to exit of potassium through potassium channel, as well as there will be inactivation of the sodium channel also. Inactivation of the sodium channel also, right? So the sodium channel which has been open in phase number 0, that will also be inactivated. Not only inactivation, there has to be opening of the potassium channel. So that's why this potassium channel opening is the main important cause of this phase number 1. Now after the phase number 1, next phase is the phase number 2. So this phase number 2 is also known as the plateau phase. So the phase number 2 is also known as the plateau phase. Here the membrane voltage is stabilized. That's why this is known as plateau. Now we all know that phase number 2 means two ions are required. One is there will be entry of calcium as well as there will be exit of potassium. So the entry of calcium and exit of potassium, both are the positive charge, they will balance out each other and the membrane voltage will stabilize. So we'll remember, so calcium entry into the cell is also happening, as well as potassium exit is also going on parallelly, and that is responsible for phase number 2. Now, in phase number 2, two channels are open. One is the calcium channel and one is the potassium channel. Now, between these two, whenever the calcium current is stopped, but the potassium channel is still open, so I can understand the potassium means more and more positive charge will go out of the cell, and this will leads to complete repolarization. So this is basically the final repolarization. We do not say final, but we simply say that this is the phase of repolarization. So the repolarization phase is phase number 3. And we all know that phase number 3 is nothing but potassium exit through potassium channel. And what is the status of calcium current? Calcium channel is already closed. So this is the bare minimum thing, the basic minimum thing that you must have to remember about the myocardium action potential, different phases and the ionic basis of different phases. And if you look back at the question, so here they are asking about the the phase number 1, and phase number 1 is this due to potassium channel opening, right? So potassium will go out of the cell due to potassium channel opening. Fine. Okay. Now coming to the next action potential. So we all know that apart from myocardium action potential, nodal tissue, particularly the pacemaker tissue like SA node, AV node, they also have different kind of action potential. And here the question is about the pacemaker potential. So the pacemaker potential means the question here is asking about the nodal tissue action potential, particularly SA node, but similar kind of action potential is also seen in AV node. So in this nodal tissue action potential, all of you know that there are different types of phase which is very, very dissimilar with that of the myocardium action potential, which we have already discussed. So this is the typical shape of a nodal tissue action potential. Here we can find out that there is a one phase where the membrane voltage is slowly rising upward, which is from minus 65 millivolt to minus 40 millivolt. This is the phase which is present in the nodal tissue action potential, and this is known as the pacemaker potential phase. Pacemaker potential phase. Pacemaker potential phase is also known as the pre-potential phase. It is also known as the diastolic depolarization phase. Diastolic depolarization phase. I told you in my main lecture again and again that this is one of the most important phase which has been asked in MCQ multiple times. So you have to be careful here. Now the second, after this minus 40 millivolts, so minus 40 millivolt is the threshold voltage. Next part is the actual action potential part. Next part is the actual action potential, and this is known as the phase number 0 of the action potential. We have to remember that phase number 0 in case of nodal tissue, is due to entry of calcium. This is a slow calcium channel, and that's why we can understand that the membrane voltage is slowly rising upward. So what is the main difference or the major difference between this myocardium action potential? Here the phase number 0 is due to the sodium entry, and it's a fast sodium channel. But in case of nodal tissue action potential, phase number 0 is due to the calcium entry, and the channel is a slow calcium channel. Then we also know that this phase, this is the repolarization phase, similar to the myocardium repolarization. This is also known as the phase number 3, and this is due to exit of potassium from the cell, and obviously this calcium channel which was open, that will be closed. So we can understand from here that in case of nodal tissue action potential, your phase number 1 is also not there, and phase number 2 is also not there. Sometimes phase number 1 or 2 may be present a little bit, particularly the phase number 1 is never present. Phase number 2 may be a little bit present, but mostly it is absent in case of nodal tissue action potential. Got it? Now look at the question, the pacemaker potential. So are they asking about this action potential here? Answer is no. The question is not about the action potential, but they are asking about the pre-potential phase. So look at, so they are basically asking you about this phase or the pre-potential phase of action potential. So which one is the pre-potential phase? We have already told that where the membrane voltage is moving from this minus 60 to minus 40 millivolt. This is the pre-potential phase. You know that if you look at here, so the options you look at, fast sodium channel. Fast sodium channel is not responsible for nodal tissue action potential. Okay, so this is a false statement, right? Decrease in potassium permeability, yes, this is absolutely required. Slow calcium channel is not required for the pre-potential. It is a rapid transient action potential is required, so this is also false. Rapid depolarization, this is a bagwas statement, false statement, right? So obviously we can understand that our answer here is B. But this is not at all. We have to understand the detail of the ionic basis of this pre-potential phase. So first look at. So I am drawing this same diagram once again. So this is the pre-potential phase. Then there is starting of the actual action potential, and now there is repolarization of the action potential. Again there will be starting of the pre-potential phase, and it will continue like this because it's a pacemaker tissue. Now if I have to understand the ionic basis of this nodal tissue cell, particularly the SA node and AV node, first of all you understand that at the beginning of this minus 65 millivolt, okay, what will happen? There will be opening of a particular channel which is present in the nodal tissue cell. This channel is known as the HCN channel. You know that HCN channel stands for hyperpolarization induced, okay, CAMP nucleotide gated channel, CAMP nucleotide gated channel. That's why the channel is known as the HCN channel, right? In brief, the HCN channel is also known as small h channel. Got it? So this channel is specially dedicated for the nodal tissue cell. Whenever the membrane voltage is minus 65 is the hyperpolarized condition. What will happen? This HCN channel will open up, and whenever the HCN channels open up, huge number of sodium will enter into the nodal tissue cell through this channel, although a little amount of potassium may also go out of the cell, but mainly it is the entry of sodium. So HCN channel is responsible for permeability of which ion? It is permeable to sodium ion mainly, although potassium ion is also permeable through this channel. Now due to entry of the sodium, what will happen? There will be more and more positivity into the cells. That means I can understand that the membrane voltage will start, okay, rising in upward direction. Now whenever the membrane voltage is depolarized, there will be opening of another channel which is also present on the nodal tissue cell, and this channel is the calcium channel. But which type of calcium channel? It's a T type of calcium channel, transient type of calcium channel. So this T type of calcium channel is a rapid calcium channel, So further calcium entry means there will be more and more depolarization. So I can understand that the membrane voltage will more rise towards the positive direction. Now whenever it reaches to minus 40 millivolt, it has reached to the threshold voltage of the nodal tissue. This will leads to opening of huge number of further calcium channel, but this calcium channel is L type of calcium channel. That's why I told you earlier that the phase number 0 of this nodal tissue action potential is due to calcium entry, but this calcium is which type of calcium? L type of calcium. This type of calcium is a slow calcium. And whenever the calcium is entering, further positivity will be there, and this will lead to action potential. After the calcium channel is opening, what will happen? Potassium channel will also start opening, through which potassium will go out of the cell, and that will lead to repolarization of this action potential. Got it? Now you look at, now whenever more and more potassium is going out of the cell, the membrane voltage is going down, and it is reaching at minus 65 millivolt once again. Now I told you already that whenever membrane voltage is just to minus 65 millivolt, which channel will start opening? There will be opening of the HCN channel through which sodium will start entering. But please note down, whenever sodium channel is open, sodium will enter into the cell, but parallelly the potassium channel which was already open during this repolarization phase, that potassium channel has to be closed. Otherwise, this sodium entry will not be able to cause depolarization of the membrane voltage. That means I can understand that not only the opening of the sodium channel or HCN channel is required, parallelly there has to be closure of this potassium channel. Then and then only the pre-potential is going to start. Got it? And so whenever the sodium channel is open, there will be further positivity, that positivity will further open up the T-type calcium channel once again. Got it? So now we can understand that the ionic basis of pre-potential. So what are the ionic basis? Number one. So now we are summarizing. Ionic basis of pre-potential. This is very, very important. Number one. Okay. There should be opening of the HCN channel. Whenever HCN channel open, which ion will enter? Sodium ion will enter. But please note down, this sodium is a fast sodium or slow sodium. This is a very, very slow sodium. Second, after the opening of the HCN channel, which channel open up? T-type calcium channel open up, and that leads to calcium entry into the cell. This type of calcium entry is which type? Rapid calcium entry. And number three, the ionic basis number three, okay, is the decrease or closure of the potassium channel. Decrease potassium permeability of the cell, or you can say closure of potassium channel is also required. That we have already explained here. So closure of the potassium channel or decreased potassium permeability is also required, right? So now if you look at here, so this fast sodium channel is not my answer. It should be slow sodium, right? And if it is a slow sodium, then that should be the first choice of the answer. Decreased potassium permeability, or I told you that closure of the potassium channel is required parallel with that of the HCN channel opening. So it's a true statement. Slow calcium channel, no. Slow calcium channel is the L-type calcium, which is required for the phase 0 of action potential, not for the pre-potential. For the pre-potential, the calcium channel which is required is the rapid calcium channel. So the slow word is false, and the rapid repolarization is not related to the pre-potential. So we can easily understand the answer of this question. Now I hope all of you know that this HCN channel, okay, whenever it is open, sodium is flowing into the cell and little amount of potassium is going out of the cell. That means there is a positive current flowing into the cell and positive current going out of the cell. This current is also known as the funny current. This current is also known as the funny current. So the H channel is responsible for flowing of a current into the nodal tissue cell. This is known as funny current. And your pharmacology, you have already read that this funny current channel is blocked by a drug, which is nothing but the ivabradine. So the ivabradine is the drug which blocks this funny current. And if you block the funny current, what will happen? The pre-potential will be slower and the heart rate will be slower also. The detailed version I have explained in my detailed lecture, but for the time being, for revision, just remember this one. Okay. Now, next question. So the next question here is the false about funny channel. So the funny channel means I told you that this is nothing but the H channel. The full name of the H channel is the HCN channel, or the hyperpolarization induced CMP nucleotide gated channel, right? So now look at, it's a sodium potassium channel. True or false? It's a true statement, because although the major ion is the sodium, but little amount of potassium is also flowing through this channel. It is responsible for spontaneous rhythm producing tissue of heart. Yes, it's a channel responsible for pacemaking activity of the nodal tissue. So this is also a true statement. They are voltage dependent channel only. So this only word is a false here. Why? Because the HCN channel, they open in presence of hyperpolarization also. That's why H. And they also open in presence of CAMP also. So hyperpolarization can also open up this channel, and the CAMP can also open up this channel. So the CAMP is a ligand for this channel, and the hyperpolarization is a voltage for this channel. Although the voltage is a negative voltage, but it's a voltage gated channel as well as ligand gated channel. So this only word is not appropriate here. So it's a false statement. And number 4 option here, they are responsible for diastolic depolarization. I told you already that pre-potential is also known as diastolic depolarization. So this is also a true statement. So my answer here is the C. So I hope this is clear. So you must have to remember this basic minimum part of the nodal tissue and myocardium action potential in cardiovascular system. Very, very important topic. I have seen multiple MCQ from this region. Okay. So now we have given a summary diagram of both of this action potential. As you can see here, this is the typical action potential which is found in myocardium. We have already discussed the ionic basis, and on your right hand side you can find out a typical action potential of nodal tissue. Okay, and in this nodal tissue action potential, we have seen that this phase is nothing but the pre-potential phase or pacemaker potential phase, right? So this portion you have to remember. Okay. Now the next is that depolarization and repolarization of the whole heart. So in intact heart, there is a question that where from the depolarization is started and where from the repolarization is started. So look at, so atrial depolarization, it start from the SA node, and atrial repolarization also start from the same region. So for the atrium, the complexity is not there. Depolarization, repolarization, both starting from the same portion, SA nodal region. But the ventricular depolarization is very, very important for MCQ. So if the question is first portion of the ventricle to get depolarized, your answer will be interventricular septum. Now, if I ask you which portion of the interventricular septum, your answer will be left side of the interventricular septum, and it is the middle portion of the interventricular septum. I have given the references in my actual lecture, but please, for the time being, you just revise this thing. Left middle portion of the interventricular septum is the first part to be depolarized, and the last portion of the ventricle to depolarize is the uppermost portion of the interventricular septum. This uppermost word is very, very important. So the middle portion depolarization is starting for the first time, but the uppermost portion, the depolarization will occur at the last. Not only that, the posterior basal epicardial surface of the heart, so the base of the heart, posterior basal portion of the heart, these are the two areas where the depolarization occurs at the last. Now, if I have to choose only one between these two, suppose both of them are in the option, then I'll choose this. Posterior basal portion of the left ventricle is the last part to be depolarized. Got it? And now if the question is about the repolarization, we all know that repolarization occurs in the reverse direction from epicardium towards the endocardium. But in whole heart, in intact heart, which portion repolarizes first? Your answer will be apex of the heart, apical region of the heart. That's why it is written that epicardial surface is the first to repolarize, and the base of the endocardial surface of the base is the last to repolarize. Just remember this information in your brain. It will be helpful for your MCQ. Got it? Okay. Now the next is that the cardiac cycle. So in cardiac cycle, there are multiple detailed discussions, but what is the basic thing that I have to remember? Different phases of cardiac cycle. So all of you know that the diastole has a duration of 0.5 second and the systole has a duration of 0.3 second. We are talking about the ventricular systole and ventricular diastole. Now you can find out that diastole has 5 phases. Sometimes this protodiastole phases has not been included in multiple books, but in Genong it has been given, so that's why I have written here. So this protodiastole phase has the shortest duration among all of the phases of cardiac cycle, okay, and this is 0.04 second. But suppose protodiastole is not in the choices, then this isovolemic contraction has a duration of 0.05 second, right? That is the shortest duration phase. Now, whenever it is isovolemic relaxation phase or whenever it is isovolemic contraction phase, isovolume means the ventricular volume will remain same. Why? Because all the valves in the heart will be closed during these two phases. Whether it is isovolemic relaxation or isovolemic contraction, all the valves of the ventricles will be closed in this phase, right? So this isovolemic relaxation has a duration of 0.06 second. You may not remember this thing. Okay. Now you look at the other phases of the diastole. What are the other phases written here? The first rapid filling phase, okay, the diastasis, and the last rapid filling phase. This diastasis has the longest duration phase in the cardiac cycle, 0.2 second, right? And the ventricular filling occurs during this 3 phase only. So if I ask you when the ventricle is getting filled, your answer will be actually 3 phase are responsible for ventricular filling. That is the first rapid filling phase, diastasis, and last rapid filling phase. Now this last rapid filling phase corresponds with the atrium contraction. So when the atrium is contracting, during that time, the filling of the ventricle will occur rapidly, and that's why the atrium contraction is responsible for last portion of the rapid filling of the ventricle. That's why we say that the atrium contraction corresponds with the last rapid filling phase of cardiac cycle, and this type of ventricular filling is known as the active filling of ventricle. So active filling means this active word is coming from the active contraction of atrium is responsible for ventricular filling. So I can easily understand that the other two phases, like for example this first rapid filling phase and this diastasis phase, they are also responsible for ventricular filling, but during these two phases atrium is not contracting. Atrium will remain in diastolic condition. That's why this is known as the passive filling phase of the ventricle. Remember, the passive filling phase of the ventricle is responsible for 70 to 75% of the total ventricular filling. So suppose ventricle is getting 100 ml blood during diastole. Within this 100 ml, 70 ml blood will reach during these first two phases. And the last phase, that is the last rapid filling phase or the active filling phase, is responsible for 25 to 30% of the total ventricular filling. Got it? Now, after the filling of the ventricle is over, there will be isovolemic contraction. During this isovolemic contraction, ventricular pressure will be very, very high. That will lead to opening of the semilunar valves. And whenever the semilunar valve is open, there will be ejection of the blood from ventricle. That is known as the ejection of blood or the ejection phase. It has two parts, rapid ejection followed by a slow ejection phase. Rapid ejection phase and slow ejection phase, between these two, maximum ejection occurs. 2/3 of the ejections occur during the rapid ejection phase and 1/3 of the ejections occur during the slow ejection phase, although the duration of the rapid ejection phase is shorter. Got it? So at least you remember this basic point about the different phase of cardiac cycle. Now, we have to look at that during this different phase of cardiac cycle, when the heart sound, first heart sound, second heart sound, third heart sound and fourth heart sound, when they will be produced. So first you look at the MCQ and then we'll discuss the heart sound. So in this MCQ, the ECG is recorded with phonocardiogram to identify the different heart sound. Got it? So one is the ECG recording. So this is the typical ECG recording. Along with the ECG recording, the heart sound is also recorded by an instrument which is known as the phonocardiogram. Phonocardiogram, which record the heart sound from the heart. Okay, so what is sound? Sound has an amplitude particular and it has a particular frequency. So in this recording, this is the recording of the sound. So y-axis is the amplitude, more the length in the y-axis, more is the amplitude. So I can understand that in this heart sound diagram, this is the higher amplitude and this is the lower amplitude. Means this B, sound B, this is the large amplitude sound and this C is the small amplitude sound or low amplitude sound. Okay, and the x-axis is the time axis. X-axis is the time axis. So I can understand that this sound B is a longer duration and sound C is a shorter duration. Got it? Okay. So now you look at the question. Question is saying that the first heart sound will appear at which point in the following diagram? Right? A, B, C, D. Which point in the following diagram? So you have to understand that if you record heart sound along with ECG, which wave of the ECG correspond with which heart sound? That is one way. But even if you don't know that, you have to understand the difference between first heart sound and second heart sound. Right. So look at first heart sound and second heart sound. I remember like this, that the second heart sound is short. Okay. Second heart sound is sharp and second heart sound is soft. So short means short in duration, shorter duration. The duration of the second heart sound is only 0.12 second. Sharp means it's a high frequency sound with a frequency of 50 hertz, right? And soft sound means it's a low amplitude sound, or the decibel of the sound will be lower. So it's a low amplitude sound. Got it? Okay. Now if you compare this second heart sound with the first heart sound is a long duration sound. The duration is approximately 0.15 second. It's a low frequency sound. Okay. Frequency is 25 to 45 hertz. And the third is it's a loud sound. Loud sound means it's a high amplitude sound, high amplitude sound. Got it? So if I compare the first and second heart sound, one of the important difference is the amplitude. First heart sound has huge amplitude, high amplitude, and second heart sound is the low amplitude. You may be thinking that what about third and fourth heart sound? Third and fourth heart sound is inaudible normally. If you want to listen with the stethoscope, you will not be able to hear them. So obviously they are the more lower amplitude sound even in comparison to the second heart sound also. So now if I go back to the question once again, so now we have understood that the highest amplitude sound between first, second, third, fourth is the first heart sound. So obviously I can easily comment that this B is nothing but the first heart sound. Got it? And this C is nothing but the second heart sound, and this D and E, they may be third or fourth heart sound. We can understand from this. Okay, so this is the first identification point. Even if you look at the amplitude also, okay, so look at here, even if you look at the amplitude, so I can understand that there will be presence of more waves in this sound, that is a high frequency sound. So this is also indicating that this will be probably the second heart sound. But there is a second checkpoint, we'll check that. But before that, you look at, so first and second heart sound difference, apart from these three difference, you also remember that the first heart sound appear at the onset of isovolumic contraction. So when this sound is going to be heard at the onset of, at the start of isovolumic contraction, and the second heart sound is going to be heard at the onset or at the start of isovolumic relaxation. So whenever the ventricle is about to relax, the second heart sound will occur. Whenever the ventricle is about to contract during systole, okay, the first heart sound will occur. So at the beginning of systole, first heart sound; at the beginning of diastole, second heart sound, right? Now, if you correspond this heart sound with ECG, right? So ECG, the R wave will correspond with the first heart sound, and the ending of the T wave ending will correspond with the second heart sound, right? So the R wave, okay, top of the R wave or the later part of the R wave will correspond with the first heart sound, and the T wave ending will correspond with the second heart sound. Now, if you know this information, it will be very, very easy, and your answer will be very, very confirmatory that at the end of this T wave is corresponding with the heart sound. This obviously is the second heart sound, and the peak of this R wave is corresponding with the heart sound. Obviously this is the first heart sound. Now first, second, obviously this D will be the third heart sound, and this E will be the fourth heart sound. E will be the fourth heart sound. How to identify? The heart sound which is directly corresponding with that of the isoelectric line of the ECG, that is probably the third heart sound. And the heart sound which is corresponding with the end of the P wave, that is the heart sound which is probably the fourth heart sound. Probably name, this is more or less 100% sure. So the end of P wave correspond with the fourth heart sound. Got it? So these are the checkpoints that you must have to remember in your brain to identify what is which heart sound, right? Okay. Now, apart from this first and second heart sound, I hope all of you know that the third heart sound occurs during the phase of first rapid filling phase. So we have discussed during the cardiac cycle, first rapid filling phase, and the fourth heart sound correspond with the last rapid filling phase. I told you repeatedly that the last rapid filling phase is due to contraction of the atrium. So atrium contraction is responsible for production of which heart sound? The fourth heart sound. Got it? So although third and fourth heart sound normally not audible in case of adult person, but sometimes they can be audible even in some normal person also, particularly this third heart sound. Fourth heart sound is almost pathological in nature. The detailed pathology I have discussed in my main lecture. Got it? So this is about the heart sound and cardiac cycle. Now after understanding this heart sound and cardiac cycle, different phase of cardiac cycle we have to understand once again with the help of this PV loop, because you know the PV loop is a very particular topic, very important topic in case of image based question. So the image based MCQ I will show you during the snapshot discussion, but for the timing you look at the PV loop. Okay, what to remember from the PV loop? So all of you know that the two axes, x axis is the volume axis and the y axis is the pressure axis. So the left ventricular volume and left ventricular pressure is plotted in this curve, particularly left ventricle. You can also plot it for the right ventricle. So in this picture, first of all, there is a line. this line indicates, suppose this line is A to B. This A to B line indicates this is the filling phase of ventricle. So A to B is the filling phase of ventricle. So filling phase means ventricular filling is going on. It may be first rapid filling phase, it may be diastasis, it may be last rapid filling phase. So at the end of ventricular filling, okay, so at this point number B, the total volume of blood which is present at the ventricle, that is known as the end diastolic volume. So at this point, the volume which is present in the ventricle is the end diastolic volume. After the end diastolic volume has entered into the ventricle, now the ventricle will start contraction. The first phase of ventricular systole or ventricular contraction is isovolumic contraction. Isovolumic contraction means, look at my diagram, the ventricular pressure is rising more and more, but volume change is not occurring. What is the volume in the ventricle? The same volume, that is the EDV, is remain in the ventricle, and the ventricle is contracting severely. So this point number B to point number C, suppose this is point number C, this is nothing but your isovolumic contraction phase of ventricle, right? Now we all know that at the end of isovolumic contraction, what is going to happen? There will be opening of the semilunar valve. So this is the point number C, where the semilunar valves opening is going to happen. Now whenever the semilunar valve is open, the ventricle is going to eject its blood. So during the ejection, the ventricular pressure will rise a little bit, and the blood volume will also decrease. But what will happen? Initially, although the pressure is rising in the ventricle, but later on the ventricular pressure is going to be decreased and volume is also going to be decreased. So from this point number C up to, suppose this is point number D, this is nothing but the ejection phase of ventricle. Rapid ejection followed by slow ejection. During the rapid ejection phase, little bit increase in ventricular pressure may occur, but during the slow ejection phase, ventricular pressure as well as volume both will decrease. Now, at the end of ejection, ventricular pressure become very, very low, okay, and this will leads to closure of the semilunar valve. So this is nothing but the closure of semilunar valve, point number D. Now, whenever there is closure of the semilunar valve at point number D, what is going to happen? The ventricular pressure will drop down to a very, very low level, but without any change in volume of the ventricle. So again, I can understand that this is the iso phase, okay, and this is known as isovolumic relaxation phase of ventricle. So this D to A, this phase is nothing but the isovolumic relaxation phase of ventricle. So during the isovolumic relaxation phase, the ventricular blood volume will remain same to same. And what is the name of that volume? This volume is known as the end systolic volume. Okay, at the end of ejection, at the end of systole, how much volume is still remaining in the ventricle? That is end systolic volume. Normally, we know that this end diastolic volume is 130 ml, right? And end systolic volume is more or less equal to 40 ml. So this is end systolic volume is equal to 40 ml. And the difference between this end systolic and end diastolic, okay, is nothing but the stroke volume. So if you subtract the end diastolic volume minus end systolic volume, you are going to get the stroke volume of the ventricle, which is nearly 70 to 90 ml. Got it? So now from this loop, okay, you can understand that PV loop is nothing but it is the relationship of volume and pressure within the left ventricular chamber, right? So A to B is the filling phase of ventricle. So could you tell me at the point number A, which valve has to be open for the filling of the ventricle? Ventricular filling is going on. If it is left ventricle, so the mitral valve has to open up. So point number A means this is nothing but mitral valve opening point, right? And at the end of ventricular filling, when the ventricle is starting contraction, the first heart sound is going to happen. First heart sound means which valve is going to closed here. So there will be closure of mitral valves, okay? Or if it is a right ventricle, the tricuspid valve. So the closure of the mitral valve means this is the point where the first heart sound is going to happen. And this closure of the semilunar valve, this is the point where the second heart sound is going to happen. So this is all about the brief discussion of the PV loop, normal pressure volume loop in the cardiovascular system. Now, with the help of this PV loop, you remember three principles. Whenever there is increase in the end diastolic volume of the ventricle, the PV loop will shift to the right side. Okay, PV loop will shift to the right side if the end diastolic volume is high. If there is increase in contractility of the ventricle, then the PV loop will shift to the left side, shift to left and little upward. And if there is increase in afterload means it is the aortic pressure, then the PV loop will shift to upward direction. It will shift to upward direction. For the timing, you just revise this 3 points. Okay. In my lecture, I have discussed the detail, but you remember these 3 things. Now, with the help of this 3 information, if you look at the different valvular disease and the PV loop status, then you look at here, the aortic regurgitations as well as mitral regurgitations. Because the blood is regurgitating back into the ventricle, what will happen? In the next cardiac cycle, the end diastolic volume will be higher. So in both the condition, whether it is aortic regurgitation or it is mitral regurgitation, which kind of shift is going to happen? There will be right shift of the PV loop. There will be right shift of the PV loop. Got it? So as you can find out here in this diagram, this is the right shift, rightward shifting of the curve. So this red color shadow curve, this is the abnormal curve. And this this black color line curve. So this is the normal PV loop curve, and the red color shadow curve, that is the abnormal curve. Okay. Now in case of this aortic stenosis and this mitral stenosis, what you are finding out in aortic stenosis, the curve is shifting in this direction, upward direction. Why? Because aortic stenosis means the afterload, the aortic pressure is high. That's why there will be upward shift of the curve. But later on, in case of chronic aortic stenosis, the curve may also shift in the leftward direction, because there will be increase in hypertrophy of the ventricle. Hypertrophy means there will be increase in contractility of the ventricle. That's why in case of chronic aortic stenosis, apart from this upward shift, there may be also leftward shift of the PV loop. Got it? Now in case of mitral stenosis, the end diastolic volume will be very, very low. There will be severely reduction of the end diastolic volume, because of which the curve will be shifted on the left hand side. But it is not actual left shift. This is basically narrowing of the curve. But it is said that the curve is shifting on the left hand side due to the reduction of this end diastolic volume point. So what kind of shift we are going to see here? The left shift of the PV loop. Got it? So this is about the valvular disease and the shifting of the PV loop in different conditions. Now, apart from this valvular disease, you know that there are cardiomyopathies also, primary disorder of the heart muscles, right? And all of you know that there are 3 different subvariety of the cardiomyopathy. One is the dilated cardiomyopathy, one is the hypertrophic cardiomyopathy, and one is the restrictive cardiomyopathy. So look at here. In cardiomyopathy, first you look at the end diastolic volume. So in case of dilated cardiomyopathy, EDV increased to a very high level. So we can easily understand that what kind of shift is going to happen. The rightward shift of PV loop will happen, right? Now, in case of restrictive and hypertrophic, so you look at, in case of hypertrophic cardiomyopathy, the end diastolic volume is decreased. So whenever the end diastolic volume is decreased, we have seen in mitral stenosis also that what kind of shift is going to happen? The leftward shift is going to happen, right? So now we'll look at the actual diagram. So first, you look at the normal curve. So this is the normal curve. Normal curve means this. Okay, this diagram is the normal curve. Okay, so in hypertrophic cardiomyopathy, we have already seen that end diastolic volume decreases, because of which kind of shift is going to happen? Predominantly leftward shifting of the curve. Although in hypertrophic cardiomyopathy, additionally, we can find out that there is increase in contractility. Whenever there is increased contractility, there will be a little leftward shift of the curve. So this leftward shift of the curve in case of hypertrophic cardiomyopathy is due to both conditions, decrease in end diastolic volume and increase in contractility, right? So this is hypertrophic. Now the dilated cardiomyopathy, we have already seen that in case of dilated cardiomyopathy, the end diastolic volume is very, very high. So that's why there is right shifting of the curve. And in case of restrictive cardiomyopathy, you know what is going to happen? Due to restriction, due to scarring of the ventricular muscles, due to increased scarring of the ventricular muscle, look at here, scarring and myocardial infiltration, what will happen? The compliance of the ventricle will be reduced. That means the ventricular muscle will be hard, due to which during the filling of the ventricle, the pressure rise will be very, very high. And that's why you can see from this normal curve, the restrictive cardiomyopathy curve is shifting to the upward direction. So that's why we say that in case of restrictive cardiomyopathy, what kind of shift will be there? Upward shifting of the curve. But don't think that this upward shifting of the curve is due to aortic pressure changes. No, here the upward shifting is due to the filling of the ventricular problem. So during the filling of the ventricle, the pressure rise will be very, very high. And that's why the filling phase of the ventricle will be shifted in the upward direction. And that's why the whole curve will be, whole PV loop will be shifted in the upward direction. So this is about the cardiomyopathy and PV loop. So now we got to know the different phases of cardiac cycle, PV loop, and some abnormal PV loop. Now look at the question. So the question is, the pressure volume curve of the left ventricle is recorded from different valvular disease. The curve is typically shifted to the left. So different valvular disease, we have seen only one condition, one only valvular disease, where the curve is shifting on the left, and that is nothing but the mitral stenosis or MS. So this is the direct answer of this question. Now the next question, here we can find out the question is about the C wave in JVP. So all of you know that the JVP is nothing but the jugular venous pulse. Jugular venous pulse is the indication, or it is the recording of the right atrium pressure. So the jugular venous pulse, it is nothing but the indication or the recording of the right atrium pressure. Now we remember three things, okay, that there are some positive wave, there are some positive wave in the JVP, and there are some negative wave or the descent wave in the JVP, negative wave. So positive wave, they are A, C and V. Remember like this, A for atrium contraction, A for atrium contraction, C for bulging of the cusp, C for cusp. What will happen to the cusp? There will be bulging of the cusp towards the right ventricle. And V stands for venous return. So whenever the venous return is occurring to right atrium, the pressure will rise. So these are the three positive curve. And the negative curve, the X descent and the Y descent. The X descent is typically of the atrium relaxation along with the pulling of the tricuspid valves towards the ventricular chamber. And Y descent, whenever there is opening of, okay, tricuspid valves, the ventricular filling will happening, due to which the blood from atrium will divert to the ventricle and atrium pressure will drop down. That is nothing but the Y descent. In some books, sometimes this X descent has been divided into X dash and X. Okay, I'll come to that. But before that, you just look at that this is the bottom line thing that you must have to remember. So in this question, they are asking about the C wave, C for cusp. Valves. So there will be bulging of the tricuspid valves into the right atrium, and this will lead to C wave of JVP. So now I hope all of you know that this is the typical diagram of JVP, and all of you know that. So this is A wave, positive wave, followed by a C wave, that is positive wave. Now there is descent. Again there is a positive wave, that is a V wave, and then this is a descent. This descent is nothing but the Y descent. So you look at this X-axis of this recording is the time and Y-axis is the pressure. Pressure means which pressure? I told you already that JVP means they are talking about the right atrium pressure. So suppose this is right atrium, okay? So inside this right atrium, if the pressure is rising, then the positive wave will be created. And if the pressure inside the right atrium is dropping, then the descending or the negative wave of the JVP will be created. Now you start from here, that suppose when the atrium is contracting, so what will happen? Obviously the atrium pressure is going to rise to a very high level, okay? And that high increase in pressure is depicted here. So this is the increase in pressure in the right atrium during atrium contraction, and that is producing a positive wave. This is A wave. So that's why I told you A wave in the JVP is due to atrium contraction. So now if I ask you that the A wave in the JVP, A wave in the JVP correspond with which phase of cardiac cycle? Okay, it is due to atrium contraction, but atrium contraction is corresponding with which phase of cardiac cycle? Your answer will be last rapid filling phase or the active filling phase of ventricle, right? Okay, now then the C wave. Okay, C wave means the tricuspid valve will bulge towards the atrium. During which phase of cardiac cycle this is going to happen? See, so when this tricuspid valve is closed, the ventricle is contracting, okay, and your pulmonary valve is also closed. So tricuspid valve is closed, pulmonary valve is closed, but the ventricle is contracting. Which phase? The isovolemic contraction phase. During this phase, this tricuspid valve will bulge towards the atrium like this. And whenever the tricuspid valve is bulging towards the atrium pressure will again rise. That's why we say that when the ventricle is contracting isovolemically, the tricuspid valve will bulge and that will lead to C wave. So C wave corresponds with the isovolemic contraction phase of ventricle. So this way you have to remember that C wave corresponds with isovolemic contraction phase and the V wave of JVP corresponds with this isovolemic relaxation phase and protodiastole phase of ventricle. Got it? So this descent, here you look at, so this is X descent, first part of the descent, and this is X dash. We generally say this X descent is due to atrium relaxation, Now this X dash, atrium relaxation is happening, but along with that, this tricuspid valve will pull towards the ventricular direction. It will be pulled towards like this. So when the ventricle is contracting severely, ejection of the ventricle is occurring. That time there will be pulling up tricuspid valves towards the ventricular cavity, and that is leading to X dash descent. Right? So this X dash descent will be seen in which phase of the cardiac cycle? Ejection phase of cardiac cycle. And whenever there is opening of the tricuspid valves here, whenever there is opening of the tricuspid valve, the blood will start moving from atrium to ventricle. Atrium pressure will drop down, and that is nothing but Y descent. So Y descent will happen whenever there is opening of tricuspid valves. Opening of tricuspid valve means the ventricular filling will start. So if I ask you which phase of the cardiac cycle will correspond with it, the first rapid filling phase, and the diastasis will correspond with this Y descent of the JVP. Got it? So at least you remember this JVP, what is the region of different waves, and these waves correspond with the which phase of cardiac cycle. Both you have to remember. And at the end, you also have to remember certain abnormality in JVP waves. Like for example, prominent A wave is seen in case of tricuspid stenosis, pulmonary hypertension. Canon A wave, very large A wave. Okay, whenever the atrium ventricular dissociation occurs, like for example, complete heart block and junctional rhythm, in these cases, canon A wave is going to be seen. A wave will be absent in case of atrial fibrillation because the pressure generation during this atrial fibrillation will not be very high. Large V wave, okay, huge amount of venous return will be seen in case of tricuspid regurgitations. Sharp Y descent is seen in constrictive pericarditis, and sharp X descent is seen during cardiac tamponade and constrictive pericarditis both, but it is mainly tamponade, right? So these are the abnormal JVP waves that you also have to remember. Okay. Now after JVP, you look at, so this diagram, okay, is it similar? Are you familiar with this diagram? So this is nothing but recording of the aortic pressure. Aortic pressure, but you cannot directly record the aortic pressure. Rather than recording aortic pressure, we record the pressure from the carotid pulse. That's why here it is written normal carotid pulse. So how the normal carotid pulse or aortic pressure looks like? So look at the diagram here. So I'm drawing. So the aortic pressure curve looks like this. Same diagram on the left hand side, it is there, but I'm still drawing it so that you understand it better. So whenever the ventricle is ejecting blood at the level of arch of aorta, okay, what will happen? This aortic pressure will start rising like this. Okay, so without the ejection, the aortic pressure was low. What is the name of this pressure? This is the diastolic blood pressure. All of you know that when the ejection of the ventricle is not happening, the pressure in the arch of aorta and pressure inside your blood vessel is the diastolic blood pressure. Now, whenever the ventricle is ejecting blood, the aortic pressure is rising. Okay, and the maximum pressure that is recorded during this ejection phase is nothing but your systolic blood pressure. And the wave which is created during this ejection of blood into the arch of aorta, this is known as the percussion. This is known as the percussion wave in aortic pressure curve, right? And at the beginning of this ejection, okay, what is going to happen? You are going to get a heart sound, okay? And this is nothing but your first heart sound, as you can find out here. So we all know that at the beginning of systole, the first heart sound is going to happen. So at the beginning of systole, first heart sound will occur, then isovolemic contraction, then the ejection will start, and there will be rise of aortic pressure like this, right? There will be rise of aortic pressure. Now we look at, after the ejection is over, what is going to happen? The aortic pressure is going to be reduced, obviously, because initially the ejection is very high. Now the ejection is reduced, so the aortic pressure is reduced. Now you have to imagine a diagram like this, that this is the arch of aorta and the left ventricle is ejecting blood. So when the ventricle was ejecting blood, what will happen? This arch of aorta will be expanded like this. Arch of aorta will be expanded like this. Now, when the aortic ejection is reduced, the aortic pressure will also start falling. But suddenly, what will happen? This semilunar valve is going to get closed. So this is the point where the semilunar valve is getting closed. Okay. After the closure of the semilunar valves, what will happen? This expanded arch of aorta, it will return back to the original condition. So arch of aorta has elasticity. Whenever you are ejecting blood, it will expand. But whenever the ejection is not there, the arch of aorta will recoil back. During this recoiling back, it will put some pressure at the level of the arch of aorta blood, and that pressure, okay, will be recorded in a positive wave here, and this positive wave is known as the dicrotic wave. So what is the cause of this dicrotic wave? This is due to elastic recoiling of the aorta, elastic recoiling of the aorta. And the semilunar valve closure point, this is producing a notch, and this notch is known as dicrotic notch. So the dicrotic notch followed by a positive wave, that is dicrotic wave. This is typically seen in aortic pressure or carotid pulse pressure. Got it? So this you have to remember. You may get an image based question, okay, sometimes from this diagram. Okay. Now, next is the cardiac output. So cardiac output, the first thing that you have to remember is the measurement of cardiac output, you know. So measurement of cardiac output means there are various methods, okay, and these methods has been written here. So the fixed principle, all of you know what is fixed principle? Could you tell me? Okay, recall karke dekho. Could you tell me what is fixed principle? So fixed principle is saying that cardiac output is equal to oxygen consumption upon your artery minus venous oxygen content. So oxygen consumption, so you measure the oxygen consumption of the whole body. Suppose you, with the help of a spirometer, you measure that what is the total amount of oxygen consumption by the body. Suppose that is 250 ml, right? And then you measure what is the arterial oxygen content, what is the venous oxygen content. Suppose arterial oxygen content is 20 ml per deciliter of blood and venous oxygen content is 15 ml per deciliter of blood. So from the deciliter, if I want to convert into a milliliter, so 100 multiplication. So this is 250 upon 5 multiplied by 100. That means it is, okay, ml. So this is nothing but your normal cardiac output. So this way, if you measure the oxygen consumption of the whole body, and if you measure the arterial blood oxygen content, particularly the brachial artery or radial arterial blood is taken, and the venous blood oxygen content. Venous blood means you have to take the sample from the mixed venous blood. Mixed venous blood is typically taken from the pulmonary artery level, right? So this pulmonary arterial sample and the radial arterial sample you require. So obviously you can understand that this fixed principle, although it is one of the best method for cardiac output measurement, but it's a very invasive method. Now we look at This dye dilution method and the thermodilution method, both of this method is based on a principle which is known as Stewart-Hamilton principles. So this is known as Stewart-Hamilton principle. This has been asked already in AIMS entrance examination. So remember the name of these two scientists, right? Now between these two methods, this thermodilution method is done by putting a pulmonary artery catheter, and this pulmonary artery catheter method or the thermodilution method is known as the gold standard method for cardiac output measurement. Please remember, okay? So although we say fixed principle is one of the best method, but the gold standard method is the thermodilution method, right? Echocardiography, it is one of the most common method for measuring cardiac output. But you know that this echocardiography is most erroneous method, means with this method you are not going to get the actual cardiac output. So although it is the most common used method, but not the accurate method. Now impedance cardiography can also be used for measuring cardiac output by measuring the thoracic bioimpedance, but this method also has 20 to 40% error. Now this MRI, not the simple MRI, but you have to remember there is a phase contrast, okay? Phase contrast MRI. So MRI is the phase contrast velocity encoded MRI. Velocity encoded phase contrast MRI. This is one of the most accurate methods. So this is the most accurate method for measuring cardiac output. But please note down that this method has not been used clinically till death. But for the research purpose, this has been used, and it is said that this phase contrast velocity encoded MRI is the best method for cardiac output measurement, most accurate method. But if it is not given in the option, then you will go for this thermodilution method, right? Okay. Now, determinant of cardiac output. In this topic, all of you know that cardiac output is determined by two main factors. One is the stroke volume. So I'll write down here, stroke volume multiplied by heart rate. All of you know this thing is equal to cardiac output. And then if you multiply this cardiac output with the total peripheral resistance, you are going to get the blood pressure, mean arterial pressure. All of you know this. Now this heart rate, it is regulated by sympathetic parasympathetic system, right? All of us know this parasympathetic system. Heart rate also regulated by Bain-Bridge, okay? Bain-Bridge reflex, Basal-Gilles reflex, and your baroreceptor reflex. Okay, so we have to understand what is Bain-Bridge reflex, what is baroreceptor reflex. Now, on the other hand, the stroke volume is regulated by three main factors. One is preload, very, very important for MCQ. One is preload. More the preload, more will be the stroke volume. So positive relation. Second is the contractility. More the contractility, more will be the stroke volume. And third one is the afterload. I'll tell you what is the meaning of afterload. But afterload has a negative relationship with stroke volume. Means more the afterload, stroke volume will be decreased. Now, we all know that this preload is equal to the end diastolic volume. And the preload is determined by venous return. So please note down, if the venous return of a person is high, then preload will also high, and more the preload, more will be the stroke volume. But not only that, if the preload is high, means end diastolic volume is high, what will happen? There will be stretching of the ventricular muscle, and you know that whenever you stretch ventricular muscle will contract more forcefully, and this relationship is known as the Frank-Starling law. So what I'm saying here, if there is increase in preload, okay, preload means what? There is increase in end diastolic volume. There will be increase in length of the myocardium. Increase length of the myocardium means there will be increase in contractility of the myocardium. This is what? This is known as the Frank-Starling law, right? Frank-Starling law. So I can understand here that more increase in preload means contractility of the ventricle can also increase by Frank-Starling law. Now, regarding this contractility, we all know that contractility is stimulated or increased by sympathetic stimulation, and contractility is decreased by parasympathetic stimulation. So if you stimulate the parasympathetic system, contractility will reduce, and stimulate the sympathetic system, contractility will be enhanced. But apart from this, we also have to remember that increased heart rate can also increases the contractility of the ventricle, and this is known as the Bowditch effect. So what I'm saying, if there is increase in heart rate, increased heart rate can also increase the contractility of the ventricle, and this is known as the BOWDITCH, Bowditch phenomena or Bowditch effect. Got it? So Frank-Starling law is increased contractility when the end diastolic volume is high. Bowditch phenomena is increased contractility when the heart rate is high. And the third factor, afterload. You know that whenever there is increased afterload, the stroke volume will be reduced. But in the next cardiac cycle, what will happen? The ventricle will start contracting more forcefully. That means now I am saying that if there is increase in afterload, although the stroke volume will be reduced in the cardiac cycle, but later on the heart will start contracting more forcefully, means increased afterload can also increases the contractility of the ventricle, and this is known as the ANREF effect. Please note down all these three effects. They are very important for your upcoming MCQ. So this afterload is nothing but your aortic pressure, and preload is nothing but your end diastolic volume. So we have to summarize this preload and afterload. So please remember, preload means it is the diastolic load on ventricle. Preload means pre means before. So when the ventricle is not contracting, the load which is applied on the ventricular muscle is preload, right? Or you can say the initial stretch on the ventricle is preload. So these two are the definition of preload. We have just seen that the best index of preload is end diastolic volume. And end diastolic volume depends on which parameter? It depends on venous return. So the determinant of the preload is venous return. Got it? Okay. Now afterload, I told you repeatedly that it is the load which is applied on ventricle during contraction, means this is the systolic load, right? Systolic load. Okay. Or you can define that systolic ventricular wall pressure. So during systole, what is the pressure on ventricular muscles? That is afterload. So it depends on the aortic pressure. So the best index of afterload is aortic pressure. Aortic pressure. You may be thinking, which aortic pressure? Mean arterial pressure is the best indexed. Aortic pressure in turn depends on total peripheral resistance. So if the question is what is the determinant of afterload, your answer will be TPR. Getting my point? So if the question is best index of afterload, your answer is aortic pressure, mean aortic pressure, but best determinant of afterload is the total peripheral resistance. Got it? Okay. Next is regulation of blood pressure. So you see here the different mechanism which regulates your blood pressure has been classified. Okay. And you can find out that rapidly acting mechanisms are there, intermediate acting and long-term mechanisms are there. You have to remember them according to categories. But the most important thing that already been asked, that this hormone ADH, atrial natriuretic peptide, aldosterone, as well as this renin angiotensin aldosterone system, they are part of the long-term regulatory system of blood pressure. Got it? And the short term, the baroreceptor, chemoreceptor, CNS ischemic response, they are very important for your MCQ. In intermediate response, here also the renin angiotensin system has been written. But when the renin angiotensin system is causing only vasoconstriction, then that is a part of the intermediate mechanism. But when the renin angiotensin system is acting through aldosterone, then it's a long-term system. Now, among all of this mechanism, if I ask you most rapidly onset mechanism, your answer is baroreceptor reflex, followed by chemoreceptor. But if I ask you, among all of this mechanism, which mechanism is the most potent? Most potent means he or she, this mechanism can increase your blood pressure to a very high level, which is that this renin angiotensin aldosterone system is the most potent mechanism for blood pressure control. And the CNS ischemic response is the second most potent mechanism for blood pressure control. At least you remember this information. Now, after this, you have to remember little bit of this baroreceptor and chemoreceptor reflex. Okay, what is the must know information about this baroreceptor and chemoreceptor? Remember, this baroreceptor, they are the stretch receptor. First thing you have to remember, baroreceptor are the stretch receptor. And where this baroreceptor are located, all of us know that it is nothing but carotid sinus. Okay, carotid sinus wall and the aortic arch wall. Aortic arch wall. You should not forget, you should never forget this information. Now, they are the receptor which detect the stretch on the blood vessel. That's why we say it is a stretch receptor or mechanoreceptor, right? Whenever your blood pressure is high, the baroreceptor will be activated. But there is an MCQ that this baroreceptor is most sensitive to which blood pressure? It is most sensitive to pulse pressure followed by mean arterial pressure. Please note down. Baroreceptor is most sensitive to pulse pressure followed by mean arterial pressure. Now, whenever your baroreceptor is activated by increased blood pressure, what will happen? It will send one inhibitory signal to the vasomotor center, which is also known as RVLM, rostroventrolateral medulla, and it will send a stimulatory signal to CIC, cardiac inhibitory center. So this vasomotor center is connected with the sympathetic system. So sympathetic will be inhibited, and CIC is connected with the parasympathetic system. So your parasympathetic system will be stimulated. So whenever your baroreceptor is stimulated, your sympathetic system will go down and parasympathetic system will be up, because of which your blood pressure will be corrected once again. So this is the in brief mechanism that you have to remember. Okay. Now coming to the chemoreceptor. So we all know that chemoreceptor, basically we are talking about the peripheral chemoreceptor, where the peripheral chemoreceptor are located at the level of carotid body as well as at the level of aortic body, right? So this carotid body and aortic body, it's a small tissues. Okay. This small tissue contain one cell, particular cell, which is known as the glomus cell type 1. And it has been asked multiple times that this glomus cell type 1 is the actual chemoreceptor cells of your body. Means this within this carotid body and aortic body, the glomus cell type 1 is there, and this glomus cell type 1 can be activated by three major stimulus. Number one, decrease in partial pressure of oxygen in the arterial blood, increase in partial pressure of carbon dioxide in the arterial blood, and increase in H+ ion in the arterial blood, that is acidosis. So hypoxia, hypercapnia, acidosis, these are the three stimulus for chemoreceptor. Now when the chemoreceptor is stimulated, we have seen if the baroreceptor is stimulated, what is going to happen? If the chemoreceptor is stimulated, it will stimulate the vasomotor center also. It will stimulate the cardiac inhibitory center also. Got it? So vasomotor center stimulation means there will be increase in blood pressure. So if there is hypoxia, hypercapnia or acidosis, chemoreceptor will be stimulated. What will happen to your blood pressure? Your blood pressure is going to increase. And what will happen to your heart rate? Heart rate is mainly regulated by CIC center or parasympathetic system. So heart rate will be generally reduced by the direct effect. But apart from this direct effect, there is an indirect effect also through which heart rate can also be increased. The detailed effect of indirect effect and direct effect I have discussed, but for the timing you remember that if the chemoreceptor is stimulated, your blood pressure will always shoot out, but the heart rate may decrease also, may increase also. If the chemoreceptor stimulation is mild, then the heart rate will be reduced. If the chemoreceptor stimulation is very, very strong, then the heart rate will also increase, right? So these are the two baro and chemoreceptor reflex. It is a rapidly acting mechanism for blood pressure control. Now there is a third mechanism which we have already written here, that is a CNS ischemic response. What is this mechanism? CNS ischemic response means whenever your blood pressure is less than 50 millimeter of mercury. Generally it is said that baroreceptor is active whenever the blood pressure is high, chemoreceptor is active whenever the blood pressure is reducing, and whenever the blood pressure is very, very low, less than 50 millimeter of mercury or less than 40 millimeter of mercury, what will happen? There will be ischemia at the level of central nervous system. Whenever the ischemia is affecting the vasomotor center, there will be severe stimulation to the sympathetic system, and this sympathetic system stimulation will try to increase your blood pressure. This mechanism is known as CNS ischemic response. So whenever there is ischemia at the level of CNS, it is rising your blood pressure by stimulating the sympathetic system. This is CNS ischemic response. Now, all of you know that if there is increase in intracranial tension, increase in CSF pressure, what will happen? Huge amount of increase in intracranial tension can also causes hypoxia of the CNS. So this will causes secondary ischemia at the level of vasomotor center. And during this situation, the reflex which is going to be activated is known as Cushing reflex. So what is the triad of this Cushing reflex? In case of Cushing reflex, we say that there will be increase in blood pressure, hypertension will be there will be decrease in heart rate, that is the reflex bradycardia. Along with that, there will be irregular respiration. Okay, ventilation will be irregular. These three are the symptoms of the Cushing reflex or Cushing triad. So what is Cushing triad or what is Cushing reflex? Cushing reflex is if the CNS ischemic response is activated secondary to increase in intracranial tension, then that is known as the Cushing reflex. Got it? So this is about the different reflex which is controlling your blood pressure. Now look at this MCQ. So this MCQ is talking about the Bain-Bridge reflex. So they are asking Bain-Bridge reflex is initiated in which of the following condition. So you know the Bain-Bridge reflex is different from the baroreceptor reflex, chemoreceptor reflex and Cushing reflex. Bain-Bridge reflex is a reflex where the receptor is located at the level of atrium rather than carotid sinus or aortic arch. So if I ask you what is the location of the receptor for this Bain-Bridge reflex, your answer will be atrium wall, right? And which atrium wall? Particularly the right atrium wall. Due to any condition, if there is stretching of the right atrium, okay, this Bain-Bridge reflex will be activated, or you can say this stretch receptor will be activated. So there are stretch receptor in the right atrium wall also. Due to any condition, if there is stretch on the right atrium, then right atrium stretch receptor will be activated and that will initiate Bain-Bridge reflex. What is going to happen? It is basically, whenever it is activated, it is going to inhibit the parasympathetic system of the heart. If you increase the parasympathetic system of the heart, what will happen to your heart rate? Your heart rate will be increased. That's why we say that typically in case of Bain-Bridge reflex, heart rate will be increased. If you look at book, the book will typically say that Bain-Bridge reflex is whenever you infuse normal saline in an experimental animal, the heart rate increases. So whenever you are infusing normal saline, suppose you are infusion of normal saline, NaCl, what will happen? There will be increase in venous return. Whenever there is increase in venous return, what is going to happen? There will be increased stretch on the right atrium. And whenever there is increased stretch on the right atrium, the stretch receptor will be activated. That will lead to inhibition of the parasympathetic system of the heart. And inhibition of the parasympathetic system of the heart means there will be increase in heart rate. So due to any condition, if the right atrium is stretched, so obvious answer in this question is right atrium engorgement, right? So this is Bain-Bridge reflex. Now, whenever we are talking about Bain-Bridge reflex, you know, sometimes we get confused along with the Basal-Gerys reflex. So look at here. So I told just now that the Bain-Bridge reflex, where the receptor is located, right atrium wall, the location of the receptor. In case of Basal-Gerys reflex, the receptors are located in the ventricular wall. Which ventricular wall? The left ventricular wall mainly, along with the septum of the ventricle. Got it? So this Bain-Bridge reflex receptor, this is the receptor which detects stretch of the right atrium, means it's a volume receptor. It's a volume receptor, right? And this volume receptor detects the stretch on right atrium. But this Basal-Gerys reflex receptor, these are chemoreceptor. So this chemoreceptor are located in the left ventricle, right? So the left ventricle is perfused by coronary arteries, same for the right ventricle also. If there is presence of certain chemical in the coronary arteries which is perfusing the left ventricle, those chemicals name you must have to remember. Like for example, serotonin, okay? Serotonin, veratridine, okay? Capsaicin. If these chemicals are present in the left ventricular wall, okay, left coronary artery blood, what will happen? The receptor which are present on this wall will be activated, and whenever these receptors are activated, what is the response? There will be severe hypotension. There will be severe hypotension. There will be severe bradycardia, right? Along with that, there will be coronary vasodilatation. Not only coronary vasodilations, along with that, there will be sudden onset of apnea, and it will be followed by a hyperventilation phase also. So apnea followed by hyperventilation, all of these things are seen in case of basal-Gerry's reflex activation. So obviously you can understand that this basal-Gerry's reflex activation will occur only in selective condition. Selective condition means if these chemicals are present in the coronary artery, particularly the left coronary artery. And what is the source of these chemicals or this serotonin, capsaicin, veratrin? Certain cases of myocardial infarction, you know that when the myocardial infarction is happening, the muscles is dead. And if you try to reperfuse the myocardium, sometimes the dead cell releases this kind of chemicals. Or the basal-Gerry's reflex can also be activated during whenever you are injecting certain dye in the coronary artery for the performance of the coronary angiography. During that time also, the basal-Gerry's reflex can also be activated. So these are the scenario where the basal-Gerry's reflex can be activated. And when this Bainbridge reflex will be activated, I told you already that due to any condition, if there is increase in venous return to the right atrium, then there will be activation of the Bainbridge reflex. In case of Bainbridge reflex, the main response is increase in heart rate only. Okay, the cardiac output, the blood pressure is not going to change much in case of Bainbridge reflex. Only the heart rate will increase if the Bainbridge reflex is activated. But basal-Gerry's reflex, the response is very dramatic response, right? So all of this response has been written here. Please be careful. The questions will be asked in future also, right? Okay. So look at here. This question, a scientist has performed an experiment and recorded bradycardia and hypotension, right? So there is decreased blood pressure also. There is decreased heart rate also. Now you exclude one after another. Basal-Gerry's reflex, it happens. Bainbridge reflex, there is increase in heart rate. So this is not my answer. Bainbridge reflex is not my answer. Cushing reflex, just now we have discussed, although that there will be increase in blood pressure and there is decrease in heart rate. So this is typical of the Cushing reflex. And if the chemoreceptor is stimulated, that is the chemoreflex, I told you blood pressure will rise and heart rate may decrease also, heart rate may increase also. I told you already. So now we can understand that none of this, the Bainbridge reflex, the Cushing reflex or the chemoreceptor reflex, none of this reflex is matching with our finding or the matching with the scientist. So obvious answer here is the basal-Gerry's reflex, right? Which is causing bradycardia as well as hypotension. Very careful whenever you are attempting this kind of questions. Okay. Now next is the certain questions on hemodynamics in cardiovascular system. You know that there are different types of blood vessels in our body. Sometimes it is asked the Wien-Kessel vessel. So Wien-Kessel vessel means the blood vessels which contain huge amount of elastic tissue. They got expanded and followed by elastic recoiling. And who are they? The arch of aorta. Okay. Arch of aorta is typical examples of Wien-Kessel vessel, right? Then conduit vessel. These are the vessels which only conduct or transmit the blood from one part to the different part of circulation, and the arterial system, artery, are known as the conduit vessels. Resistance vessel, we all know that this is an important MCQ. Resistance vessels are nothing but the arterioles, and these arterioles are also known as the vessels which is responsible for distribution of blood volume in different organs. So this is the vessels which is also responsible for distribution of blood volume in different organs, right? Next is the exchange vessel. We all know that capillaries are known as the exchange vessels, and capacitance vessels, we know that the venous system, the vena cava, they are known as the capacitance vessel because they have huge capacity to store blood. Now apart from that, the last part is written shunt vessel. Okay. AV anastomosis, shunt vessel. What is the property of this shunt vessel? They contain thick muscular wall and richly innervated by nervous system. So there will be severe or strong contraction and relaxation of these vessels. And where they are located? Tip of the finger at the level of ear lobule. These are the location where these normal shunt vessels are located. Okay, that's all about these different types of blood vessel. Now look at here. This question is based on some hemodynamics mathematics, right? So a 22-year-old man has a muscle blood flow of 250 ml per minute. He has a mean arterial pressure of 130 and muscle venous pressure is 5 millimeter of mercury. Calculate the vascular resistance. So I can imagine a diagram like this. So this side is the arterial side, and this side is the venous side, and in between there is capillary. So in this question they are saying that the arterial pressure is 130 millimeter of mercury, right, and venous pressure is 5 millimeter of mercury, right, and they have also given that the blood flow is 250 ml per minute. What I have to calculate? I have to calculate the resistance. So we all know the Ohm's law, that is saying V is equal to IR. So if we apply this Ohm's law in case of cardiovascular system, V is the potential difference. V is the potential difference means difference of pressure between this arterial end minus this venous end, means P1 minus P2 is the potential difference of V. I is the blood flow in case of cardiovascular system. The blood flow is given here 250 ml per minute, right? So P1 minus P2 is how much? 130 minus 5. So this is 125, okay, millimeter of mercury. What I have to calculate? I have to calculate this R. So this R is nothing but the resistance. So resistance is V upon I. So V here is 125 millimeter of mercury and I is 250 ml per minute. So obviously we can understand the answer is 0.5 ml per minute per millimeter of mercury. So this way the questions will be asked from this hemodynamic part. You have to be a little careful during calculation. That's all. Okay. Now the next question is also a calculation. Calculate the change of resistance in a vessel after 50% decrease in radius of the vessels. So suppose due to atherosclerosis, the coronary vessel radius or diameter is reduced to 50% of the original. Which formula you are going to apply here? So you have to calculate the resistance, but you cannot apply the Ohm's law here. Rather than applying Ohm's law, you know that there is another law which is known as the Hagen-Poiseuille's formula or Poiseuille's-Hagen law, right? So Poiseuille's-Hagen formula. According to this formula, the resistance is equal to 8 eta L by pi R to the power 4. This is the eta. Eta is nothing but the viscosity, and this is L. L is nothing but the length of the vessels where you are calculating the resistance, and pi is pi and R is the radius. So basically I can understand from this formula that the resistance is inversely proportionate to the radius to the power 4, right? So this is the actual formula. So whenever your radius, suppose the original radius of a blood vessel is R. After 50% decrease of radius, okay, so 50% means half, okay, so what will happen? New radius is R minus half R. That means now it is 1 upon 2R. So what will happen? I have to calculate the resistance. It will be equal to 1 upon 2R to the power 4. So this is nothing but 16 times 2 to the power 4, right? 2 to the power 4 means this is 16 times. So whenever there is reduction in radius of a vessel to 50% or half radius decrement, what will happen? There will be increase in resistance, and how much increase? 16 times, right? 16 time increase in resistance. So blood flow will reduce to 16 time, because we know V is equal to IR. More the resistance, more will be the decrease in blood flow. Okay, so this is the calculation. Now with this formula, there is another MCQ which has been asked in AIIMS entrance examination. So here the question is a little bit more difficult. Two blood vessels has been given, A and B, right? So look at the question, A and B. The length of the blood vessel A is 2L and the diameter is 2D, and the B vessel has a length of L and the diameter is D. So basically I can understand that in this question, if I compare A with B, so vessels A, the resistance of vessel A in comparison to B, how to calculate? So I have to apply this formula 8 eta L by pi r to the power 4. So this eta, this viscosity of the blood has not been given, and this pi, it is a fixed. So I can understand that in this equation, the changing that is happening is the change in length also, and this r also. So we have just seen in this question that the A vessel has 2d diameter and length is also 2l. So length is 2 times than that of the B, and radius is 2 times than that of the B. Okay, so if I do like this, then I can understand that the resistance of A in comparison to B will be how much? 2 upon 2 to the power 4. That means 2 to the power is 16. So 2 upon 16 means 1 upon 8. That means I can understand that the resistance of A is 1/8 of resistance of B. Right? Got it. Now question is asking calculate the flow rate, blood flow rate. I told that blood flow rate is the inverse of the resistance, right? So what will happen? The blood flow in A will be 8 times than that of the blood flow in B. Okay, because A has a resistance which is 1/8 of resistance of B. So the blood flow in A will be 8 times greater than that of B. So this way you have to answer the kind of question, right? And lastly, the types of blood flow. So we have just seen that the blood flow is inverse of resistance. But if I want to understand that whether the blood flow is occurring smoothly without any noise or with noise, then there are 2 types of blood flow. One is laminar blood flow, and one is turbulent blood flow. So laminar blood flow means the blood will flow, the velocity of the blood flow will be maximum at the center, followed by there will be reduction in the velocity in both sides. So it will follow a parabolic profile. But whenever the blood flow is not following this kind of pattern, the blood flow direction is in different direction like this, then that is known as turbulent blood flow. We all know that the turbulent blood flow produces some noise. It's a noisy, and this laminar blood flow is silent. But question is not that. Question is the probability of turbulence depends on a number, and that number is known as the Reynolds number. So please note down that more the increase in Reynolds number, more will be the probability of turbulent flow, right? So the Reynolds number Re is calculated by rho dV upon eta. So this is the formula. So I can understand more is the density of the blood, that is rho, more is the diameter of the vessels, more is the velocity of the blood flow, more will be the turbulence probability, because more the Reynolds number, more will be the probability of turbulence. So I can understand that more the diameter, more will be the probability of turbulence, more the velocity, more will be the probability of turbulence. But between these 2 parameters, you remember that the velocity is most important parameter than diameter in determination of the turbulent. So whenever this Reynolds number is greater than 3000, it is said that always there will be turbulent flow. And if the Reynolds number is less than 2000, right, then there will be laminar flow. There will be laminar flow only. And if the Reynolds number is in between 2000 to 3000, then you cannot be 100% sure that whether the flow will be laminar or turbulent. Okay, that's all you have to remember here. Now sometimes we also asked about a term which is known as the critical velocity. So critical velocity is that velocity beyond which the flow is always turbulent. So you have seen here that velocity is the most important parameter in determining turbulence. So if you determine a velocity that beyond that velocity the blood flow is always turbulent, whatever may be the diameter, whatever may be the other parameter, then that velocity is known as critical velocity. So velocity above which the blood flow is always turbulent. Now the last, you look at this table
So there are multiple numbers, and this number sometimes asked in database type of question. Like for example, they'll ask you that maximum blood flow occurs in which organ? Your answer is liver, right? So please note down at least this information. Then maximum artery venous oxygen difference. You note down here that it is the muscles of the heart. Okay, rest of the body forget. So this is the muscles of the heart, that is the maximum artery venous oxygen difference. Then maximum oxygen consumption. One unit is ml per minute. Okay, and here you can find out again the answer is liver. But whenever the question is maximum oxygen consumption, okay, and the unit is ml per 100 gram of tissue per minute, then the answer is the heart muscles. Okay, again the heart muscle is the answer. And then the percentage of total cardiac output is delivered to which organ maximally? Again your answer is liver. So at least you remember this many information for you.
The selective questions have been asked in MCQ, so you have to quickly revise these two topics and always read endocrinology with the help of medicine. So first there is an MCQ, which statement about peptides or protein hormone is usually true. So you know two major groups of hormones are there, proteins and peptides, and the steroid one. So steroid, they are lipophilic, they can easily cross the plasma membrane, and after crossing the plasma membrane they attached with their receptor, which is generally located either in the cytoplasm or within the nucleus. But protein group of hormone, they cannot cross the plasma membrane, so their receptor must be present on the cell membrane. So the first thing, they have receptor on the cell membrane. This is absolutely and true statement about the protein hormone. Now the second thing is that whenever the receptor is present on the cell membrane, whenever you are stimulating the receptor, it will activate one second messenger system, and through the second messenger system the onset of action of the hormone is very rapid. So protein group of hormone, they have very rapid onset of action. But steroid group of hormone, you know, the steroid group of hormone, they ultimately act through gene expression, genomic expression. So whenever you want to express genes and followed by protein expression, it takes long time. So the action is completely slower in comparison to the protein hormone. So the protein hormone has a slower onset of action. This is a false statement. They are not stored in endoplasmic reticulum. So protein, they are generally produced by rough endoplasmic reticulum, and they are packed inside certain vesicles or granule at the level of Golgi body, and they are secreted from this granule. So they are generally stored, they are not stored. This is also a false statement. And if I look at the first statement, they have longer half-life. So we all know that protein hormone, normally they remain free in the blood, and whenever one hormone is free in the blood, their half-life will be less because they can easily be excreted from the blood. So this is also a false statement. So answer of this question is B, right? So protein hormone means they normally generally remain free in the blood, so short half-life, membrane receptor, faster action, and they secreted as a granules. Okay. Now second, all of the following hormone have intracellular receptor except. So again, this is one of the question where they have asked multiple times that what are the hormones which have intracellular receptor. Intracellular receptor means receptor may be present at the level of cytoplasm also, receptor may be present at the level of nucleus also. I hope all of you know, right? But whether the receptor is present at the level of cytoplasm or nucleus, ultimately the hormone receptor complex will act through nucleus only. That's why sometimes we say they are nuclear receptor. But according to the location, it may be cytoplasm or it may be nucleus. Now, all of the following hormone has intracellular receptor except. So this thyroid hormone has intracellular receptor. This glucocorticoid steroid hormone also has intracellular receptor. This androgen also have intracellular receptor. So answer is obviously glucagon. The classification of the hormone receptor. So we are discussing that membrane receptor is there for protein or peptide groups of hormone. The membrane receptor again can be classified into 5 different subcategories. What are they? GPCR. This is nothing but G protein coupled receptor. Guanine cyclase receptor, tyrosine kinase receptor, cytokine receptor, and serine kinase receptor. I will give you the examples of all of this hormone, but the detailed mechanism will not be discussed in this brief discussion, right? Then second is the intracellular receptor. Intracellular receptor means these hormones will act through the nucleus. That's why sometimes we say as a whole that this is nuclear receptor. But they are asking controversial question that intracellular receptor means whether the receptor is actually located within the cytoplasm or within the nucleus. And this is one of the most important controversial area where different books has given different answer. Okay, but what I follow or what I have given the references in my main lecture also, that nuclear receptor, the receptor directly present in the nucleus for thyroid hormone, vitamin D and vitamin A receptor. So there is controversy regarding this vitamin D receptor, but I am telling you with some reference also, and there are other books also which are saying that vitamin D is cytoplasmic receptor. On the other hand, cytoplasmic receptor, this is a glucocorticoid receptor, mineralocorticoid receptor, androgen receptor, estrogen and progesterone receptor. All of them have their cytoplasmic receptor. Again, there is a controversy regarding this progesterone, but you can follow any of the teacher which you are believing, right? So don't waste your time by putting into your controversy. So now next is that when the hormone is a G protein, when the hormone has a membrane receptor, I told you that there are different sub variety, 5 different subtypes. Look at, if the hormone is acting through a G protein coupled receptor, so the G protein first it will be activated, then the G protein can be of different type. If it is stimulatory G protein, then it is known as the alpha GS alpha basically. So there are alpha subunit, beta and gamma subunit in the G protein. So you know that alpha subunit, if it is stimulatory G protein, then it is known as alpha S. Inhibitory G protein, alpha I. And there is another type of G protein which is known as the alpha Q, GQ type of G protein. So this is GQ type of G protein, this is GI type of G protein, and this is GS. So GS means stimulatory. It will stimulate the AC, adenine cyclase, that is an effector. And through this effector stimulation, the second messenger that will be increased is CAMP. GI means it will inhibit the adenine cyclase and CAMP will be decreased. And when it is GQ, it will stimulate the phospholipase C. Through the phospholipase C, DAG and calcium will be increased. So this is one of the important area where you can find out that calcium is one of the messenger system in this pathway. And through this messenger system, what is happening, ultimately the physiological effect of the hormone will be seen, right? So we have to remember the hormones which are acting through this GS, okay, which is acting through this GI and which is acting through the GQ. But among these three, the most important is that I have to remember what are the hormones which act through GQ type of G protein coupled receptor. Now I told you the second group of receptor is the tyrosine kinase type of receptor. So here is the guanine cyclase type of receptor. I will tell you the examples of this. Tyrosine kinase type of receptor, it can activate 2 different intracellular pathway. One is RAS, RAP and MAP kinase pathway, and second one is the AKT and MAP kinase pathway. You just try to mug up this information for the time being, okay, because it is rapid revision. So the hormone which act through this RAS, RAP and MAP kinase pathway is the epidermal growth factor and the nerve growth factor, right? And AKT and MAP kinase pathway, insulin and IGF are the hormones. Similarly, the cytokine receptors, okay, this is analogous to the tyrosine kinase receptor. It activates the intracellular pathway that is known as the JAK-STAT pathway. Very, very important for MCQ. I have to remember growth hormone and prolactin. They are the tyrosine kinase analogous receptor and they activate the JAK-STAT pathway. And serine kinase receptor, they activate the SMAD pathway. SMAD pathway, what are the hormones which are acting through this SMAD pathway? MIS, that is the Mullerian inhibitory substances, and activin. So these are the brief discussions of all the membrane receptor putting into a single slide. You try to remember that what are the hormones acting through them. I will tell you the detail. Okay. Now, rather than membrane receptor, if you look at the steroid hormone receptor, okay, so because that's the lipophilic hormone, they can easily diffuse through the cell membrane. So this is the hormone which has entered into the cytoplasm. Now the receptor of the hormone can be located directly at the level of cytoplasm, as you can find out here, or the receptor of the hormone can directly located at the level of nucleus. But whether it is at the level of cytoplasm or at the level of nucleus, whenever the hormone attaches with its receptor, ultimately the hormone receptor complex has to translocate at the level of nucleus. And after reaching at the level of nucleus, how it is going to act? It is going to act via gene expression. That's why we say that the steroid hormone, typically they have genomic action. Typically they have genomic action because they act through expression of various genes. And steroid hormone, they are nuclear receptor, because whether the cytoplasmic receptor is there or nuclear receptor. Ultimately, the function is happening through nucleus. So sometimes broadly we say they are the nuclear receptor, they have nuclear receptor. But question specifically asked that whether the nucleus is already present in the cytoplasm or already present in the nucleus. Okay, that type of question has been asked, which we have already discussed. Okay, now you look at the examples of different hormones. So I told you that G protein coupled receptor, it can be GS or GI or GQ. I told you specially that you have to remember the names of hormone in the category of GQ. What are the hormone? TRH, GnRH, GHRH, growth hormone releasing hormone, oxytocin, ADH, acting through V1 receptor. Please remember, ADH has V1 and V2 receptor. V2 receptor act through this. Okay, that is the CMP, increased CMP. But V1 receptor, they act through this IP3DG, and IP3DG means ultimately the calcium is going to be released. Okay, not only that, the alpha-1 adrenergic receptor and acetylcholinergic M1, M3 and M5 receptor, they are also examples of this GQ type of G protein. This is very, very important. I told you already many questions has been asked from this area. Okay, now second is that guanine cyclase receptor. This is also important for MCQ. What are the hormones that act through guanine cyclase receptor? ANP, atrial natriuretic peptide, and the second one is the endothelin derived relaxation factor, which is nothing but the nitric oxide. So basically ANP and this endothelin derived relaxation factor, these are the two names that you have to remember for guanine cyclase receptor. Then I told you earlier, already these examples we have discussed, that under tyrosine kinase receptor, the intracellular pathway can be this MAP kinase pathway, AKT pathway also, or it can be RAS, RAP, MAP kinase pathway also. So it is RAS, RAP and MAP kinase, then the hormones are epidermal growth factor and nerve growth factor, and this insulin and IGF-1, they act through the MAP kinase and AKT pathway. I told you the more important is the JAK-STAT pathway. Through this pathway, the growth hormone and prolactin act. This is a cytokine kind of receptor, but it is analogous, similar to the tyrosine kinase receptor. And the serine kinase receptor activate the SMAD pathway. The hormones which act through this is the activin, TGF-beta and Mullerian inhibitory substances. So, in endocrine physiology, you know, the most important thing is this hormone receptors. Okay. Other things, some part you can easily answer from the knowledge of your medicine. But this receptor part you must have to read from physiology at least. Okay. Now look at this. MCQ regarding a 45-year-old woman has a mass in the sella turcica, compresses the portal vessel. Got it? Okay. Disrupting the pituitary access to the hypothalamic secretion. So we all know that if this is the hypothalamus, there is a pituitary stalk. Through this pituitary stalk, anterior and posterior pituitary is there. So all of these anterior pituitary trough cells, they are basically under the stimulatory control from hypothalamus. So hypothalamic hormone generally stimulate them, but except one, which is under the inhibitory control, and that is nothing but the prolactin. So whenever there is disruption of this stalk by any tumor or anything, what will happen? All of the stimulatory pathway will be cut down. So all the secretion of all hormone like the ACTH, like the TSH, all of them will be decreased. But the prolactin was under inhibitory control. So what will happen? The prolactin level is going to be increased. So that's why the secretion rate of which of the following is most likely to increase. Your answer will be prolactin. Okay. So look at this, whole control has been given here. So gonadotropin releasing hormone. Okay. It is acting at the level of pituitary for production of LH and FSH, stimulatory control. TRH, it is acting at the production of TSH, it is also stimulatory control. But look at here, the dopamine, which is controlling the prolactin production from anterior pituitary, it is under inhibitory control. So this dopamine is coming from the hypothalamus. It is known as the prolactin inhibitory factor. Okay, normally it is inhibiting the prolactin production from anterior pituitary cells, right? But here you look at GHRH, growth hormone releasing hormone. It is a stimulatory for the anterior pituitary growth hormone production, but somatostatin is also there, which is an inhibitory for this growth hormone production. So for the growth hormone, both stimulatory and inhibitory factor are there. And CRH, it is a stimulatory for the ACTH production from anterior pituitary. And for posterior pituitary, you all know that ADH and oxytocin is there. But one thing you have to remember here. See here, there is one bypass pathway. The TRH, generally it stimulates the TSH production. But if the TRH is very high, like for example, suppose on primary hypothyroid patient, TRH level is very high, then this TRH can stimulate the production of prolactin. So in case of primary hypothyroid patient, if the TRH level is very high, prolactin level can also increases because TRH gives additional stimulation to this prolactin hormone secretion. Got it? So these are the things that you have to remember for your MCQ. Now, which of the following condition or hormones would most likely increases growth hormone secretion? So whenever it is growth hormone, you have to remember that growth hormone increases your blood glucose level. So any stimulus which is decreasing your blood glucose level, hypoglycemic condition, that is a stimulus for growth hormone secretion. Okay, so hyperglycemia is not a stimulus. If you are doing exercise, your cellular hypoglycemia will be there, so it will increases the growth hormone secretion. Yes. Somatomedin is the mediator of the growth hormone. Somatomedin is also known as the IGF. So growth hormone generally produces somatomedin from the liver, and somatomedins do some of the actions of growth hormone. It is a mediator of the growth hormone action. Somatostatin is an inhibitor of the growth hormone production. So only answer that is possible here is exercise. So I must have to remember that what are the stimulus for growth hormone production, because this has been asked multiple times in MCQ. So number one is the hypoglycemia. Okay, one of the most potent stimulus for growth hormone production. Second is the increased amino acid in the plasma. So whenever you are taking protein containing food, meal, your amino acid level in the blood will be high, and that's a stimulus for growth hormone secretion. Third is any kind of stressful stimulus, whether it is mental stress or physical stress, surgical or traumatic stress, that will also increase your growth hormone. And the fourth one is the sleep. So in sleep, you particularly remember, it is the non-REM sleep which is the stimulatory. REM sleep is the inhibitory for growth hormone. Although REM sleep is a stimulatory for prolactin hormone, LH hormone, FSH hormone, right? REM is a stimulatory, but REM is an inhibitory for growth hormone. Please remember, this is very important for MCQ. Okay. Now, last thing that you have to remember about growth hormone is growth hormone functions. This has also been asked in multiple MCQ. So, growth hormone has some direct action. So, all the yellow color boxes that has been given here, they are the direct action of growth hormone. Means growth hormones are doing all of this job. Okay. So, increase bone growth, increase protein synthesis, increase sodium and water absorption, okay, decrease glucose uptake in the cells, so it is a diabetogenic hormone, increase insulin resistance. So all of these are done by direct action of growth hormone, right? But growth hormone stimulate the liver and it produces IGF, insulin like growth factor, which is also known as the somatomedins. And through these somatomedins, what the growth hormone is doing, it is increasing the protein synthesis. It is increasing the protein synthesis in the muscle. It is increasing protein synthesis in the chondrocyte, as well as it is also doing the anti-lipolytic activity. So please remember all of these actions. You may get MCQ from here. Okay. So next is, which physiological response is greater for T3 than T4? So basically you are doing a comparison between T3 and T4. So what we know from our basic knowledge, T4 is a major hormone which is secreted by the gland, but T3 is more active than T4, right? So these are the basic things which I keep inside my mind. So secretion rate from thyroid. So which of the following is greater for T3 than T4, right? So secretion rate from thyroid, no, it is greater for T4, okay? So T4 is greater than T3 here. Plasma concentration, obviously T4 secreted more means plasma concentration will also be more. Plasma half-life, T4 has a half-life of 7 days and T3 has a half-life of 1 day. So all these are more in case of T4. Affinity for nuclear receptor, this is more in case of T3 than T4, because whenever your affinity is more for the receptor, your onset of action, your rapidity of action, okay, will be also more stronger. So that's why we know that T3 is more active, okay, more faster onset of action than T4. Okay, so T3 is more active and more faster than T4. Okay, so look at this difference between T4 and T3. So this is T4 and this is T3. So T4, as you can find out here, secretion is more, 80 microgram per day, but here it is only 4 microgram per day. Plasma concentration 8 nanogram per dl. Here this is only 0.15 nanogram per dl. In case of half-life, 5 to 7 days in case of T4. It is only 1 day in case of T3. But look at potency. So T4 is slower and T3 is faster. Potency is less potent. It is 3 to 5 times more potent. Binding to thyroid hormone receptor, less affinity binding, more affinity binding. So these are the important things that you have to remember between T3 and T4. Okay. Next, a person presented with puffy skin and lethargic. So this is giving an indication that the person may be suffering from hypothyroidism. His TSH level are low and are improved on administration of TRH. So when the TSH level is low, what I will think? I'll think that the problem may be at the level of pituitary, so pituitary is damaged, or maybe the hypothalamus is damaged because the hypothalamus is not producing adequate amount of TRH. That's why the TSH level is less. So the problem may be at two levels, maybe at the hypothalamus, maybe at the level of pituitary. Now the second part of the question is saying that TSH levels are improved on administration of the TRH. So whenever you are giving TRH injection externally, TSH level is rising. So where from the TSH is producing in these cases? Obviously pituitary. That means pituitary is absolutely normal in these cases. But the problem lies at the level of hypothalamus. So these are typical cases of hypothyroidism because the patient is presented with the puffy skin and lethargic. But hypothyroidism is not due to problem at the level of pituitary. Problem is at the level of hypothalamus. Hypothalamus is not producing adequate TRH, that's why TSH low, that's why T4 is also low, and the person is suffering from hypothyroidism. So this kind of hypothyroidism is known as tertiary hypothyroidism, where hypothyroidism because of hypothalamic defect is the typical answer. Whenever we classify the hypothyroidism or hyperthyroidism, you have to look at the three types: primary hypothyroidism, secondary and tertiary hypothyroidism. So whenever I am saying primary hypothyroidism, problem is at the level of thyroid gland. Secondary, problem is at the level of pituitary. Tertiary, problem is at the level of hypothalamus. Now look at, if there is primary hypothyroidism, so problem is at the level of thyroid gland is destroyed. So which hormone production will be decreased at the beginning? T4. So that's why I put it into circle. But if the T4 is less, so negative feedback on pituitary and hypothalamus will be less. So if the negative feedback is less, what will happen? TSH will rise and TRH will also rise. Got it? So that's why TSH, TRH is high but T4 is low. This is typical of primary hypothyroidism due to thyroid problem. But if the pituitary is damaged, so the first hormone that is going to be reduced in this condition is the TSH. So that's a problem is arising from here. Problem is arising from here. So in the first cases, problem was arising from T4, but here the problem is arising from TSH. So pituitary is defective, TSH is not there, so T4 will also be decreased. So that's why again the person will suffer from hypothyroidism, right? But this hypothyroidism is originating at the level of TSH problem, which is secondary hypothyroidism, and the TRH will be high because the negative feedback is not there. But in case of hypothalamic defect, the problem is originating from here. TRH is low, that's why the TSH is low, that's why the T4 is low. So again the person is hypothyroid, but this is tertiary hypothyroidism. Problem is originating at the level of hypothalamus. Very, very important. Similarly, hyperthyroidism, primary thyroid problem, secondary pituitary problem, tertiary hypothalamic problem, right? So primary means T4 is high because of the thyroid gland problem. Secondary hypothyroidism means T4 is high because of the TSH is high. And tertiary means hypothalamic TRH is high. That's why the TSH as well as the T4 level is very, very high. So these are the basic concept about the different types of hypothyroid disease that you have to remember is here. Now next question, in comparison to normal healthy person in the evening time, which among the following have elevated both ACTH and cortisol? So if you compare with the evening level, which of the following has more ACTH and cortisol level? So we all know that cortisol as well as ACTH has a diurnal variation. Okay, it's follow a circadian rhythm. There is an diurnal variation. What do you mean by diurnal variation? Means the highest amount of ACTH as well as cortisol is released at the level of morning. So cortisol ACTH level is high. That's why cortisol level is also high. This is at the level of morning time, particularly at 8:30 am. And the minimum level or the lowest level of ACTH as well as the cortisol is seen at which level? At the in and around midnight level, in and around midnight, right? So this variation, this fluctuation will follow a 24-hour rhythm, means it is high at 8:30 am in the morning, again it is low in midnight, again it is high at 8:30 am in the morning. So this is 8:30 am in the morning, this is also 8:30 am in the morning. If I ask you what is the gap between these two peak points, obviously the gap is approximately 24 hours. This kind of rhythm is known as the circadian rhythm or diurnal rhythm. So in comparison to this evening level, morning ACTH level and morning cortisol level will be higher, obviously. So if I look at this question, in comparison to normal healthy person in the evening time, so in the evening time ACTH and cortisol level is low, okay, ACTH and cortisol level is low in a normal healthy person in the evening. In comparison to this, just after awakening in the morning, so in the morning time ACTH and cortisol level will be high. So this is a true statement. Then a person who is suffering from Cushing disease. So Cushing disease means we all know that it is Cushing syndrome due to pituitary adenoma. So pituitary adenoma is producing huge amount of ACTH. Because of the huge amount of ACTH, the cortisol level is very, very high and the person is suffering from Cushing syndrome. So this is also a true statement, means a person who is suffering from Cushing syndrome or Cushing disease, not the Cushing syndrome, the Cushing disease, the ACTH and cortisol level is also very, very high in comparison to the evening level of ACTH and cortisol. So both are true. But if I look at the difference, then in case of Cushing disease, the ACTH and cortisol level will be very, 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 very high in comparison to normal person. So if I have to choose a single best answer, I'll go for the Cushing disease. Although just after awakening in the morning, it will also have a higher value of cortisol and ACTH in comparison to the evening value of ACTH and cortisol. Got it? So this is the answer of this question. Okay. Now coming to the next, which is not seen in case of ACTH deficiency. So if there is ACTH deficiency, what will happen to the production of the adrenal cortical hormone? Adrenal cortical hormone will be production will be very, very low, and that can sometimes leads to secondary addition disease. I'll show you. Okay, I'll tell you. But note down here. Which of the following is not seen in? Remember, if the ACTH level is very, very high, then it cross-react with the melanocortin receptor type 1 and it stimulates the melanocyte, which causes hyperpigmentation. So when this hyperpigmentation will be seen, if the ACTH level is very, very high. So hyperpigmentation in case of ACTH deficiency is not a feature. Rather, if the person is suffering from ACTH deficiency, there will be severe pallor rather than hyperpigmentation. So this is the answer of this question. But I am telling you that this question can be answered in a different way also, that if the ACTH is deficient, then the person can also suffer from secondary adrenal insufficiency, as it is written here. It is the consequences of dysfunction of the hypothalamo-pituitary axis, which suppresses when the ACTH level is very, very low. That is a secondary addition disease. Primary addition disease, that the problem originate at the level of adrenal gland itself. The adrenal gland is destroyed. Why it will be destroyed? It may be tuberculosis of the adrenal gland, it may be autoimmune destruction, or maybe other disease like HIV, metastatic carcinoma, adrenectomy. So in all of this condition, whenever your adrenal gland is destroyed, from the adrenal gland, the glucocorticoid hormone which was produced, will be deficient. The mineralocorticoid will also be deficient. The sex steroid will also be deficient. Right. So whenever they are deficient, what will happen? The hypoglycemia, will be seen. The fatigue, the weight loss, the muscle and joint pain will be there. In case of mineralocorticoid deficiency, hypotension is one of the important feature. Postural hypotension will also be there. And sex steroid, lack of energy will be there. Dry and itchy skin will be there. But remember that if it is primary adrenal destruction, that is the typical addition disease, then what will happen? Because the adrenal cortex is destroyed, ACTH level will be very high because of the loss of negative feedback. So ACTH level, whenever it is excess, I already told that hyperpigmentation of the skin is going to happen. But in case of secondary adrenal insufficiency, okay, generally it is not known as addition disease. The primary one is known as addition disease. So in case of secondary adrenal insufficiency, this hyperpigmentation is not going to be seen because here the ACTH level is low, and because the ACTH level is low, the person will suffer from additions like symptoms, adrenal insufficiency. Getting my point? So these are the symptoms of addition disease, which is nothing but primary adrenal deficiency. Now next is, which hormone has permissive role in puberty? Okay, so question is permissive role. Permissive role means, the presence of certain hormones is required for full functions of other hormones. So leptin, it cannot helps in onset of puberty. Okay, the main hormone which is responsible for the onset of puberty is the GnRH. We say that pulsatile release of GnRH is responsible for, or one of the main cause of onset of puberty. But certain amount of leptin, small amount of leptin is essential for proper functioning of this GnRH hormone. This kind of functions is known as the permissive action. So leptin per se cannot causes onset of puberty, but presence of leptin is essential for full function of this GnRH hormone. That's why we say that leptin has permissive role for GnRH, permissive role for onset of puberty. So you have to remember certain information about leptin because this is one of the important topic in MCQ. Leptin releases from white adipose tissue, fat cells. So whenever your fat cells masses is more, blood level of leptin will be also more. So if the person is fat, fatty person, the leptin level in the blood will be higher. And if the person is lean and thin, then the leptin level in the blood is low. But look at, more the adipose tissue mass, more is the amount of leptin that I already told. Leptin sends anorexigenic signal, satiety signal to the hypothalamus. So if a person is very fatty person, obese person, leptin level is already high in the blood, and that leptin is giving a signal to the hypothalamus that please reduce your food intake because you are already obese, right? So that way, please remember, whenever the person is obese person, leptin level is high, but leptin sends anorexigenic signal to hypothalamus. Got it? Okay. Leptin also stimulates thermogenesis, and leptin has permissive role in the onset of puberty. It regulates the circadian rhythm of the gonadotroph cells, and it also increases the pulsatile rate of GnRH secretion, because I was telling that this pulsatile release of GnRH is one of the essential feature of onset of puberty. Now next, after ovulation, corpus luteum releases which of the following hormone? We all know that after ovulation, the corpus luteum releases progesterone hormone. So this is a direct answer. Full development and function of the seminiferous tubules. So seminiferous tubule has receptor for FSH. Single most important hormone which is required for seminiferous tubular development is FSH, but along with FSH, testosterone is also required. So androgen and FSH will be best answer in this question. So option number D is the answer here. Now in male, testosterone is secreted from. So this kind of similar questions is asked from the reproductive physiology. Don't look at me that said these questions are very simple. This kind of questions have been asked in NEET entrance examination also, and in future also from reproductive physiology questions will be simpler. Got it? So what you have to remember, you can understand from here that for male reproductive system, at least I have to read about the Sertoli cell, at least I have to read about the Leydig cells. So look at, so this is the cross section area of the testis where you can easily find out the location of this Sertoli cell. So this is the location of the Sertoli cell. Okay? So this is one of the Sertoli cell, and this is another Sertoli cell here. Okay, so these two Sertoli cell, they are connected with one another by a cytoplasmic bridge, and that produces a barrier which is known as the blood testis barrier. So blood testis barrier is formed by the Sertoli cell. Please remember this Sertoli cell, right? Okay. Now the Sertoli cell, is one of the important cells which is responsible for proper development of the spermatogenesis. Okay, proper development process of spermatogenesis. And outside this, outside this basal lamina, you can find out another cells, and this is nothing but the Leydig cells. So Leydig cells, we all know that LH has receptor on this cell, and the FSH has receptor on this Sertoli cell. And this Leydig cell is going to produce the testosterone hormone. Then this testosterone hormone will enter inside this compartment and it will help in the spermatogenesis process. This is the basic thing. So what I have to remember? I have to remember about Sertoli cell, I have to remember about Leydig cell. So Sertoli cells, I told you that it forms a blood testis barrier. It nourishes and protects the developing sperm. Okay, and it contains the receptor for FSH and androgen. They also produces androgen binding protein. What is the importance of this? So whenever this testosterone from the Leydig cell is entering inside the compartment, this testosterone has to be attached with some binding protein, and that is nothing but androgen binding protein. Which cell is secreting them? The Sertoli cell is going to secrete them. So please remember that they also secrete androgen binding protein. Sertoli cell express aromatase enzyme, very important. And this aromatase enzyme can convert the testosterone which is entering here. That testosterone can be converted into little amount of estrogen, and this estrogen has also important for spermatogenesis process. Now the Sertoli cell also produces extracellular matrix component and also produces Mullerian inhibitory substances. Inhibin B is also produced by the Sertoli cell, which is one of the most important testicular contribute to the negative feedback suppress of FSH. So we all know that FSH stimulating the Sertoli cell will produce inhibin B will inhibit the FSH production negative feedback process. Now the Leydig cell on the other hand, so Leydig cell is going to produce the testosterone, steroidal hormone. So what is the raw material for steroidal hormone? The cholesterol. So this Leydig cell can synthesize this cholesterol de novo, as well as it can acquire the cholesterol through this LDL and HDL receptor. So the scavenger receptor is present on this Leydig cell, through which it can take the LDL from the blood, or it can synthesize LDL de novo within the cell. Okay, and from this cholesterol ultimately the testosterone is going to be formed. But the enzyme which is required for special production of this testosterone is the 3-beta hydroxysteroid dehydrogenase, that you also have to remember. Now next is that we already told that testosterone diffuses into the seminiferous tubule, and some of the testosterone can be converted into estrogen by aromatase enzyme, right? Aromatase of the Sertoli cell convert into estradiol, already told. Sperms expresses estrogen receptors. I told you that estrogen is also required for spermatogenesis process. Sperms has this estrogen receptor, and this estrogen helps in acrosome synthesis of the sperm. Got it? Very important. So testosterone is converting into estrogen. Estrogen has its receptor on sperm cells, and how estrogen is helping in spermatogenesis? By synthesis of the acrosomal cap. Now the last questions of this rapid revision is one question from practical physiology, practical MBBS. Okay, Rees-Ecker fluid is used as a diluent for which of the following pipette? So as you can find out here, this is an hemoglobin pipette, this is an RBC pipette. I hope all of you know that in RBC pipette the marking here is 101 and here it is 1, and in WBC pipette here it is 1, here it is 11. So this is the WBC pipette, and in hemoglobin pipette there is only one marking, that is 20 microliter, right? And the last one, all of you know from your pathology knowledge that this is nothing but Windrobe tube. Okay, so Windrobe tube marking, we all know that in one side 0 to 10 and in the other side 0 to 10. So this kind of marking on both sides is present. This is Windrobe tube. So now you tell me, Rees-Ecker fluid is used for which of the following thing? You know, Rees-Ecker fluid is used for counting platelet, and this platelet is counted in RBC pipette. So that's why the RBC pipette here is B. So the B is the answer in this question. So how to remember? You just have to remember the name of certain fluid which is used for different cell counting. Like for example, hemoglobin estimation is done by Sully's acid hematine method, where HCl, n by 10 HCl is used. Another method is also there for hemoglobin estimation, that is the cyan-meth hemoglobin method, where Drabskin solution is used. At least you remember these two names. Okay. Now for RBC counting, Haem's fluid is used typically, which is nothing but an NaCl solution. Sometimes formalin citrate can also be used. Okay. For WBC countings, the fluid that is used for WBC counting is Turk's fluid. Okay. And for platelet counting, ammonium oxalate and Riesecker fluid, these are the solution that is used for platelet.
What are the important topics that you have to read in central nervous system? So first, one MCQ in front of you. This MCQs has been asked in NEET 2021 examination. So look at the MCQ. So there is a detailed history of a patient has been given, and ultimately the diagnosis is also given, that the diagnosis is multiple sclerosis. Now the question is, which cells are commonly affected in such condition? So we all know that multiple sclerosis is a demyelinating disease of central nervous system. So in central nervous system, myelination is done by which cell? All of us know that the cell which forms myelination in central nervous system is oligodendrocyte. And all of you also know that this Schwann cell is responsible for myelination in the peripheral nervous system. So PNS myelination is by Schwann cell and CNS myelination is by oligodendrocyte. So whenever there is death of this oligodendrocyte, there will be demyelination in central nervous system, and one of such disease condition is multiple sclerosis. Now another extra thing that you have to remember here, that there is a little bit difference between CNS myelination and PNS myelination. So in PNS myelination, the Schwann cell is responsible for myelination of a single neuron, means one Schwann cell is dedicated for myelination of a single neuron. The ratio is 1:1. But in case of central nervous system, one oligodendrocyte is responsible for myelination up to 30 neurons, okay, which can go maximally up to 50 neurons. That's why we can understand that in case of CNS, the myelination, one neuron is giving myelination on multiple neuron, 1:30 ratio. But in case of PNS, one neuron is dedicated for a single neuron, not only single neuron, for a single node of Ranvier. So this extra information you have to remember for your future MCQ. Now next question, again a MCQ, which is similar like that of the previous MCQ. Here also the disease that has been asked is multiple sclerosis, but the question here is a little different. The question is nerve conduction velocity. So in case of demyelination, the conduction velocity of nerve impulses will be low in compared to the normal myelinated neuron. We all know that. So question is, what may be the possible cause? So we have already seen that multiple sclerosis means there is death of oligodendrocyte. So loss of oligodendrocyte is a true statement. But loss of oligodendrocyte is not directly responsible for conduction velocity lowering. So conduction velocity depends on myelination. So whenever there is death of this oligodendrocyte, there will be loss of myelin sheath of the neuron, and because of this loss of myelin sheath, the conduction velocity of neuron will be reduced. So the best answer in this question will be B, loss of myelin sheath. So all of you know that you have to remember that conduction velocity of action potential on a neuron depends on two main important things. One is the diameter of the neuron. More the diameter, more will be the conduction velocity. And second thing is the myelination of the neuron. More the myelination, more will be the conduction velocity of neuron, right? So here the question is directly asking about the low conduction velocity in multiple sclerosis. So answer is loss of myelination. Now one extra information that you have to remember, that in case of multiple sclerosis, the oligodendrocyte cell is destroyed. Why there will be destruction? So this is an autoimmune disease where T cells attacks the oligodendrocyte cell in the central nervous system, and because of which there will be demyelination, right? So the nerve conduction is interrupted due to demyelination, we have already discussed. Now one important thing here you have to remember, antibody. Okay, so T cells is attacking the oligodendrocyte. So antibody against the myelin basic protein and several other component of myelin like myelin oligodendrocyte glycoprotein MOG are also responsible for demyelination. So these are the antigen against which the antibody is produced, right? So the antigen is which one? Myelin basic protein is one of the antigen and second is the MOG. These are the two important antigen against which the antibody is directed in case of multiple sclerosis. So this is also important to remember for future MCQ. So next we are going to discuss most important things of synapses. So all of you know that synapses in the central nervous system may be excitatory in nature or maybe inhibitory in nature. So if the synapse is excitatory in nature, suppose this is the presynaptic neuron and this is the postsynaptic neuron, we know that the neurotransmitter in between these two neuron is the glutamate, that is the excitatory synapse. Similarly, if you look at the inhibitory synapse, so the presynaptic neuron and the postsynaptic neuron, the neurotransmitter here in most of the cases is GABA or it may be glycine also, right? And if you are thinking of the peripheral nervous system, so peripheral nervous system means neuromuscular junction, where one motor neuron, suppose this is the terminal of the motor neuron, will make a synapse with the muscle membrane. So suppose this is the muscle cell, it will make a synapse with the muscle membrane. So now you have to quickly revise that what are the glutamate receptor that will be present in the postsynaptic membrane. In my lecture, I have discussed this glutamate receptor in detail, but for the timing, at least you remember three names. That is the glutamate receptor NMDA, second one is KAI-NAT kinase, and third one is the AMPA. These are the three main inotropic receptor of the glutamate that you must have to remember. Coming to GABA. So GABA, all of you know that there are GABA A receptor, GABA B receptor, and GABA C receptor, right? And glycine is only one type of receptor, so there is no subdivision. At the level of neuromuscular junction, the receptor, all of you know that the receptor is acetylcholine receptor. What kind of receptor they are? They are nicotinic muscle variety or NM variety of receptor. So this you have to remember. All of you know that the neurotransmitter here in the motor neuron is obviously acetylcholine and the receptor is acetylcholine receptor, which is the nicotinic variety of receptor, nicotinic muscle variety, right? So this is the basic bottom line that you have to remember. Now on to this, you look at if the glutamate is released from the presynaptic neuron, it will act on the receptor here, and what it is going to do? It is going to generate a local potential here in the postsynaptic neuron. Similarly, if the GABA is released from the presynaptic neuron, again it is going to produce a local potential in the postsynaptic neuron. And in case of neuromuscular junction, if the acetylcholine is released from this motor neuron terminal, it is also going to produce a local potential at the level of neuromuscular junction. So this local potential is generated in all these three types of synapses, but the local potential which is produced by the glutamate is excitatory in nature. The local potential which is produced by GABA is inhibitory in nature, and the local potential which is produced by acetylcholine, this is also excitatory in nature, but depending on the location, the name of this local potential is different. So what are the names? You have to remember, one is EPSP, one is IPSP, and one is MEPP, the motor end plate potential. So this EPSP is the local potential of excitatory synapses. IPSP is the local potential of inhibitory synapses, and MEPP is the local potential of neuromuscular junction. So I can go back here. So this local potential is known as excitatory postsynaptic potential. This GABA mediated local potential is known as inhibitory postsynaptic potential, and this neuromuscular junctions, the potential is known as motor end plate potential or MEPP. Now you have to remember that what is the ionic basis of all of this local potential. So this EPSP, the ionic basis is there will be entry of positively charged ion into the postsynaptic neuron. Positively charged ion, like for example, it can be sodium entry, or it can be of calcium entry, or it can be entry of both sodium and calcium. So I'm writing here entry. So it can be entry of positive ion in the form of sodium, or calcium or sodium calcium combined, right? Or EPSP can also be generated by closure of potassium channel. So whenever potassium channel is closed, we can understand that positive charge will remain more into the neuron, so there will be depolarization. So this EPSP is an excitatory postsynaptic potential. This is a kind of local potential, so I can write down here, this is a local depolarization. So what is EPSP? It is a local depolarization. Now coming to the next one, that is the IPSP. What is the ionic basis? Ionic basis is that negative charge ion will enter into the postsynaptic neuron. Like for here, the negative charge ion is going to enter here. And what is the most common negative charge ion that is going to produce IPSP? That is the chloride entry into the postsynaptic neuron. Although IPSP can also be produced by opening of more and more potassium channel. So whenever potassium channel is open more than normal, so excess potassium will go out of the cell, excess positive charge will go out of the cell, and inside of the cell will be negative. So that's why we say that IPSP is a kind of local potential. But what kind of local potential? Local hyperpolarization of the postsynaptic neuron. It's a negative potential, hyperpolarization, right? The membrane potential will go more negative in comparison to RMP. That's why the local hyperpolarization. And coming to this MEPP, motor end plate potential. So this is the potential which is generated in the muscle membrane, which is known as the motor end plate. And this is mediated by entry of which ion? Sodium ion. This sodium is entering through which channel? This is entering through AChR, acetylcholine receptor channel, which I already told you that it is a nicotinic type of receptor, right? So this sodium entry into the muscle membrane is producing a local depolarization. It is producing a local depolarization at the neuromuscular junction, and this local depolarization is known as motor end plate potential. So this EPSP, IPSP, motor end plate potential, all of them are local potential. I hope all of you remember, local potential means it's a kind of non-propagated potential, right? So please revise with me. Non-propagated potential, it does not follow all or null law. This is also important. And this is a kind of decremental potential. In my actual lecture, I have discussed the detail, but for the timing, you remember at least these three property of the local potential. So that is all about the synaptic potential in central nervous system and peripheral nervous system, right? Okay. Now move on to next. So now you are seeing MCQ in front of you. So there is a figure. This figure has been taken directly from the Genong's textbook of medical physiology. So the question is, this is an example of which type of connection is seen between these two neurons. So if you note down this diagram carefully, so this is a neuron, right? So the neuron is giving a branching here, and this branching is making a synapse with another neuron, and that neuron is making synapse onto the same neuron. So if I simplify this diagram, it's a diagram from Genong. If I simplify, so suppose this is a motor neuron, right? So motor neuron means this is located at the level of spinal cord. So this motor neuron is giving a branching. This branching is acting on a neuron, and this pink color neuron is acting on the same neuron. So whenever this motor neuron is stimulated, it is going to stimulate this pink color neuron, and the pink color neuron itself is an inhibitory neuron which is going to inhibit the motor neuron. Getting my point? So whoever is stimulating you, you are going to inhibit onto them, right? So this is a typical scenario which is known as negative feedback type of inhibition. Getting my point? So obviously it's not a positive feedback inhibition, it's not a feed forward inhibition, this is not a presynaptic inhibition. So this pink color neuron which I have highlighted here, so this is the pink color neuron that I have made here. This neuron is known as RNSHW, Rensa cell neuron. Getting my point? Very, very important. So this pink color neuron that I have made here, this is an inhibitory interneuron. This inhibitory interneuron is known as Rensa cell. Okay. So the Rensa cell releases a inhibitory neurotransmitter that is glycine. And by the release of this glycine, it is going to inhibit the motor neuron which is stimulating the Rensa cell. So this kind of inhibition is known as negative feedback inhibition, and Rensa cell inhibition is also known as recurrent inhibition. Getting my point? So you have to remember two important word about Rensa cell inhibition. It is a negative feedback inhibition and it's an recurrent inhibition, right? Recurrent inhibition. These two important things that you have to remember here. Now coming to the next. Again, you are finding out a image-based question here. Okay. So with the help of this image-based question, we are going to discuss one important topic in the central nervous system, that is the adaptation phenomena. So look at this diagram carefully. So what you are finding out here, it is written neural spike train. What is the meaning of this? Spike means this is nothing but the action potential. So all of the diagram that you are finding out here, this, all of this is what? This is nothing but recording of action potential. So the single line that has been given in this diagram, this single line indicate this is the action potential, the depolarization and repolarization of the action potential. Getting my point? So these are the action potentials. So how many action potential? So 1, 2, 3, 4 action potential you are finding out in this diagram. 4 action potential, right? So these are the action potential. Now if you look at the bottom line of this diagram, here it is written stimulus. So here is stimulus, here is also stimulus, this is also stimulus, this is also stimulus. Means all these 4 are similar kind of stimulus. So similar kind of stimulus is given in 4 different types of receptor, but 4 different types of receptor behaving differently. In one I can find out action potential, followed by there is no action potential. In one I am finding out action potential is present throughout the stimulus. In one I find out action potential only at the beginning, followed by there is no action potential, and in another one continuous presence of action potential, right? So we have to understand this phenomena. So look at, first I am drawing this stimulus one. So suppose this is the stimulus. Okay, so what do you mean by this stimulus? I have explained that if the stimulus is drawn like this, it indicates that you are giving more and more increasing strength of stimulus. Suppose I am giving touch. So what is touch? Touch is indentation. So suppose I am giving more and more indentation on your skin. How much indentation? Suppose 1 millimeter, 2 millimeter, 3 millimeter you are measuring. Suppose 1 millimeter, 2 millimeter, 3 millimeter indentation you have given. So you are giving a constant touch on skin. After 3 millimeter indentation, if you are holding the stimulus for long duration, it is indicated by this plateau. Okay, followed by you are releasing the stimulus. Releasing the stimulus means you are withdrawing this touch, right? So this is the meaning of this stimulus. So again I am explaining. So you are giving more and more indentation, then you are holding the same indentation for a long time, and then you are releasing the indentation from the skin. This is the meaning of stimulus. Now, whenever you are giving this kind of stimulus, if I record the action potential from the receptor, okay, actually it is not from receptor, it is the neuron which is connected with the receptor. So what you are finding out, suppose you are finding out that initially you are getting action potential, but when you are holding the stimulus for long duration, for a long time, you are not getting any action potential. Again, when you are withdrawing the stimulus from the skin, again you are getting the action potential. But in the second case, suppose you are getting action potential from the beginning also, as well as you are getting action potential whenever you are holding the stimulus for long duration. Getting my point? So you are holding the stimulus for long duration, same amount of stimulus, same strength of stimulus, but you are continuously getting same kind of action potential throughout the time period, right? But in the first cases, you are getting action potential only at the beginning of the stimulus, but not when you are holding. So what is happening? In the first cases, whenever you are holding the stimulus for a long time, the receptor has been modified itself. And because of the modification of the receptor, the neuron is not generating action potential. And if the neuron is not generating action potential, you are not going to percept, okay, perception of the stimulus will not be there. This phenomena is known as adaptation phenomena of receptor. So what I told, just take an example. I gave this example in my lecture class also. Suppose you are holding the hand of your girlfriend or boyfriend for the first time. So whenever you are touching the skin for the first time, the stimulus is like a lightening sensation. But if you are holding his or her hand for long duration, you are not going to feel the same amount of stimulus after maybe 1 hour. Why? Because the receptor on your skin will modify, will adapt itself so that the neuron is not going to generate action potential, and if the neuron is not generating action potential, your brain is not able to perceive the sensation. This phenomena, when the receptor is modifying itself, although the stimulus is present, but the receptor is modifying itself, this is known as adaptation phenomena. In the second cases, the receptor is not adapting for this long duration of time. That means the adaptation may happen, but it is not happening within this span of time. So this kind of receptor is known as slowly adapting receptor. Why slowly adapting? Receptor will adapt, but it will take long time. Okay, all receptor will adapt except the pain receptor. But this receptor is not adapting quickly. But in the first cases, the receptor is quickly getting adapt, and that's why it is not generating any action potential on the neuron. This kind of receptor is known as rapidly adapting receptor. Rapidly adapting receptor. So now all of you know that the rapidly adapting receptor for the touch, what are the rapidly adapting receptor? Pacinian corpuscles and Meissner's corpuscles. Okay, Meissner's corpuscles and hair end organ. These are the rapidly adapting touch receptor in the body. And slowly adapting touch receptor in the body. Who are they? Merkel's, right? Merkel's, Ruffini's, right? Ruffini's, and your free nerve ending. So you must have to remember this, right? Now among all of them, the most rapidly adapting receptor is Pacinian corpuscles. So with this information, now I am going back to the diagram. Now I have to look at this recording of action potential very closely. How many action potential I am getting? Because the stimulus is same in all of this diagram. So with the same amount of stimulus, I can find out that this receptor is producing 1, 2, 3 action potential, followed by there is no action potential. The diagram A, it is also producing action potential 1, 2, 3, 4, 5 action potential, followed by there is adaptation. So in case of C, there is only 3 action potential, followed by there is adaptation. In case of A, 5 action potential, followed by there is adaptation. So what do you think? Between this A and C, which one is the most rapidly adapting? Obviously C. That's why it is adapting very quickly. After generation of only few action potential, it is adapting. So the C is the most rapidly adapting touch receptor in our body, and that is nothing but your Pacinian corpuscle. That's why the answer is Pacinian corpuscles here. Okay, followed by A will be the examples of Meissner corpuscles, and this B and D, they are the slowly adapting receptor. You're getting my point? That's why you are not getting any adaptation phenomena here. The action potential is coming, okay, at a same rate. So this is the phenomena of adaptation. So what you have to remember? You have to remember that what is the meaning of this adaptation phenomena, which I have already explained. So just read this line, that if the stimulus is present, what kind of stimulus? Suprathreshold means the stimulus will be able to produce action potential, but due to some changes in the receptor, it is not capable of producing action potential, and that is adaptation phenomenon. Now, apart from this adaptation, you all know that there is a confusing term which is similar to this adaptation, which is known as accommodation. So, accommodation refers to a gradual increase in threshold caused by prolonged, slowly rising subthreshold stimulus. So see here, the word difference here is the suprathreshold stimulus, and in case of accommodation, subthreshold stimulus. Subthreshold stimulus means your stimulus is not capable of producing action potential. If you give subthreshold stimulus and you are rising that subthreshold stimulus gradually, slowly you are giving a subthreshold stimulus to a neuron or any kind of tissue, what the tissue will do? The tissue will get angry and the tissue will increase the threshold. Okay, as if you are giving, okay, you are poking the neuron more and more, okay, that you are disturbing the neuron. Okay, and what the neuron is doing? Neuron is getting angry and he is raising his threshold. So whenever you give a slowly rising stimulus, okay, neuron is getting angry and he is raising its threshold, and that is nothing but accommodation phenomena, right? So for accommodation phenomena, your stimulus should be threshold and slowly rising stimulus. But for adaptation phenomena, your stimulus should be supra threshold and it should be present for a long duration, right? So these are the two things that you must have to remember. Very, very important, right? Okay, chalo, next. So now next, we have already discussed that the touch receptor are of rapidly adapting receptor and slowly adapting receptor. Now we have already discussed that the rapidly adapting touch receptor in our body, right? Rapidly adapting touch receptor. Who are they? They are Pacinian corpuscles. Here it is written, as you can find, Pacinian corpuscles, Meissner's corpuscles, and hair end organ. Now we have to remember some specific things about this receptor. Pacinian corpuscle, what is the thing that I have to remember? It is the largest tactile receptor, it is the most sensitive touch receptor, and the best stimulus for the Pacinian corpuscle is vibration. Please note down. If the question is what is the best receptor for vibration, your answer is Pacinian corpuscles. Although you can find out vibration can be detected by this Meissner corpuscle also, as well as vibration can also be detected by this Merkel's also. But in these two receptor, okay, so Merkel's can also detect vibration, but the frequency of vibration is very, 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 very slow. Okay, Meissner's can also detect vibration, but the frequency of that vibration is only 50 Hertz. So please note down that this Pacinian corpuscles, okay, I have to remember that it is the largest tactile receptor. For Meissner's, this is the most numerous, maximum touch receptor that is present in your body is Meissner's. And the best stimulus for the Meissner corpuscle is moving touch. So when the touch is moving on your skin surface, that is best detected by Meissner's. But Meissner's specialty is that it is present only in the non-hairy skin, glabrous skin, right? Non-hairy skin, right? Please note down. And hair end organ, it can also detect moving touch, but the skin, hairy skin should be there. So if a touch is moving on a non-hairy skin, that the receptor is Meissner's. But if something is moving on your hairy skin, then the receptor is hair end organ. So these two receptors detect the movement, moving touch, right? Merkel's, it is located at the level of epidermis. So this is the only touch receptor which is located in the epidermis. All other touch receptors, what has been written here, they are located in the dermis. So Merkel's is located in the epidermis. The other name of Merkel's receptor is ego-dome receptor, and the best stimulus for the Merkel's is point. Okay, so if you are touching some point on your skin, or you are feeling the corner of the table, edges of the table, the best receptor to feel these things are Merkel's. Rufinis, the best stimulus for the Rufinis is stretch on your skin. So if you place some large object on your skin, there will be stretching. This stretching is best detected by Rufinis. So whenever you are holding some large object on your hand, the size and shape of that object is best detected by Rufinis. And free nerve ending is dedicated for itching and tickling type of touch sensation. So this is one of the most important slide in central nervous system, different types of touch receptor. Please note down. So tactile receptor is the receptor for detection of touch and pressure. The maximum number of tactile receptors are present at the level of tips of the finger, right? So tips of finger, this is the area where maximum number of touch receptors are present, followed by your lips, right? So this lips. So fingertips followed by lips. These are the two areas where touch receptors are maximally present, right? Now, whenever we are discussing the touch receptor, we have to discuss two things. One is receptor for braille reading and receptor for two-point discrimination. Believe my word that for both the cases, the answer is Merkel's, right? Merkel's. I have given the reference here and I have given the detailed discussions. Why? Merkel's is the best receptor for both reading braille also as well as 2-point discrimination also. So whenever your question is 2-point discrimination, your answer is Merkel's is the best receptor. Whenever your question is what is the best receptor for reading Braille, your answer again is Merkel's. But along with Merkel's, you also require another receptor which is nothing but Misnard's receptor. But if you have to choose best one, then Merkel's is the answer. Getting my point? So this is all about the touch receptor that you have to read. Now after touch receptor, you look at two questions, two MCQs are projected here. These two MCQs are related to proprioceptors. So what are the proprioceptors? You know what are the proprioceptors? Proprioceptors are the muscle spindle, Golgi tendon organ, and the joint capsule receptor. These three are the proprioceptors in our body. The most important proprioceptor is muscle spindle. All of you know that proprioceptors are those receptors which gives you sensation of the joint in three-dimensional position, that whether the joint is in flexed condition or in extended condition, right? So this is proprioceptor. Now you look at the question and answer. So Golgi tendon organ of skeletal muscle detect what? We all know that it detect tension. So GTO, Golgi tendon organ, it is responsible for detection of increased tension at the level of muscle tendon, right? So muscle tendon, whenever it is taut, whenever it is stretched, the Golgi tendon organ will be activated. Muscle spindle of the skeletal muscle is dedicated for, so muscle spindle can detect increase length of the muscle, or it can also detect the change in velocity of the muscle. So velocity is nothing but length upon time. So whether it is changing length or whether it is changing length upon time, that is velocity, both can be detected by muscle spindle. So here the best answer is both length and velocity of the muscle is detected. Right. So now you look at the brief discussion of these two important receptors, that is muscle spindle and Golgi tendon organ, because this is very, very important. So all of you know that the muscle spindle is located within the main muscle belly. And why it is known as spindle? Because the organ, the receptor, looks like a spindle in shape. That's why this is known as muscle spindle. So in this diagram, you can find out that this blue color diagram, this is nothing but muscle spindle. The fiber, the muscle fiber, which forms this muscle spindle, they are known as the intrafusal fiber. So intrafusal fiber is forming the muscle spindle, and it is the non-contractile fiber. Non-contractile fiber, meaning that this fiber is not going to give strength of contraction of the skeletal muscle. So muscle spindle is not for contractile strength. It is only for certain sensation. What sensation? Length and velocity of muscle sensation, right? So this intrafusal fiber is basically forming the muscle spindle. On the other hand, the Golgi tendon organ, where they are located, the Golgi tendon organ are located in the muscle tendon, but actually it is not within the tendon. It is the tendon muscle junction. So what you have to remember about Golgi tendon organ, GTO is located most commonly in 95% cases, it is located at the tendon muscle junction, that is in 95% cases, and in 5% cases it is located within tendon. So within tendon it can also locate, but that is only in 5% of cases. Getting my point? So these two important information you have to remember. Now Golgi tendon organ, we have already discussed that it is activated by increased tension within the tendon, right? There is another question about Golgi tendon organ. So we can find out that Golgi tendon organ is composed of many fibers only. So how many fibers are there inside a single Golgi tendon organ? Remember, GTO consists of 10 to 15 fibers inside it, right? So how many fibers are forming a single Golgi tendon organ? On an average 10 to 15. But what about this muscle spindle? How many fibers are forming the muscle spindle? So look at muscle spindle composed of two types of fibers. So I'm writing here muscle spindle. So what type of fiber are forming the muscle spindle? Intrafusal fiber. So intrafusal fiber are of two types. One is nuclear, very important thing, nuclear bag fiber, and second one is the nuclear chain fiber. In a single muscle spindle, 2 to 3 nuclear bag fiber will be there and 5 to 9 nuclear chain fiber will be there, right? So this nuclear bag fiber, depending on the functions, it can be of two types. That is, one is dynamic nuclear bag fiber and one is the static nuclear bag fiber. But nuclear chain fiber, they are always static in nature. So the dynamic bag fiber, they are responsible for detecting the velocity of the muscle. We have already discussed. Okay. And the static fiber, they are responsible for detecting the increased length of the muscle. They are responsible for detecting the length of the muscle. So remember that bag fiber, it can detect velocity also, it can detect length also. But this chain fiber, they can only detect the increased length of the muscle. Right. So this muscle spindle, they are located within this muscle belly, and what they are detecting? They are detecting length and velocity of the muscle by dynamic fiber and static fiber. Now there should be some afferent neuron from this muscle spindle. Obviously, there has to be some afferent neuron which should be connected from this muscle spindle. That is also important. So please remember that the afferent fiber which originate from this dynamic bag fiber, static bag fiber, and static chain fiber, from all of them, one afferent neuron is there that is known as 1A type of afferent. So this 1A afferent is known as the primary afferent of the muscle spindle. But there is a secondary afferent also, and that originate only from the static bag fiber and static chain fiber. And this is which type of fiber? This is type 2 fiber. Type 2 fiber is also known as secondary afferent fiber from muscle spindle. This primary afferent is also known as annulospiral ending. Annulospiral ending. And secondary fiber is also known as flower spray ending. You must have heard about this word, flower spray ending. So these are the basic minimum that you must have to read about the muscle spindle. Getting my point? Very good. Okay. Now coming on to the next topic. Next topic is the thermoreceptor. So the proprioceptors are done. Okay. Now coming to the thermoreceptor. So thermoreceptor, you can easily understand that it can detect the cold and hot, temperature receptor. So these receptors are located at the level of free nerve ending. So at the end of the neuron where there is no myelination, that portion is known as a free nerve ending. So at the tip of this free nerve ending, okay, there are some ion channels which can detect temperature also as well as pain sensation also. Temperature and pain, right? And those are known as the thermoreceptor and nociceptor. So they are the channels basically which are located at the tip, at the bare end, at the free ending of the neuron. So thermoreceptor, there are two types. So one is cold receptor and one is warmth receptor. What I have to remember? Cold receptor, they are activated from a temperature of 10 degrees centigrade up to 40 degrees centigrade. So what I am telling? Cold receptor, they are active from 10 degrees centigrade temperature up to 40 degrees centigrade temperature. But you look at what temperature the cold receptor is maximally active. You look at this graph. This graph is maximum at which temperature? In and around 25 degree. So your answer will be 24 degrees centigrade. So if the question is cold receptor is maximally active at which temperature? 24. Similarly, look at about the warm receptor or hot receptor. They are activated from 30 degrees centigrade. They are increasing their activation, maximum activation at here, and then the activation is decreasing and it is 0 at 50. So if I ask you what is the working range of warm receptor, your answer will be from 30 degrees centigrade to
50 degrees centigrade, and the maximum activity of this warm receptor is at 45 degree centigrade. So these are the two important things that you have to remember about thermoreceptor, not many things, right? Now, if the temperature is beyond this zone, suppose if the temperature is below 10 degrees centigrade, so below 10 degrees centigrade temperature or greater than 50 degrees centigrade temperature, in these cases, the nociceptor or the pain receptor is going to be active rather than thermoreceptor. All of you have perceived that if something is touching your skin, which has a temperature of 100 degrees centigrade, will you feel hot or will you feel pain? Obviously, that's painful. So that's why whenever the temperature is very, very high or very low, rather than thermoreceptor, nociceptor is going to be activated, right? So nociceptor, it's known as polymodal receptor. So what I told, nociceptor, they are known as polymodal receptor. What do you mean by polymodal receptor? Polymodal receptor means the receptor can be activated by multiple modes of stimulus. Multiple mode means it can be activated by mechanical stimulus, right? As you can find out here, it can be activated by thermal stimulus, or it can be activated by chemical stimulus also. You have seen that some chemical injury to the skin can also produce pain. Mechanical injury to the skin can also produce pain, or thermal injury, just now we were discussing, can also produce pain. So that's why pain receptor is a polymodal receptor. I told you already what is the location of the pain receptor. It is similar to the thermoreceptor, that it is located at the level of free nerve ending. But I told you already that free nerve ending contains certain kind of channels, and these channels are basically the thermoreceptor as well as nociceptor. So what is the ion channel responsible for detection of mechanical pain, right? So please note down this important discussion here. So if the mechanical pain is there, the receptor or the ion channel responsible for it is TRPA1 type of channel. TRP stands for transient receptor potential channel, transient receptor potential channel, right? So this is very, very important thing, very, very emerging thing that you have to remember. Second, mechanical pain, okay, or mechanical stimulus can also releases adenosine triphosphate. It can also produce mechanical pain via activation of this P2X and P2Y receptor. Or mechanical stimulus can also activate this MRGPR receptor. It is known as mass-related G-protein coupled receptor. Mass, R for related, G-protein coupled receptor subtype D. This is the receptor which is particularly dedicated for sharp pain. So suppose there is a sharp cut on your skin, you feel pain, and the receptor which is mainly responsible for it is MRGPR, mass-related G-protein coupled receptor. Now, if the pain is produced by thermal stimulus, what are the receptor that is going to be activated? So for cold stimulus, TRPA1, if the temperature is below 17 degrees centigrade, or TRPM if the temperature is from 8 to 28 degrees centigrade. So these are the information that you have to mug up, right? Now, if the temperature is very high, greater than 43 degrees centigrade, or if the H plus ion is present, or if the capsaicin chemical is present, it can activate one ion channel that is known as TRPV1, and that can also give pain sensation. Now, apart from that, TRPV2 is activated when temperature is greater than 52 degrees centigrade, and TRPV3 and V4, they are active at in and around 30 degrees centigrade, which is a normal temperature of our skin, almost normal temperature, right? Now, chemical, we all know that the most potent pain-producing chemical is the bradykinin. The receptor which is activated by this is B1 and B2 receptor. Similarly, other chemical can also produce pain, like for example, serotonin, like for example, acid or H plus ion, and nerve growth factor, neuronal growth factor, nerve growth factor, they can also produce pain via action on this TRK, tyrosine kinase receptor A, right?
Acid can act on ASIC, acid sensing ion channels, and serotonin obviously it acts on 5-HT3 receptor, and it can also produce pain. So these are the chemical which can directly produce pain. Means if there is a tissue injury and if these chemicals are released in the surrounding area, then it can activate the neuron and pain sensation will be produced, right? Getting my point? But there is something which is known as nociceptor sensitizer. Okay, so just now we have discussed that there are certain pain producing substances like bradykinin, serotonin. What is the meaning of that? Meaning pain producing substances are known as nociceptor activator. They can activate the pain producing neuron. But nociceptor sensitizer is little different. Nociceptor sensitizer means they can only increases the sensitivity of the neuron, but per se they cannot produce pain. So what are the nociceptor sensitizer? Prostaglandin, leukotrienes and substance P. Please note down that all these three substances, they cannot produce pain of their own. They can only increase the pain sensation if already the sensation is going on. So already the pain is going on. If these substances are present additionally, it will increase the perception of pain. That is a sensitizer. But pain producing substances we have already discussed: bradykinin, histamine, serotonin and free potassium ion in the extracellular fluid. All of these can produce pain by stimulating the nociceptor. So most potent is the bradykinin, right? Now whenever we are discussing nociceptor and pain, you also have to remember two terms. One is hyperalgesia and one is allodynia. So hyperalgesia is nothing but increased sensation, exaggerated response to a noxious stimulus. Means the stimulus is capable of producing pain, but the person is pursuing the pain to a higher degree. Suppose I am giving like this. Obviously it is producing pain, but not that much. But suppose some person is feeling that this pain is unbearable, then that is your hyperalgesia. But what is allodynia? Look at the sensation of pain in response to a normally innocuous stimulus. Innocuous stimulus means the stimulus is not supposed to producing pain. Non-pain producing stimulus. Suppose touch. Suppose I am giving touch and you are feeling pain. So that is abnormal. That is what? That is allodynia, right? Suppose I am giving a little bit temperature on your skin. Okay, sometimes in the winter season, we take a bath in lukewarm water. But suppose that lukewarm water is giving pain throughout your body. So that is what? Allodynia. So both of these, allodynia and hyperalgesia, both are due to increased sensitivity of the nociceptive fiber. Right? This you have to remember, allodynia and hyperalgesia. Now, also question has been asked that what are the pain sensitive structure in the brain? Just remember this information, that dura around venous sinuses and blood vessels of the brain, cranial venous sinuses with afferent vein, arteries at the base of the brain, falx cerebri, skin, scalp and periosteum, all of them are pain sensitive structure in the brain. But brain parenchyma, ependyma, choroid plexus, pia mater and arachnoid mater, they are insensitive to pain, right? So this is all about most of the somatosensory receptor, and believe me, in central nervous system, one of the important topic is somatosensory receptor. So you have to remember all of this information in a very crisp manner, right? Okay. Now moving on to next is nothing but a question regarding the Brown-Sequard syndrome. So all of you know that in case of Brown-Sequard syndrome, pain and temperature are lost on opposite side of the body, right? And how to answer this? You have to have an idea about various ascending tracts of spinal cord. So what are the different ascending tracts? This is also a must know question. So you know that there are dorsal column pathway and there are anterolateral spinothalamic tract. So dorsal column pathway, they carry sensation of localizing pressure, vibration and fine touch, proprioception and 2-point discrimination. All of these sensation are carried by dorsal column tract. Anterior spinothalamic tract, they are dedicated for crude touch and pressure, okay, tickles and itching, and sexual sensation, all of these are carried by anterior spinothalamic tract. So the pressure, localizing type of pressure is dorsal column, but in general, the pressure sensation is carried by anterior. If you have to choose only one, the best one is the dorsal column for pressure, right? And lateral spinothalamic tract, they are going to carry the pain and temperature sensation. So this is one of the must know area in the ascending tract that you have to remember, right? Okay. Now next is all these ascending tracts, they are going to end at the level of sensory cortex, somatosensory cortex. Now there are three somatosensory cortex in the brain. So look at here, the primary somatosensory area. The primary somatosensory area has a Brodmann number, that is 3, 1 and 2. So these 3, 1 and 2, they are the primary somatosensory area. Then you can also find out here that there is a secondary somatosensory area, which is also known as a somatosensory area number 2. So primary somatosensory area number, that is the 1, and Brodmann area 3, 1, 2. Secondary somatosensory area is also known as somatosensory area number 2, right? The Brodmann number is 40 here. Brodmann number is 40 here. And there is one somatosensory association area also, which has Brodmann number 5 and 7, right? Okay. Now, what is the functions of this different somatosensory area? First of all, the direct function is not known, but scientists, what they have done, they have destroyed, they have seen that in some patient where this somatosensory area number 3, 1 and 2 are destroyed completely, what sensation are lost? That means that is the function of this area. So whenever there is damage to this primary somatosensory area or somatosensory area number 1, the first sensation that is going to be lost are graphesthesia and stereognosis. These are the sensations which are going to be lost at the earliest. But if the question is which sensation will be lost maximally, then your answer will be fine touch and proprioception. These are the two sensations which will be lost maximally. But if the question is what is the sensation which will be lost at the earliest, then your answer is graphesthesia and stereognosis. Apart from this, there will be also loss of localization, means you will not be able to localize that what point I am touching on your skin, right? That is loss of localization. Now coming to this Brodmann area number 40, no functions is found out till date that what is the function of this somatosensory area number 2. Very good. Now coming to this somatosensory association area. Always remember, somatosensory association area is responsible for complex sensation of the whole body image. So I can perceive that my both hands are there, both legs are there, okay, both ears are there. I can image my body in my brain that this is the whole body. But whenever there is damage to this somatosensory area, the person will not be able to get the full image of the body, whole image of the body. This kind of complex sensory loss is known as amorphosynthesis. Getting at the term amorphosynthesis means A means absent, morphosynthesis means the whole body image is lost. The person will not be able to perceive the one side of the body. Suppose there is loss of the somatosensory association area on left side, I will not be able to perceive the right side of the body. Any kind of sensation I am not going to perceive. So what I am going to do, I am going to neglect my whole one side of the body, and that is known as hemi-neglects. So whenever there is damage to this area, there will be hemi-neglects, and the sensory loss is known as amorphosynthesis. Getting my point? Okay. Now coming to the motor cortex. So similar to the sensory cortex, there are motor cortex also. So the motor cortex, look at motor cortex. They are primary motor cortex, supplementary motor cortex, and premotor cortex. So primary motor cortex, it is responsible for, obviously motor cortex means it is responsible for movement. But what kind of movement? Simple and gross movement. So if I am moving my arm like this, so there is a contraction of whole group of biceps muscle and other group of flexor muscle. So there is a group of muscle is contracting. This kind of simple movement can be done by primary motor cortex, which has a Brodmann area number 4. All of you know this, right? Now this supplementary motor cortex, it is responsible for complex type of movement and bilateral movement. So supplementary motor cortex is responsible for complex movement and whenever the movement is occurring bilaterally, right? So if I am moving my both hand bilaterally like this, supination, pronation, then you require the help of supplementary motor cortex along with primary motor cortex. Without primary motor cortex, you are not going to contract your muscle. So primary plus supplementary is required for this kind of movement. Similarly, if you are doing a complex movement, like I'm writing on this iPad. So what is happening? This writing is a very complex thing. There is very fine movement of your finger. This kind of complex movement require primary motor cortex as well as supplementary motor cortex help. Getting my point? Now, premotor cortex is responsible for maintenance of the posture of joint before every movement. So what I'm saying, the premotor cortex is responsible for setting of posture or maintenance of posture of joint before every movement. Like for example, if I want to move my arm like this, I have to stabilize my shoulder joint first. I have to stabilize this elbow joint first. So this stabilization of this joint, this maintenance of posture of these joints before every movement is done by premotor cortex. So premotor cortex has to be activated before any kind of movement. Otherwise, your joint stabilization will not be there. So what is happening basically? If you want to move a simple kind of movement also, you require the help of premotor cortex as well as your primary motor cortex. But whenever you are doing a complex type of movement, obviously premotor cortex is active, primary motor cortex is active, supplementary motor cortex is also active. Getting my point? Please remember this important scenario. So supplementary motor cortex as well as this premotor cortex, they have Brodmann area number 6. So these are the important thing that you have to remember about important brain areas. Apart from this, sometimes if the question is difficult, then they can also ask you regarding this kind of question, that which brain area is responsible for recognition of face. So recognition of face is known as prosopagnosia. Prosopagnosia is inability to recognize face. And which part of the brain is going to be damaged here? The temporal lobe, the inferior surface of the temporal lobe and medial undersurface of both occipital lobe is responsible for recognition of face. So if this area is damaged, prosopagnosia is going to happen, right? Okay. Can recognize a person by voice, but cannot recognize by looking at their face. That is the prosopagnosia. Now, arithmetic calculation, mathematical calculation is done by an important area, that is the inferior portion of the left frontal lobe, right? If the damage is there in this portion, then there will be acalculia. The person will not be able to calculate the simple arithmetic task also. Getting my point? Now the brain area for navigation, right? So if you are going for some kind of shopping, you can easily return to your home by navigating through a particular road. These area in the brain are known as the navigating area in the brain. So right hippocampus is responsible for identifying the location of the place, and right caudate nucleus is responsible for facilitating the movement towards that place. So one is identifying that place, that I have to move in this direction, and one is helping in navigating towards that location. These are the two important brain areas that you have to remember. And you know that this navigation area in the brain is more stronger in case of male. That's why, okay, so whenever you are driving, okay, whether you have felt it or not, but I have seen that my wife and me, okay, regarding the navigation, I am far better than her. So this area is more stronger in case of male person, right? Okay. Now, chalo, move on. So now coming to the difference between upper motor neuron and lower motor neuron, this topic will be also discussed in medicine also, but quickly revise that upper motor neuron, UMN lesion and LMN lesion. What is the difference? All of you know that atrophy is not a feature of upper motor neuron, but severe atrophy or loss of muscle bulk is a feature of lower motor neuron. Fasciculation is not going to happen in upper motor neuron. It is always present. It is mostly present in case of lower motor neuron. Increased tone in upper motor neuron in terms of plasticity and rigidity. Decreased tone will be seen in case of lower motor neuron, right? Then stretch reflex, very important point. Stretch reflex will be hyperactive in case of upper motor neuron. Increased stretch reflex, exaggerated stretch reflex. But in case of lower motor neuron, mostly it is absent or it may be hyperactive also. Muscle group affected. In case of upper motor neuron, regional, but in case of lower motor neuron, mostly distal muscle group, segmental muscle group is going to be activated. And all of you know this Babinski sign, that dorsiflexion of the great toe and fanning of the other toes in case of plantar response is known as Babinski sign. It is the sign in neurology and it is present in case of upper motor neuron. So if the upper motor neuron is damaged, then there will be dorsiflexion of the great toe and fanning of the other toes when you perform the plantar response. But in case of lower motor neuron, plantar reflexes, which is kind of reflexes, superficial reflexes, which will be absent in case of lower motor neuron lesion. Getting my point? So these are the difference between these two. Now you look at another things, that in case of upper motor neuron, the tone will be increased in the muscle in the form of spasticity or in the form of rigidity. There is a little bit difference between this spasticity and rigidity. What are those? So look at spasticity is the term which is generally used for pyramidal tract lesion. All of you know that upper motor neuron is the combination of pyramidal tract and extrapyramidal tract. So if the extrapyramidal tract lesion is there and the tone is increased in that cases, then the typical term which is used there is rigidity. But if the pyramidal tract is causing increased tone, then the typical term is spasticity, right? Now rigidity, you have to remember two types of rigidity mainly. One is cogwheel rigidity, typically seen in Parkinson's disease, and lead pipe rigidity, typically seen in neuroleptic malignant syndrome, right? So in case of cogwheel rigidity, rigidity will be there along with tremor. So there will be multiple catches in between. Okay, like this. Okay, like this. That is the cogwheel rigidity. And lead pipe rigidity means if you want to stretch this joint, there will be constant tension throughout the range of movement. Means there will be increased tension throughout the range of movement. That is typical of lead pipe rigidity. Getting my point? Okay. The detailed discussion I have done in my lecture, you can listen that, and I have explained why this kind of scenario is going to happen. Now, in case of spasticity, you look at the clasp knife spasticity is very important. Okay, clasp knife spasticity. More tone in the initial part of the movement, followed by there will be sudden release of tension. So if you want to open up this joint, initially there will be huge amount of tension, but suddenly this joint will open up. Okay, like a knife opening. So this is typically known as clasp knife spasticity. Spasticity is velocity dependent, okay, but rigidity is not velocity dependent. In case of rigidity, both flexor and extensor muscle group is going to be increased tone, but in case of spasticity, only one group of muscle is going to be affected. So in case of rigidity, both extensor and flexor, both will be rigid, both will be increased tone. Both will have increased tone. But in case of spasticity, only one group, either flexor or extensor, will have their increased tone. That is the difference between spasticity and rigidity. So this is the bottom line things that you have to remember about the upper motor neuron and lower motor neuron lesion. Now coming to one question, which of the following is false about decerebrate rigidity? So one is decorticate rigidity and one is decerebrate rigidity. So the first option which is given here, that is the flexion of the upper limb flexed and lower limb extend. This is the answer in this question. This is false. In decerebrate rigidity, we do not see the flexion of the upper limb like this. This is the typical feature of decorticate rigidity, right? So look at, in case of decerebrate rigidity, the false statement is upper limb flexed and lower limb extended. Both upper and lower limb will be extended. This is obviously a true statement. Lesion between the superior and inferior colliculus produce this kind of rigidity. True. Cutting dorsal root abolishes the rigidity. Yes, dorsal root, okay, that is the afferent which is entering the spinal cord. If you cut this thing, then the rigidity will be lost. The detailed discussion of this, okay, has been done in lecture class, but for the timing, you remember that in case of decerebrate rigidity, there will be extension of all the four limbs And the reason of this extension of 4 limbs is due to activation of pontine reticulospinal tract. So pontine reticulospinal tract is causing extension of all the 4 limbs in case of decerebrate rigidity. But if you cut the dorsal root of the spinal cord here, then the rigidity will be lost, right? But in case of decorticate rigidity, when the damage is at the upper part of the midbrain, upper part of the midbrain is damaged. And in case of decerebrate, pontine superior and inferior colliculus के बीच में there is a damage. But in case of decortication, if you cut at the upper part of the midbrain, then what will happen? Upper limb will be flexed and lower limb will be extended. Upper limb flexion is done by rubrospinal tract and lower limb extension is done by the same pontine reticulospinal tract. So pontine reticulospinal tract. Getting my point? So if the question is who is causing flexion of the upper limb, this is the activation of rubrospinal tract in case of decortication. And who is causing the extension of the lower limb? Pontine reticulospinal tract. In case of decerebration, who is causing the extension of all these 4 limbs? That is pontine reticulospinal tract. Got it? Please remember. Okay. So this is all about the central nervous system. Now the next thing that you have to read in central nervous system is higher functions, right? This is also important, but very selective things you have to read in higher functions. So first you look at plan of movement. Whenever you plan certain kind of movement, right? Who is planning? Okay, just take an example. Suppose there is a mosquito biting on the dorsum of your hand. You are planning to kill this mosquito by moving this arm. Okay, by moving these joints. So who is getting this plan? Who is preparing this plan? Answer is cortical association area. So first brain area that is active during any kind of motor planning is cortical association area. Then this plan will directly divert it to the premotor and motor cortex, but not that all. The blueprint of the plan has to be delivered at the level of basal ganglia and at the level of cerebellum. Which part of cerebellum? Lateral cerebellum, which is also known as cerebrocerebellum. So why these are required? So this basal ganglia and this lateral part of cerebellum, they will give feedback that whether the plan is foolproof or not. Getting my point? Okay, so whenever you are making some plan of action in the government project or any kind of state project also, you want to get feedback from other department. So this basal ganglia and this cerebellum, they are the other department. They will give feedback that the plan that you have made, it is foolproof. Go for the executions. So this way, the brain is planning. So I can understand that the basal ganglia is also responsible for planning and programming. And the cerebrocerebellum or the lateral part of cerebellum is also responsible for planning and programming. And then what will happen? Then the premotor and motor cortex, they are going to execute the movement. Now when the movement is happening, suppose you are moving this joint from here to here. This is a long pathway. So during this actual movement, cerebellum also give feedback from time to time so that during this actual course of movement, no diversion is happening. This way, cerebellum also gives real-time modification of the movement. This real-time modification of the movement is done by intermediate part of cerebellum that is also known as spinocerebellum. So this spinocerebellum is giving real-time feedback during actual movement. By this real-time feedback, it is smoothing the movement. It is coordinating the movement. So that's why we say that cerebellum is responsible for planning and programming also, as well as it is also responsible for smoothing and coordination of the movement also. But basal ganglia is responsible only for the planning, not for the smoothing and coordination part. So look at, according to the functions, we know that cerebellum has 3 subdivisions. One is vestibulocerebellum, which is responsible for balance and posture maintenance. Second part is the spinocerebellum and cerebrocerebellum that we have just discussed. So spinocerebellum is coordination and smoothing of the voluntary movement, and cerebrocerebellum is responsible for planning and programming of the movement. At least you remember these three functions of three different parts of cerebellum. If there is damage to the cerebellum, so cerebellar disorder, what are the features? So there will be hypotonia of the skeletal muscles. There will be no sensory deficit, no abnormality at rest also, except for the change in stretch reflexes. Okay, there will be drunken gait, very important feature. There will be intense and tremor. So whenever you are going to do some activity, suppose there is a glass of water on the table, you want to pick up this glass. So whenever you are at resting condition, the tremor is not going to happen. But whenever you are about to take this glass, the tremor will start. That is intense and tremor. So all of you know that the resting tremor is a feature of the basal ganglia disorder, that is Parkinsonism. But this intense and tremor is a typical feature of this cerebellar disorder. Apart from that, dysmetria, pass pointing, okay, voluntary movement problem. So whenever you want to touch this nose, okay, the action will not be adequate. Dysmetria will not be able to assess where this tip of the nose is located. Rebound phenomena, okay, adiadochokinesia. So rebound phenomena is that suppose I am going to touch my nose and you are resisting. So what I am going to do, I am going to give more and more forces. Suddenly if you release this thing, I can stop my hand before touching the nose. Otherwise what will happen? If you release this, it will touch the nose. So in case of cerebellar disorder, you will not be able to hold this hand before touching the nose. It will strike on your nose, and that is known as the rebound phenomena. Adiadochokinesia is known as alternate movement will be affected. Supination, pronation, rapid alternate supination, pronation. If you do, I can do easily without any problem. But in case of cerebellar disorder, this movement will be problematic. Similarly, decomposition of the movement, smooth, long movement will be difficult. So that is decomposition, as well as there will be nystagmus. Right? So this is the cerebellar disease feature. Now coming to the functions of basal ganglia, we have already discussed that main functions of basal ganglia is planning and programming of the movement. That is the main function of basal ganglia. Apart from that, basal ganglia also has some cognitive functions, right? And the main area of basal ganglia that is responsible for these cognitive functions is caudate nucleus. Please note down this. So prefrontal association cortex is connected with the basal ganglia, and this loop is responsible for these cognitive functions. Not only that, basal ganglia is also responsible for skill and procedural memory. So whenever you are learning some new skill or some procedure, in these cases, the cerebellum and basal ganglia both are required for learning new skill or procedure. Okay? So these are the functions of basal ganglia. Now all of us know that what are the disease which is related to basal ganglia problem, right? So one is hypokinetic disorder, that is a Parkinsonism. We all know that in Parkinsonism, substantia nigra is destroyed, the dopaminergic neuron of the substantia nigra is destroyed. Apart from that, hyperkinetic movement are also seen in basal ganglia disorder. Those are hemibalismus, Huntington disease and dystonia. Hemibalismus, the subthalamic nucleus is damaged. Huntington's disease, the striatum is damaged, and dystonia, the direct pathway of the basal ganglia is damaged. So all of you know that from the striatum, two pathways are there. One is direct pathway, one is indirect pathway. So if the direct pathway is specially damaged, then dystonia is going to happen. If the striatum, the caudate nucleus and putamen, both are damaged, then Huntington disease is going to happen. And if the subthalamic nucleus is damaged, then hemibalismus is going to happen. So these are the things that you have to remember in your brain. Mog up this information just for your exam, right? Okay. Now next is in higher functions, one important area is EEG and hypothalamic nucleus, electroencephalography. Okay, which is related to sleep and EEG. So sleep, EEG and hypothalamic nucleus, these are the two important areas in higher functions, right? So following EEG depict which stage of sleep. So what you are going to do, you first look at the x-axis, that within this 1 second time period, how many waves I am getting. So you are getting multiple waves like this. That means the frequency of this wave is very, very high. So if you are sleeping, so the frequency of the EEG waves would be low. But if it is high, then it is like beta like frequency, because beta EEG wave is seen when the person is awake, and there is a particular stage of sleep when the beta like wave is seen in EEG although the person is sleeping, and that is typical of REM sleep, or the rapid eye movement type of sleep. So with this help of this diagram, you can identify that this is the REM sleep. But again, I will tell you that this is not a very good questions. Okay, for identification of the stage of the sleep, you require the help of EEG also, you require the help of EOG also, electrooculography, and you require the help of EMG also, electromyography. All these three recording should be there in combination, and the study which record all these three parameters in combination is known as polysomnography. So polysomnography is recording of all these three parameters simultaneously. Along with that, SpO2 is also recorded, saturation of oxygen. Along with that, ECG is also recorded. Along with that, breathing movement is also recorded. So these are the secondary recording, but the primary recording in case of polysomnography is these three. So polysomnography is study of sleep. Okay, sleep study. If you want to study the sleep, that which stage of sleep, what is the disorder, okay, disorder of sleep, then you have to do for polysomnography, right? Now next is that different types of waves in the EEG. This is again a must know things. So we remember like this, that beta, alpha, theta and delta. So B-A-T, bat, dance. We remember like this. So if you go from B-A-T, bat, dance, then bat, B or beta wave has the highest frequency among all of them. Okay, among all of them, among these four, beta has the highest frequency, that is 14 to 30 Hz, followed by alpha, which has a frequency of 8 to 13 Hz, followed by theta, 5 to 7 Hz, followed by delta, 2 to 4 Hz. Okay, so these are the frequencies of different EEG wave that you must have remembered. Beta wave is seen when the person is awake and fully alert. This is the main criteria for production of the beta wave. The person should be alert, the person should be awake. Eyes may or may not be open, although it's a criteria, but it's a secondary criteria. The first criteria or the main criteria, the person should be awake and alert. In case of alpha wave, the person is still awake, but he is not alert. Okay, his mind is wandering here and there, he is relaxing and the eyes are closed. This is the typical scenario when beta wave will be converted to alpha wave. Now when the person is entering into the light stage of sleep, or the person is feeling drowsy, okay, his brain is more suppressed. In these cases, you are going to get the theta wave or low frequency wave. And when the person is sleeping in the deep sleep stage, then the delta wave you are going to get in EEG. So what you are finding out? Okay, whenever you are going in deep and deep sleep, the frequency of the EEG wave is decreasing. That's why we say that frequency of the EEG wave is proportionate to brain activity. More the frequency in the EEG, more is the activity in the brain, right? That's why you know that when your brain is very highly active, you are concentrating on something in a focused manner. Like for example, if you are doing meditations, not you, but suppose some yogic meditation is going on. In case of meditation, the brain area, multiple brain area will be highly active simultaneously. This multiple brain area, when they are active simultaneously, this thing is known as bindings in neuron. As if all the neurons in the brains, they are attached with one another. They are binding with one another. This is known as binding of neuron when multiple brain area are active simultaneously, particularly during meditations. During working memory, when you try to remember some information for short duration of time, or you are learning something, or you are doing some problem solving, okay, with some high grade maths, right? So those are the condition when the EEG wave will be converted into a very, very high frequency wave. This is a normal wave, and this wave is known as the gamma wave, which has a frequency of 30 to 80 Hz. So if you are looking at the normal beta, alpha, theta, delta, here the highest frequency of beta is 14 to 30. But if the frequency is greater than 30, that means the brain is highly active due to binding problem in the neuron. What is binding problem? Multiple areas of the brain are active simultaneously, as if there is a binding between neurons in multiple areas. Got it? So this is different EEG waves. Now, apart from this EEG wave, you know that sleep and EEG, they are going in hand by hand. Okay, so sleep are of two types. One is non-REM type of sleep and REM type of sleep. All of you know this thing. When you are sleeping for at a stretch of 8 hours or 6 hours, non-REM sleep is responsible for 70 to 80% of your total sleep duration, and REM sleep is responsible for 20 to 25% of your total sleep duration. Now, this REM sleep has no subdivision, means there is no different stages, but non-REM sleep has different stages. Previously, we used to say that stage 1, stage 2, stage 3, stage 4. Nowadays, we say that the recent classification is stage N1, stage N2, stage N3. There are some key features of these three stages. N1, how will you identify if the alpha wave is converting to theta wave in the EEG? Then the person is in stage 1 of the sleep. Whenever you are getting sleep spindle and K complex in EEG, this is typical wave in the EEG, a large spike K complex or spindle shaped wave in the EEG, that indicated that the person is entering into the stage 2 or N2 of the sleep. And whenever the person is entering into the deep sleep stage, the delta wave will be seen in EEG. This is one of the must know important information for your MCQ. Please note down. Now, apart from this, look at the EEG picture and EMG picture and EOG picture. I told you already that what is the meaning of polysomnography. You are recording electrooculography, movement of the eyeball. You are recording the electromyography, the electrical activity of the muscles, and you are also recording electroencephalography, brain electrical activity. First, you look at the EMG activity. If the EMG is completely silent, silent means only you are getting a single line. See here. So, look at this 2 EEG, compare this 2 EEG. Here you are getting multiple disturbance like this, but on your right hand side there is no such kind of disturbance. This is known as the silent EEG. Silent EEG means muscles are almost like in paralyzed condition, and this is typical of REM sleep. So in REM sleep, if you look at the muscle activity, then it is completely silent. The person is in deep sleep stage. Okay, the person is in sleep stage. But if you look at the EEG, then beta-like activity is seen with a high frequency wave. Because of these two dissimilarity, if you look at the EEG wave, you are getting beta-like wave, means you will think that the person is awake, but the person is not awake. His muscles are completely paralyzed. That's why this REM sleep is known as paradoxical sleep. But look at the non-REM sleep stage. Your muscle activity is intact, although it is less than normal. So normally when you are active, when you are awake, your muscle activity is at a high degree. But whenever you are sleeping and you are entering in the non-REM stage, your muscle activity is decreasing. Okay, but you look at the muscle activity is not silent. Similarly, if you look at the EEG wave, you are going to get different types of wave. It may be delta wave, it may be theta wave, it may be K complex. Looking at this time, first you look at this time. Within this 1 second time, you count how many waves you are going to get. Like for example, in this picture, you must have noted that here, okay, look at within this 1 second period, suppose this 1 second period, I am getting 1, 2, 3 peaks only. 1, 2, 3 peaks only, means frequency of this wave is 3 Hz per seconds. Okay, so obviously this is a delta wave. This way you have to identify that the EEG is of which type, whether beta wave or alpha wave or theta wave or delta wave, right? So this way the sleep classification is done, that whether the person is in non-REM sleep stage or REM sleep stage. Got it? Now at the end, the sleep, you must have remembered the disorder of the sleep. This is more important in MCQ rather than the sleep classification, and I'm sure that this also has been taught by your psychiatrist teacher, right? So sleepwalking or somnambulism, it is seen in stage 3 and stage 4. Sleep talking, stage 1 and stage 2 mainly. Bruxism, seen in stage 2 and stage 1 mainly. Nocturnal enuresis or bedwetting, right? This is typically seen in all stage of non-REM sleep. Mainly it is the N3 stage. And night terror is seen during the transition from stage 3 to stage 4. Although stage 3 and stage 4 both has been included in N3 stage according to the recent classification. So if the question is night terror, your answer will be N3 stage. And in case of REM sleep, the disorders are narcolepsy and nightmare. So please note down, nightmare is for REM sleep disorder and night terror is for non-REM sleep disorder. Okay, so non-REM sleep disorder are very, very important for your MCQ. All these 5 disorder you have to remember. Got it? Okay, so this is about EEG and sleep. I told you apart from EEG and sleep, what you have to read? You have to read about hypothalamic nucleus. All the hypothalamic nucleus I have kept in this slide. There are different subdivision, different parts of hypothalamus. The detailed version I have discussed in my lecture, but at least you remember the important nucleus of hypothalamus. Like for example, anterior nucleus of hypothalamus is responsible for thermoregulation. Bracket mein hot means if you expose to hot environment, what is going to happen? Sweating will be there, vasodilatation will be there. All these things are due to activation of this anterior nucleus of hypothalamus. And the posterior nucleus of hypothalamus, they respond to cold. Okay, posterior nucleus of hypothalamus means shivering, okay, vasoconstriction, curling of the body. All of these are done by the posterior nucleus of hypothalamus, right? Here it is written that posterior nucleus of hypothalamus, this is known as the shivering center. Important for MCQ. Apart from this, we know suprachiasmatic nucleus is responsible for circadian rhythm. Lateral nucleus is responsible for controlling our thirst and hunger. Ventromedial nucleus is known as the satiety center. If this center is active, you will feel that you are not hungry at all, right? Medial forebrain bundle, this has been asked multiple times. It is known as the reward center. Got it? Okay. And periaqueductal gray matter, this is the center which is known as the punishment center. If you stimulate the punishment center again and again, the animal will be very, very angry. Very, very angry. This kind of reaction is known as the rage reaction. Getting my point? So if you stimulate the punishment center again and again, what you are going to feel? You are going to feel very angry. Why? Because the feeling will be like as if you are getting some punishment. Who wants to get punishment? We want to get reward, but you are giving more and more punishment. So I'll be angry. And that kind of reaction is known as a rage reaction. Got it? Right. And anterior nucleus of hypothalamus contain the osmoreceptor cell. Very, 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 very important. Osmoreceptor are located in the anterior nucleus of hypothalamus. These are the important nucleus of hypothalamus that you must have to remember. Got it? Now the last topic in higher functions as well as in neurophysiology is the memory. So you know the types of memory are important for MCQ. One is working memory, one is short-term memory, one is long-term memory. So working memory, it is lasting for only 18 to 20 seconds in your brain. You can hold the information. How many information? 7 plus minus 2 chunk of information. What is the meaning of that? Suppose I am giving you the names of 7 different cities. Okay, that Ahmedabad, okay, Delhi, Mumbai, okay, Indore. You have to remember the names of this city in a sequence. How many names you can remember in your brain for short period? 7 plus minus 2 means maximum 9. If I give 20 cities name, you are going to forget. So this is the kind of memory which is known as a working memory. Okay. And the prefrontal cortex is responsible for the working memory. Now the short-term memory, it's last in your brain for seconds to hour, and the main area which convert this short-term memory to long-term memory is the hippocampus. Which area of the hippocampus? CA1 area of the hippocampus is mainly responsible for short-term memory to long-term memory conversion. But the long-term memory are stored inside which part of the brain? It is stored in the neocortex. So this hippocampus is converting the short-term memory into long-term memory, and whenever the memory is converted into long-term memory, it will be stored in the neocortex of the brain, and the long-term memory you can recall for long duration, years, even years, after months, obviously. Okay, so that is long-term memory. So this is one type of classification according to the storage of the information in your brain. Now there is another type of memory classification which is known as the explicit memory and implicit memory. So first you take one example. Suppose you are learning how to drive a car for the first time. Okay, suppose you are learning how to drive a car for the first time. So how you learn? You learn by trial and error, and you do multiple mistakes. But whenever you are learning driving for the first time, it is very difficult. You have to remember which one is the brake, which one is the clutch, which one is the speed, and your brain is highly active that now I have to put the brake, now I have to put the gear. So whenever you are doing this thing, your brain is highly active. This is the memory which is known as explicit memory. Got it? Your brain is highly active. So require conscious processing at the level of hippocampus and medial temporal lobe. But whenever you have learned the driving completely, now you are a master driver. Okay. So what do? That time, do you think that you have to put brake, you have to put clutch, you have to put gear? No, you don't have to. Even you are talking with your friend, even you are listening music, still you can drive your car smoothly without any thinking. So your brain is not thinking about the driving process. Your brain is talking with someone, your brain is listening some music, but still you are doing this driving automatically. So when this kind of memory become a kind of automatic things, okay, that is known as implicit memory. Got it? So the same thing which happens during brushing of tooth. For the first time will you learn brushing the tooth, that was explicit memory. But when you have already learned how to brush, now this is automatic. Okay, you are brushing the tooth automatically. This is implicit memory, right? So please note down that explicit memory, conscious processing require. But in case of implicit memory, it does not require consciousness or awareness in the brain or awareness at the level of hippocampus. Now there are different sub-classification, different subtypes of this implicit and explicit memory. One of the sub-classification of this implicit memory is associative learning, which is very important in MCQ. Associative learning, okay, is a type of implicit memory where the person learn the association between two stimulus. And the typical experiment which has been done on this associative learning is Pavlov's experiment. Okay, so what is the experiment? All of you know that if you give food to an animal, okay, obviously the animal is going to salivate, right? We know this thing. But if you give bale to an animal, obviously he is not going to salivate. But if you give bale followed by food for 1 day, 2 days, 3 days, means you are giving bale followed by food is coming. Bale followed by food is coming. How many times? Multiple times. If you do this scenario again and again on multiple days, then the animal, the dog, is going to remember that whenever there is bale, I am going to get my food. So he is associating between these two stimulus, that bale followed by food. Now, after this association is done, this association is known as pairing. So this is known as pairing of two stimulus. Now whenever this pairing is done completely, now if you give only bale, the animal will start salivation in anticipation that the food is going to come. So now this is typically known as classical conditioning. But here there is one important catch. If the question is like this, that if you give food to an animal, the animal is salivating, which kind of response this is? Your answer will be, this is innate reflex. What do you mean by innate reflex? Means there is a particular hardware in the brain. This hardware will be active whenever you are getting some food. No training, no memorization is required. Do you think somebody taught you how to salivate whenever you are getting food? Do you think your parents has taught you that whenever you get food, you start salivating? No. So how do we salivate? Whenever you are getting food, there is a hardware system in the brain. This hardware system is giving a reflex which is known as the innate reflex. You don't require learning, you don't require memory for this. But whenever I am giving a pairing kind of stimulus, one stimulus which is a neutral stimulus, that is in the form of bell. So neutral stimulus is attached with the unconditioned stimulus, and this attachment should be more and more, multiple times. This attachment is known as pairing. So whenever you are doing the pairing on multiple times, then the animal is developing an association between these two stimulus, and then it is known as associative memory or classical conditioning. So classical conditioning is an example of associative memory. Whenever the question is using this word pairing multiple stimulus, pairing two stimulus, then and then only you are going to mark that it is a typical classical conditioning. Got it? So this pairing word must be there, or otherwise there should be complete description of the phenomena that you are presenting bell followed by food on multiple days, and after multiple days training, the dog is salivating in response to bell. What is this? Your answer is classical conditioning. Your answer is associative learning. Got it? But otherwise, if the question is given that food is given and the animal is salivating, this is typical of innate reflex. One topic, one is general physiology and one is GIT. So first we are starting with general physiology. So what are the important things that you have to revise before your exam? So first you look at one MCQ. So this MCQ has been asked in NEET 2021 examination, and I will say this is one of the most simplest MCQ asked so far. So in this question they are asking that the electrolyte measurement of an fluid component is sodium 10 milliequivalent per liter and potassium 140 milliequivalent per liter. Looking at this electrolyte composition, you have to identify, and I am 100% sure all of you know that it is nothing but intracellular fluid component which has a higher potassium concentration near around 140 milliequivalent per liter and low sodium concentration. Sodium concentration is high in the extracellular fluid, so that if the sodium concentration is very high, like 145 equal, that is indicating that is the extracellular fluid. So you just have to remember that this electrolyte composition of this ECF and ICF, so this is the ECF component and this is the ICF component. You can find out that the sodium and potassium, they are strikingly different between these two components. Sodium is very high in the ECF and potassium is very high in the ICF. Apart from that, you also have to note down here that the calcium concentration between ECF and ICF, look at this. So the calcium concentration, if you look carefully, you will be finding out that this is one of the electrolyte where ECF is to ICF concentration ratio is very high, tremendously high. Look at outside calcium concentration is 2.4 milliequivalent per liter and inside is 0.001 milliequivalent per liter. It is said that the ratio between ECF is to ICF calcium is in and around 12,000 to 20,000 is to 1, right? So this is one electrolyte where ECF is to ICF concentration or ratio is maximum 12,000 is to 1. Apart from that, also note down that the protein concentration is very little in the extracellular fluid, but in comparison to that, protein concentration is very high in the intracellular fluid. All of you know that the protein is a large molecule, so it is impermeable to the cell membrane, and whenever one impermeable molecule like protein is present in one of the compartment, it will exert one effect, and that effect is known as the Donan effect, right? So Donan effect, right? So this question has already been asked, that Donan effect is due to which of the following? So your answer will be large impermeable molecule like protein, right? So these are the things that you have to remember. Now moving on to the next question. So here question is baroreceptor reflex is an example of. So again you see that this is a NEET 2022 questions and one of the easiest question, right? So here we all know that it is a negative feedback reflex. Okay, so this question is based on the physiology which is known as the control system in biology. So control system, all of you know that there is feedback control system, right? and there is feed forward control system. So this feedback control system again are of two type. One is negative feedback control system and one is positive feedback control system. So we have to remember the examples of this positive feedback control system, that is important for our MCQ. And for this negative feedback control system, most of the biological system is an example of negative feedback control system. Like for here, the baroreceptor reflex. Whenever your blood pressure is rising to a high value, okay, it will activate the baroreceptor, and the activation of the baroreceptor will inhibit the sympathetic system, and that inhibition of the sympathetic system will leads to again decrease in blood pressure. So what is happening whenever your blood pressure is rising? Blood pressure is decreased by baroreceptor control system. It is a typical example of negative feedback control system. So now look at the positive feedback control system and this feed forward control system. They are more important for MCQ. So the positive feedback control system, all the examples has been written here. Okay. So first one is the process occurs during blood clotting. All of you know that the activation of one clotting factor leads to activation of the subsequent clotting factor. Like for example, remember whenever there is generation of a little bit of thrombin, this thrombin can activate the factor number 5, factor number 8 and many other factors. So this is a typical example of positive feedback control system, because of which the clot formation become very easier. Second, the LH surge. All of you know that the LH surge gives estrogen gives a positive feedback on LH, and because of which LH level become very high, which is responsible for ovulation. The third one, the uterine contraction during the process of childbirth, that is also an example of positive feedback reflexes. This is also known as Ferguson reflexes. Then lactation during the suckling of the baby, okay, that's also gives a positive feedback control system, which leads to more and more ejection of milk. Number 5, generation of the action potential. Here you have to look at very carefully. During the generation of the action potential, there is opening of the sodium channel, voltage gated sodium channel, as well as there is opening of the voltage gated potassium channel. We know that opening of the voltage gated sodium channel leads to depolarization. This is a typical example of the positive feedback control system. But opening of the potassium channel leads to repolarization of the action potential, and the opening of the one potassium channel leads to inhibition of the subsequent potassium channel. So this is an example of negative feedback control system. So please note down that whenever I am saying that during generation of the action potential, the positive feedback response is only during the depolarization. During the repolarization, or more specifically opening of the potassium channel, is an example of negative feedback rather than positive feedback. And the point number 6 is opening of ryanodine receptor for the release of calcium. You know that whenever there is entry of little amount of calcium in the cytoplasm, that calcium stimulate the ryanodine receptor. Further calcium will be released in the cytoplasm, and that calcium will again stimulate further opening of the ryanodine receptor channel. So this way, all of these are example of positive feedback control system. You have to remember this, right? Now, apart from positive feedback, the more important thing is that you have to understand what is gain of the control system and what is feed forward control system. So now look at gain of the control system. Just remember for quick revision that gain is equal to correction upon error. So this is the formula, correction upon error, right? So what is the meaning of this? Suppose one question has been given like this, that when a person is changing his posture from supine to standing posture, what will happen to the blood pressure of the subject? You all know that whenever the person is changing his posture from supine to standing posture, the blood pressure will drop down. Now suppose the question is saying that during this changing in posture, there is dropping of 10 millimeter of mercury blood pressure. So blood pressure decrease how much? 10 millimeter of mercury. Now due to the inhibition of the baroreceptor system, now the baroreceptor will try to correct this blood pressure. And how much correction? So correction is around 8 millimeter of mercury. So there is drop of 10 millimeter of mercury blood pressure, and the baroreceptor system is correcting it. And how much correction has been done? 8 millimeter of mercury. So I can understand that this correction is not foolproof, because still there is some error which is persisting in the system. That is nothing but 2 millimeter of mercury. So 10 millimeter drop, 8 millimeter correction,
error is still 2 millimeter of mercury. So with the help of this formula, I can understand that correction is 8 millimeter of mercury and error still remaining is 2 millimeter of mercury. So the gain of this control system is 4. So in this example, I can understand that the gain is correction upon error. If I use this formula, then here the gain of the baroreceptor control system is 4. Getting my point? And the correction is happening in which direction? So the disturbance is occurring in the downward direction and the correction is happening in the opposite direction. So that's why you can say that this gain is negative gain or positive gain. Obviously this is a negative gain. Always remember that normally the gain of the baroreceptor control system is in and around 2, right? Thermoreceptor control system has more gain in around 33.5, right? But you have to remember that in a control system, if the residual error is 0, suppose one control system is foolproof control system, that whenever there is disturbance, the control system is capable of correcting that disturbance to 100%, means no residual error is there, error is 0. So in these cases, if you calculate the gain of the control system, so correction is full correction and the error is absolute 0. So what is the gain? The gain is infinity. So please remember that there was a MCQ in NEET entrance examination that infinity gain is seen in which organ system in our body. Your answer will be the infinity gain example is kidney. So kidney can correct your blood pressure and blood volume with 0 residual error, provided you give enough time. That means kidney is a part of the long-term regulation of our blood pressure control system. So if you give enough time for maybe for months or weeks, so what it will do, the kidney can control your blood pressure. It can correct your blood pressure to 100% with 0 residual error. So that's why kidney for the correction of the blood pressure and the correction of the blood volume. These are the two examples where residual error is 0 and gain of the control system is infinity. So these are the important thing that you have to remember for your MCQ purpose. Now you look at the examples of feed forward control system. So what is feed forward control system? All of you know that feed forward control system is nothing but it is an anticipatory control system. So whenever your control system is expecting some kind of disturbance, he is taking some measure so that the disturbance will not affect the system. Means you are taking some precautionary measure so that whenever the error is going to happen, before that you have taken some measure. That is a kind of system which is known as feed forward control system. Look at the example, thermoregulation system. You know that body always try to maintain the core body temperature. Whenever your skin temperature is drop, okay, thermoregulatory system try to raise the body temperature ahead of the fall of core body temperature, so that it is an example of feed forward control system. Thermoregulation has two parts. One is feedback control system. So feedback is also there as well as feed forward is also there. But mainly it is the feed forward control system. It try to raise the body temperature ahead of fall. Which body temperature is more important? The core body temperature maintenance is more important. Getting my point? Yes. Second thing, increase in heart rate and respiratory rate even before the start of exercise. This has been asked in MCQ. That suppose I ask you that you have to do the exercise on this treadmill for the next 1 hour. So whenever you are thinking that you have to start the exercise, this anticipation that you have to start the exercise will start rising your heart rate and respiratory rate. This is known as the psychic stimulation. Okay, psychic stimulation. Your brain has understood that you have to start the exercise and he is rising the heart rate and respiratory rate in anticipation. So feed forward control system. Cephalic phase of gastric secretion. So all of you know that whenever you are looking at some food or suppose you are chewing the food, so food has not yet entered into the stomach, but stomach is secreting acids in anticipation that food is going to reach. So this is again a typical example of feed forward control system. Receptive relaxation of the stomach. You know that whenever food enter in the upper part of the esophagus, the upper part of the stomach dilate ahead of food. So food is not entering into the stomach. It is only in the upper part of the esophagus, but stomach is dilating itself in anticipation that food is going to come. He has to accommodate, right? And the cerebellum. So the granular cell
stimulate the basket cell and basket cell inhibit the Purkinje cell. So basket cell mediating inhibition of Purkinje cell, this is in control of feed forward control system. In my detailed lecture, I have discussed this thing detail, but for the time being, you just remember these are the examples of feed forward control system in our body, right? So this is all about the control system and the feedback, the gain of the system. Now coming to the body water. So what you have to read in case of body water. So look at first two MCQs. One question, the question looks similar. First question is ECF is dash percentage of total body water, and in second question ECF is dash percentage of total body weight. So don't think that the answer of these two questions will be same. So to answer this question, first you look at, I hope all of you know that this distribution of the body water, how it is distributed. So the total body water, how you are going to get the total body water? You take the 60% of your body weight. So if a person has a body weight of 70 kg, so you take 60% of 70 kg, that is the 42 liter. So the 42 liter is the amount of the total body water in that person who has a body weight of 70 kg. Now this 42 liter water will be distributed in 2/3. That means 28 liter will be in the ICF and 14 liter will be in the ECF. So this is the way we calculate the body water approximately. So same thing has been written here. So the 2/3 is the ICF and 1/3 in the ECF. But look at another things I have also written here, that this is 40% of the body weight and this is 20% of the body weight. So if I ask you that ECF is how much percentage of your body weight, your answer is 20%. But if I ask you ECF is how much percentage of your body water, then your answer is 1/3 of the total body water. 1/3 means how much percentage? 1/3 means 33%. So this 1/3 means this is 1/3 of total body water. This 2/3 means this is 2/3 of total body water. But whenever I am writing this percentage means percentage of the total body weight. So if the question is ECF is how much percentage of body water, your answer is 1/3 percentage means 33%. But how much percentage of body weight? It is 20%. So in the second question, it is 20% is the answer, and here it is the 33% is the answer. Getting my point? So please be careful. Similarly, if you look at the ECF has been divided into two compartments, interstitial fluid and plasma. So if I ask you, plasma is how much percentage of ECF? Then it is 1/4 of ECF. 1/4 means it is 25% of ECF. But if I ask you directly that plasma is how much percentage of your total body weight, then it is 5% of the total body weight. Getting my point? Same way, interstitial fluid is 15% of the total body weight, but it is the 3/4 or 75% of ECF. So this way, this is very simple, but sometimes MCQ can be a little bit tricky from this topic. So body water distribution, you have to remember like this, right? Now the next is how this body water is calculated by some mathematical equation. Look at the question here. So this question has been asked in AIIMS entrance examination. Here the question is 100 milligram of sucrose is injected in a 70 kg man. The plasma level of sucrose after mixing. So plasma concentration is given, as well as it is also said that 5 milligram has been metabolized during this period. So how to calculate this? You know that this calculation is based on a principle. That principle is known as volume of distribution principle. Volume of distribution principle. This is very common topic and question has been asked multiple times. So what is volume of distribution principle? Look at. So this is the representative diagram. So this is nothing but the capillary, and these are nothing but the cells of our body. Okay, so these are nothing but the cells. So in volume of distribution principle, first of all, you have to inject one substances into your venous blood. Suppose I have injected Q milligram of substances. Okay, then what will happen? Depending on the property of these substances may penetrate through this capillary blood or may not. But suppose I am assuming that the substances is easily
filtrable, easily penetrable through the capillary. So it will penetrate through the capillary wall and it will reach in the interstitial fluid. After reaching into the interstitial fluid, it will try to cross the plasma membrane also. But suppose the substances that I have injected here, he is not able to cross the plasma membrane. So what will happen? So the substances will be distributed only in the interstitial fluid, and obviously it will be also distributed in the plasma, but it will not be able to distribute within the intracellular fluid or ICF. That means if I ask you, these substances, the Q milligram of substances that I have injected here, where it is distributed inside the blood vessels, as well as it is distributed inside the interstitial fluid. Means it has been distributed in the plasma as well as interstitial fluid. Combination of plasma and interstitial fluid is what? ECF. That means this Q milligram of substances has been distributed in the extracellular fluid. Now after proper distribution, you have to take a little blood sample from this person and you have to measure what is the concentration of these substances into this blood. Suppose this concentration is C, right? So now what you have to do, if you divide this Q upon C, then you are going to get a volume, and this volume is nothing but the volume of the fluid in which this substances has been distributed. Getting my point? So what you are getting? You are getting a volume. Volume of what? Volume of the fluid in which the substances has been distributed. Now, whenever you are injecting any substances into your blood, there is always a possibility that some portion of the substances may be metabolized or may be excreted by the blood. So that's why you have to take that into consideration. So the formula is actually, it is Q minus E. So what is this E? E stands for, it is the part which has been excreted or metabolized. So Q is the total amount of substances that you are injecting, E is the excreted or metabolized part, and C is the plasma concentration of the substances. This formula is the formula for calculating the volume of distribution. Looking at this formula, we can easily understand that different substances has to be used for measuring different fluid compartment. Answer is obviously yes. So if you want to measure only the blood volume, then you have to choose one substances which is impermeable to capillary. Otherwise, if it is permeable to capillary, then it will be distributed in the interstitial fluid also. So that way, different substances has to be used for measuring different compartment fluid volume. You have to remember one table where all these substances have been summarized. Look at, this is one of the important table that you have to remember for your MCQ. If you want to measure the total body water, the deuterium oxide, D2O, deuterium oxide and antipyrine is used. If you want to measure only the ECF volume, the substances which has to be used is inulin, sucrose, sodium 22 isotope, iodine 125 iodothalate, and mannitol. So these are the substances which is used for measuring ECF compartment. So if I want to measure ICF volume, you cannot measure ICF volume directly because there is no such substances which will be distributed only in the ICF, not in the other compartment. So what you have to do here, you have to measure the total body water and you have to measure the ECF separately and subtract them. You are going to get the volume of ICF. Similarly, if I ask you how to measure the plasma volume, your answer, the substances should be confined within the plasma only. It is impermeable to capillary. So those substances are Evan blue and 125 iodine, 125 tagged with albumin, right? So albumin tagged with iodine, sorry, right? Now, if you want to measure the interstitial fluid, again you have to measure the ECF separately and you have to measure the plasma volume separately and subtract them. You are going to get the interstitial fluid volume. Similarly, if you want to measure only the RBC, then this chromium isotope, iron isotope, okay, tagged RBC can be used for that purpose, right? Now we are looking back at this MCQ once again. So now we have to apply the formula. What formula? The volume of distribution formula. The V is equal to Q minus E upon C. So here Q is 100 milligram minus metabolized is 5 milligram and the plasma concentration is 0.01 milligram. That means this is 95 upon 0.01 ml. That is nothing but 9500 ml. 9500 ml is equal to 9.5 liter. What substances has been used here? Sucrose. Sucrose is used for measuring which fluid component? Sucrose is a disaccharide which is freely permeable to the capillary, but it is impermeable to the plasma membrane. So it will be distributed in the plasma as well as in the interstitial fluid. So basically this is nothing but measurement of the ECA volume in this person. Getting my point? So this is all about the fluid compartment and how to measure this fluid compartment. See here, sucrose has been written here, which is used for measuring ECA volume. But the best substances for ECA measurement is inulin, right? So these are the all things that you have to remember. Now look at the transport process across the cell membrane. Look at here. This is interesting question and tricky question. So active transport across the cell membrane is mediated by, if you look at suddenly at this question, you will think that this is a very easy question. Sodium, potassium, ATPase pump. True, it's an active transporter. But what about carrier protein? Can carrier protein be also used for active transport? Answer is yes. This is also a true statement. Now I have to choose in between these two, that both of them can be used for active transport. Now first of all, you look at active transport are mainly of two types. We know primary active transport and secondary active transport. So first of all, you look at this whole transport system process. So the transport process is divided into active transport and passive transport, and obviously endocytosis and exocytosis are also there. Now if you look at the active transport process, again it is dividing into primary active transport and secondary active transport. Okay, and this secondary active transport is again divided into two parts here, that is symport and antiport. Now this symport, antiport, they are the part of the secondary active transport. They require the help of carrier protein. I hope you know what is the meaning of carrier protein. Carrier protein means is a protein which will binds with the substances, then the carrier protein will change its shape and then it will throw the substances into the other compartment. Right. Like for example, one carrier protein is transporting glucose. First it will attach with glucose. Then the carrier protein will change its shape and then the glucose will be extruded into the other part of the cell membrane. So that way the carrier protein functions. So if I ask you the symporter and antiporter, what are they? They are carrier protein. If I ask you sodium, potassium, ATPase pump, what is this? This is a protein. What kind of protein? Can it change its shape? Answer is yes. It also changes its shape for the transport of sodium and potassium. So basically, sodium, potassium, ATPase pump, it is also a carrier protein. Carrier protein can also be used for this facilitated diffusion. That means carrier protein can be used for active transport also, can be used for passive transport also. So look at here, this is taken from Guyton. So carrier protein, where they can be used for facilitated diffusion, they can be used for active transport process also. Getting my point? Active transport means which type of active transport? It can be used for primary active transport also, as well as the secondary active transport process also. So if I ask you that this question is asking active transport across the cell membrane, will you mark the sodium, potassium, ATPase pump or will you mark carrier protein? So sodium, potassium, ATPase pump only indicating this is the primary active transport, but carrier protein can be responsible for primary active transport also. It can be responsible for secondary active transport process also. So the better answer will be carrier protein. So this is an old MCQ of AIMS entrance examination, and all of the guidebook has been given correct answer that carrier protein is the best suitable answer in this question. Although sodium, potassium, ATPase pump is also an example of active transport process. We all know that. Right? Now, this is very, very important thing you have to remember. Now, also look at this passive transport process. Passive transport can be of osmosis, it can be of diffusion. And we know the diffusion can be of three types: simple diffusion without any carrier protein, facilitated diffusion with carrier protein, and non-ionic diffusion. Typical example of non-ionic diffusion is the what? Yes, secretion of ammonia at the level of kidney, at the level of GIT. They are the example of this non-ionic diffusion. Just remember this example. Now, simple diffusion and facilitated diffusion, if there is presence of a channel protein, then it's a simple diffusion. Look at here the diagram once again. So this is a channel protein, as you can find out here, and the channel protein has been put into which category? Simple diffusion. So the sodium is passing through the sodium channel. What is that? Simple diffusion only. Okay, because channel protein does not bind with the sodium. Okay, it does not bind with sodium like that of the carrier proteins. Okay, so that's a channel protein. All channel proteins are example of simple diffusion only. Now, whenever we are talking about simple diffusion, you have to remember one important thing, that the calculation of the rate of simple diffusion, is done by a formula which is known as Fick's law of simple diffusion. This has been asked in MCQ. So the rate of simple diffusion can be calculated by Fick's law. What is Fick's law? According to Fick's law, simple diffusion rate, so this J is nothing but the rate of simple diffusion, is equal to D multiplied by A multiplied by delta C upon your X. So this D is the diffusion constant, right? So this D is the diffusion constant. A is the surface area of diffusion, that what is the total surface area through which diffusion is occurring. And this delta C is very, very important. Delta C is the concentration difference between two sides of the membrane, and X is the thickness of the membrane through which diffusion is occurring, right? So this formula you have to remember. This is known as Fick's law of simple diffusion. Now, based on this Fick's law, look at this MCQ. So in this MCQ, they are saying that the solution A and B, suppose this is solution A, suppose this is solution B, they are separated by a semi-permeable membrane, okay, that is permeable to urea. So in this question, the membrane is permeable to urea. Now the solution A contain a urea of 10 millimole. 10 millimole urea is there, and solution B contain urea of 5 millimole, right? 5 millimole or 5 mole, whatever, 5 millimole or 5 mole, whatever you say. So this is mole. Now they are saying, if the concentration of the urea in solution A is double, so now you are changing this concentration to 20 millimole without changing the concentration of B, because they are not commenting on anything on B. So what will happen to the rate of diffusion? So urea is passing through the simple membrane, so it's a simple diffusion process. We just learned that simple diffusion rate J is calculated based on dA delta C upon X. So if every parameter is constant, so it is directly proportionate to delta C. So this J, or rate of diffusion, is directly proportionate to concentration difference between two sides of the membrane. So in the first cases, when it was 10 and 5, the delta C, or the concentration difference between two compartments, is 10 minus 5, that is 5. But whenever you have changed the concentration to 20, keeping the B concentration same, then here the delta C is 20 minus 5, that is 15. So because of the change in concentration, the diffusion has been increased from 5 to 15. That means 3 times increase in diffusion. So the question answer will be triple, right? It is not double. Although looking at the question, you are thinking that this is a very simple question, but not that much simple. Okay. So this is 3 times increment in diffusion, right? So next we are looking at another transporter dependent question, glucose transport in adipose tissue. So this is a typical memory based question. We all know that in adipose tissue and in muscle tissue, cardiac muscle as well as skeletal muscle, the glucose transporter is nothing but GLUT4, right? GLUT4. And we also know that GLUT4 is the insulin dependent GLUT, right? So this is important to remember. Now another question, the mechanism involved in the absorption of glucose from small intestine. Very, very important question. Very, very important question. So from the small intestine, whenever the question is like this, the absorption of glucose, they mean to say that absorption of glucose from luminal membrane of intestinal epithelium cell. But suppose the question has been asked that absorption of glucose from basolateral membrane of the intestinal epithelium cell, then the answer will be different. So in this question, the answer will be secondary active transport. Why secondary active transport? The absorption from luminal surface is done by SGLT. 1, and absorption from basolateral surface is done by GLUT, GLUT2. GLUT2 is an example of facilitated diffusion. Facilitated diffusion. So what I have to remember? I have to remember an intestinal epithelium cell like this. Suppose this is the intestinal epithelium cell. Very, very important question I am telling you. From the luminal membrane, if they are asking question about glucose or galactose, both uses the same transporter, glucose and galactose. So whether it is glucose or it is galactose, it will take help of sodium, and glucose or galactose will be transported, and this is known as SGLT1. SGLT1, right? But the main transporter for glucose transport at the level of kidney epithelium cell is SGLT2. I hope you remember that, right? So this is about glucose and galactose. But if the question is, what about fructose? That is also a monosaccharide, fructose. So transporter of fructose is nothing but GLUT, GLUT5. So if I ask you a question on glucose and galactose, it is SGLT. All the SGLT are example of symporter. So it is nothing but secondary active transporter. But all the transporter which are started with the name GLUT, glucose transporter, they are example of facilitated diffusion. Facilitated diffusion. So please be careful. Now look at the basolateral aspect. On the basolateral membrane, whether it is glucose, whether it is galactose, or whether it is fructose. So whether it is fructose, glucose, or galactose, all are transported by GLUT2, and GLUT2 an example of what? GLUT2 an example of facilitated diffusion. Getting my point? So please be careful in this question. Very important. So now we can understand that there are GLUTs and there are SGLT, which could be a very, very potential MCQ. Answer is yes, obviously yes, right? So now look at in this table, all the SGLT and all the GLUTs has been put into, right? So first you look at SGLT. Secondary active transport. SGLT1 is present in intestine main, as well as it is also present in kidney. But in kidney, which part? The proximal straight tubule. The second part of the last part of the proximal tubule is proximal straight tubule. But the main glucose transporter in kidney is SGLT2. It is said that SGLT2 is responsible for 90% of glucose transporter in kidney. So this is SGLT2, and 10% of glucose transport is done by SGLT1 in kidney. But in case of intestine, only on one SGLT is present, and that is SGLT1, right? Sometimes this SGLT3 can also be given in MCQ. It is particularly present in skeletal muscle, also little amount in small intestine, right? Now looking at the GLUT. So there are different GLUTs. You don't have to remember all of them. You just remember GLUT1, GLUT2 and GLUT4 at least. Right. So GLUT1, highest level is present in the RBC. So anytime it can be asked in MCQ. GLUT2, we all know that it is present in pancreatic beta cell. It is a glucose sensor for the pancreatic beta cell. Whenever your blood glucose is high, through this glucose transporter, the glucose will enter in the pancreatic beta cell. But this GLUT4 is an insulin dependent GLUT. It is present in heart, skeletal muscle and adipose tissue. Very, 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 very important. But not only that, insulin dependent GLUT are also there apart from this GLUT4. I'll tell you which one that. But before that, see here the GLUT5. What is GLUT5? Although the name is GLUT5, it is a fructose transporter. It is transporter of fructose. This you also have to remember. Other GLUT you may go through, but they're not very important to revise just before exam, right? So before exam, you at least remember whatever is written on this slide. Insulin responsive GLUT, GLUT4, we all know. Apart from that, GLUT12 is also there. Insulin responsive GLUT in blastocyst, GLUT8, right? So during the fetal development, during the blastocyst development. Fructose transporter GLUT, GLUT5 we all know. Apart from that, GLUT11 is also a fructose transporter. In central nervous system, there are three different types of GLUT. GLUT1 is present in the blood-brain barrier, endothelium cell of the brain capillary. GLUT3 is present in the neuronal membrane, and GLUT3 is present on the astrocyte membrane. So you can understand that astrocyte is taking glucose through this GLUT5, neuron is taking glucose through this GLUT3, and how the glucose is entering into the brain fluid, that is by GLUT1, that is the blood-brain barrier GLUT. Okay, and the major GLUT in placenta and fetus is GLUT1, right? So these are the important things that you must have remember, okay, for your future MCQ. Okay, now moving ahead. So here a research scholar, while studying the cell cytoskeleton, so you can understand that the question is on cell cytoskeleton. Now look at the description of the cell cytoskeleton. Okay, it's a fibrous protein, right? And it is a stable stand. These are the two cues in this question. So it's a fibrous filament-like protein and it's a stable protein, stable stand of protein. You know that there are three main different types of cell cytoskeleton. We say that cell cytoskeleton are of two types. One is dynamic cell cytoskeleton and one is static cell cytoskeleton, right? Dynamic means the length of the cell cytoskeleton can alter, right? But static means this is the stable cell cytoskeleton. The length of this cytoskeleton is not going to change. The examples of stable cell cytoskeleton is intermediate filament. An example of this dynamic cell cytoskeleton is microtubule and microfilament. So just if you understand this one, your answer will be done. So that is intermediate filament. This is the question they are asking here, right? So intermediate filament, you know that this is a stable cytoskeleton. Stable cytoskeleton means it is not going to alter its length according to the cell growing. That's why this intermediate filament, they are used as a cell marker, cellular marker. You know what is the meaning of cell marker from your pathology knowledge. If you want to identify a particular type of cell, like for example, epithelial cell, the marker is cytokeratin. So what is this cytokeratin? The example of this intermediate filament is cytokeratin. So cytokeratin is a marker of epithelium cell. Cytokeratin is an intermediate filament. Like desmin, like vimentin, all of them are cell marker. Who are they? These are nothing but intermediate filament, fixed, stable structure within cell. Got it? So just quickly look at this three different types of cell cytoskeleton. Okay, microfilament, intermediate filament, microtubule. I told you already that this is dynamic one. Okay, this is also dynamic one, and this is the fixed cell cytoskeleton, stable cell cytoskeleton. Look at the diameter. Looking at the picture, you can easily understand that the microtubule is the strongest one with a huge diameter of 25 nanometer. Okay, and this microfilament is the thinnest one, 7 nanometer is the diameter. Now, sometimes they can also ask you what is the sub-unit of this cell cytoskeleton. Okay, so the tubulin is the subunit of microtubules and actin is the subunit of microfilament. Intermediate filament composed of various different types of protein like cytoskeleton, vimentin, desmin. Okay, so that's why it is written several protein in case of intermediate filament. So this is the most briefest thing that you have to remember in your general physiology. Now, after finishing quick general physiology, we are going to finish this GIT physiology, a quick revision. Okay, so you know, in GIT physiology, the questions will be straightforward. They are going to ask you informative question mostly. Okay, so with that respect, we are going to quickly revise this GI physiology. So first topic in GI system that you have to read, must read before your exam is the basic electrical rhythm, means motility of the GIT you must have to read. So first an important thing is the basic electrical rhythm or the basal electrical rhythm. Look at the MCQ. List frequency of BER, basic electrical rhythm, is seen in which part of the GIT? So it's a memory based question. You have to remember what is the rate of basic electrical rhythm in different part of GIT. In this question, the answer will be stomach. Okay, and the maximum rate is at the level of duodenum, right? So you try to remember the rate of BER in different part. Here it is given. In case of stomach, this is 4 per minute. In case of cecum, 2 per minute. But cecum is not there in this option. In this question, the option is not there. So that's why we are choosing stomach. Okay. But look at the maximum rate is duodenum followed by jejunum. right? And the minimum rate is cecum. If that is not in the option, then stomach. And sigmoid colon, they have also asked directly, what is the rate of BER at sigmoid colon? Your answer is 6 per minute. Now this BER, basic electrical rhythm, what is this? So please remember, BER is nothing but resting membrane potential of smooth muscle cells of GIT. Smooth muscle cells, BER is nothing but resting membrane potential of smooth muscle cell of GIT. What is that? The resting membrane potential of smooth muscle cell of GIT moves from minus 65 millivolt to minus 40 millivolt. Means it's not a fixed voltage. The membrane voltage will drop down to minus 65 millivolt. Again, the membrane voltage will move to minus 40 millivolt. Again, it will drop down to minus 65 or minus 60 millivolt. Again, it will move to minus 40 millivolt. So this way, a rhythmic fluctuation of electrical voltage will continue in the smooth muscle of the GIT, and this rhythmic fluctuation of electrical activity is known as basic or basal electrical rhythm of GI smooth muscle. Got it? So this is nothing but BER is nothing but a resting membrane potential only, rhythmic fluctuation of the membrane voltage. Now question is, who is generating this kind of rhythmic fluctuation of membrane voltage? Why the membrane voltage is not fixed? Who is causing this fluctuation? You know that there is a pacemaker cell in the GIT which has also been asked in MCQ, and all of you know the name of this pacemaker. It is nothing but interstitial cells of Cajals, CAJAL, interstitial cells of Cajals. It is the pacemaker cell of GIT, and this Cajal cell is responsible for generating the basic electrical rhythm, right? Okay, first thing. Now you look at another MCQ related to this BER only. Okay, so conversion of BER to an increase in intestinal muscle tension. So muscle tension means the muscle is contracting and the muscle is producing some force. So first question that you have to think here, can BER produces muscle contraction? What is BER? BER is RMP. Can RMP causes muscle contraction? Answer is no, muscle contraction is possible by BER itself. For contraction of the muscle, you require action potential. So whenever the BER is generating action potential onto the top of it, then and then only the muscle contraction is going to happen. So what I'm saying like this, suppose the BER is going like this, okay, at a particular rhythm the BER is going, okay. So whenever this BER is moving above a certain voltage, that certain voltage is known as the threshold voltage. So whenever the BER is moving above a threshold voltage, then and then only action potential is going to fire. We all know the basic concept is that the RMP should go above the threshold voltage. So whenever the BER is moving above this threshold voltage, more positive than that of the threshold voltage also, what will happen? There will be development of few action potential, and this group of action potential which is developing on the top of the BER is known as the spike potential. So this spike potential is nothing but a kind of action potential only, group of action potential, and whenever there is generation of this spike potential, the smooth muscle is going to contract. So there will be contraction of muscle, and whenever there is contraction of the smooth muscle, what is going to happen? The tension in the GIT smooth muscle will be increased. So the question they are asking here, that what is the reason that the muscle is producing tension? What is the reason that this BER is going above this threshold voltage? Very valid question, that why the BER is suddenly going above the threshold voltage? Yet there must be some stimulus in the form of neurotransmitter, and the most important neurotransmitter is acetylcholine. So look at here in this question, the answer will be release of acetylcholine. Acetylcholine releases from parasympathetic system. All of you know that in presence of parasympathetic stimulation, there will be contraction of the GI smooth muscle. Your motility will be increased, right there. Okay. So how the acetylcholine is causing increased contraction of the smooth muscle? This is the reason. In presence of acetylcholine, the BER will go above the threshold voltage, and whenever the BER is going above the threshold voltage, spike potential will be generated that will cause muscle contraction. Muscle contraction can be of peristalsis also, can be of segmentation also, can be of any other type of GI movement, right? But the basic thing is that acetylcholine is responsible for converting this BER into action potential. Got it? So please look at here. The activation of the interstitial cells of calves is only responsible for BER generation. Adrenergic discharge. In presence of adrenergic discharge, the BER will go below the threshold voltage. Okay, that's why we know that whenever you give sympathetic stimulation, adrenergic stimulation, GI smooth muscle will relax because BER will go down. Okay, it will go below the threshold voltage. But acetylcholine, the BER will go above the threshold voltage. Okay, so that's why the answer is here. Release of VIP also causes relaxation of the smooth muscle of the GIT. So that is not also my answer. Got it? So this is very, very important thing. Please note down. In GIT, one of the most important things is BER, right? So next question, AIIMS 2015 question. So a small segment of mammalian small intestine was mounted over Dell's tissue bath. Don't have to worry about what is Dell's tissue bath. It's a apparatus which is used for study the movement of the GIT. So you take a small part of the GIT, you put that tissue onto this bath, you maintain the temperature of the fluid, you maintain the electrolyte of the fluid, and you study what is happening to the contraction or relaxation of that smooth muscle. That's all. So even if you don't know what is Dell's tissue bath, you don't have to worry. Look at the question. Movement was recorded. A substance was added at point X. Which of the following correspond to X? So look at here. There is a diagram which is given here. So contraction, relaxation, contraction, relaxation, contraction, relaxation of the smooth muscle of GIT. So this is basically not your BER. This is basically mechanical contraction and relaxation. So as you can understand that this y-axis is the strength of contraction. So strength of contraction is very high. But just after giving these substances X, you are finding out that the strength of contraction is decreasing further, and there is no contraction at all. So that way I can understand that this substance X is causing relaxation of the GI smooth muscle. So what will be the substances? Obviously this adrenaline. We have just understood that adrenaline means the BER will go below the threshold voltage. So the action potential will disappear, and if the action potential is not there, contraction of the GI smooth muscle is not going to happen. That's why there will be relaxation of the smooth muscle. So see, same concept, or the question has been given in a different way, but answer remains the same. Got it? Okay, very good. Now look at all other substances, acetylcholine, KCl, barium chloride, all of them will increase the strength of contraction like this. All of them can increase the strength of contraction like this. Okay, so relaxation is only done by adrenaline among these given choices. Fine. Okay, next question. So the next is, which of the following substances causes anterograde relaxation during peristalsis? Gut peristalsis. So here, the question is not about the BER. Here the question is about another movement. Okay, that is the peristalsis. You know that in fed state, so when the food is there in the GIT, there are two movements mainly. One is segmentation movement, and another one is the peristaltic movement, peristalsis movement. But in between these two, if I ask you which one is the dominant motility during the fed state, your answer will be most common motility is segmentation. Dominant motility is segmentation. Okay. Peristalsis is not the dominant one, although it looks like that peristalsis is the only motility. No, in fed state, major motility is segmentation. But whenever the question is about the fasting motility, so fasting motility means when there is no food in the GIT for last maybe 90 minutes, there will be another motility which is known as the migratory motor complex. I'm coming to this, right? So here the question is about peristalsis. They are asking which of the following substances causes anterograde relaxation during peristalsis. Very definite question, and this question has been asked multiple times. So what we have to remember? We have to remember that in peristalsis, whenever food bolus reaches at a particular part of the GIT, there will be stretching of that part. The stretching will lead to secretion of serotonin secretion of serotonin from the intestinal epithelium cell. This serotonin is going to act on the enteric nervous system. So whenever this enteric nervous system is activated, I hope all of you know what is enteric nervous system, the myenteric plexus and mesenteric plexus, mainly the myenteric plexus. So this enteric nervous system will be activated, and this activation will occur in such a way that the neurons which are projecting in this proximal part, they are going to release substances acetylcholine and substance P, and the neuron we are projecting in the distal part or anterograde part, they are going to release the nitric oxide, BIP and adenosine triphosphate. In presence of substance P and acetylcholine, there will be contraction of the proximal segment of the GIT. In presence of NO, VIP and ATP, there will be relaxation of the distal part of the GIT, and because of this kind of scenario, the food will move in the forward direction, propulsive movement. That's why we say that peristalsis is the propulsive movement. So please note down, never forget this information, that proximal contraction is done by this and distal relaxation is done by nitric oxide, VIP and adenosine triphosphate. Okay? Right. Okay. Now next, another MCQ on this migratory motor complex. I told you that migratory motor complex is a fasting motility. The initiation as well as regulation of migratory motor complex is done by a hormone which is nothing but motilin. Please remember. So motilin is secreted from MO cell of duodenum jejunum, that is the small intestine, duodenum jejunum. It can be also released from stomach, but I have to remember the main is the duodenum jejunum and the second release site is the stomach. So MO cell releases motilin. Motilin causes initiation as well as regulation of migratory motor complex. I have to remember certain information about migratory motor complex also. So I told you it's a fasting motility. Why you require fasting motility? So there is no food in the GIT, but still the GIT is having some motility. Why? This is to clear the content of the GIT which is still remaining in different parts. Getting my point? So after the digestion and absorption of food, certain amount of food particles, certain amount of gastric juices, certain amount of intestinal juices may remain in the GIT. You have to squeeze out all that content. That means it is clearing the GIT. It is preparing the GIT for the next meal. That's why it is said that migratory motor complex is a housekeeping motility. It is maintaining some housekeeping function in the GIT, right? Okay. So the migratory motor complex starts from stomach and it ends at the level of ileum, means MMC is not seen at the level of large gut. It starts from the middle part of the stomach and ends at the level of terminal ileum. I already told you that motilin is responsible for initiation and controlling of this motility, right? Now the speed of the MMC is 5 centimeter per minute, and MMC or migratory motor complex start only after 90 to 100 minutes after last food. Means you should do fasting at least 90 minutes. Not before that your MMC is going to start. MMC will start only after a period of 90 to 120 minutes from the last food. Got it? And the MMC will reappear, means if there is starting of one MMC movement, second MMC will only start after an interval of 90 minutes. That is also important for your MCQ. So these are the information that you have to keep in your brain. Got it? Okay. Next MCQ. So next MCQ, let emptying of gastric content in the presence of hypertonic and acidic content in the duodenum. Look at the question, very specific. So this question is regarding the movement of the stomach. Okay. Due to presence of certain thing at the level of duodenum. So if there is certain kind of content, like for example hypertonic content or acidic content present at the level of duodenum, it hampers the movement of stomach. It decreases the movement of the stomach by a reflex pathway which is known as enterogastric reflex. Got it? So whenever huge osmolality containing food or hypertonic food or acidic food is present in the duodenum, from the duodenum a neural reflex will reach to the level of stomach, which will causes contraction of the pyloric sphincter, and it will decrease the motility of the stomach. That is known as the enterogastric reflex. So basically we have to remember certain point about motility of the stomach, gastric motility, certain point we have to remember. So what are the point? The main pathway for regulating the motility of the stomach is the neural pathway, neural reflexes, vagovagal reflexes. It is the main reflex which control the motility of stomach or gastric emptying, right? Second, most rapidly emptying substances from stomach is isotonic saline. So suppose you have taken different types of food, or suppose you have taken different types of liquid. Which liquid will pass from stomach to duodenum in a rapidest fashion? The answer is isotonic saline. Regarding food, the first food which will move from stomach to duodenum is the carbohydrate, followed by protein, followed by fat. That's why, if you take huge amount of fatty food, it will remain in your stomach for long duration and you will feel heavy in your abdomen. Okay, all of us has felt this kind of scenario after taking heavy, rich meal, rich in fatty food. Got it? Okay. Now, second thing, distension of duodenum, acidic content in the duodenum and high or low osmolality food in the duodenum hampers or decreases the emptying of the stomach. This is known as the enterogastric reflex, which we have already discussed in our MCQ. Okay. Apart from that, you also have to remember, so although the main pathway which controls the motility of the stomach is neural reflexes, but you also have to remember certain hormones can also regulate the emptying of the stomach, motility of the stomach. Who are they? Gastrin stimulate the emptying. Means if I ask you what is the role of gastrin on pyloric sphincter, it will cause relaxation of the pyloric sphincter. But the CCK, secretin gastric inhibitory peptide, GIP, they basically inhibit the pyloric sphincter. They basically prevent the emptying of the stomach. Got it? Okay, very good. Now next. So next topic in GIT, which is the second most important topic, is the GI hormones. Regarding GI hormone, at least you revise 3 hormones. Who are those 3 hormones? Gastrin, CCK, secretin. The most important thing that you have to read about these 3 hormones is what is the stimulus for the secretion of this hormone. Must know. Okay, so please note down that for gastrin, the most potent stimulus is peptide. Very, very important. Apart from that, distension of the stomach is also a stimulus. Calcium ion, if it is present in your food, it's also a stimulus for gastrin. GRP, gastrin releasing peptide, is also a stimulus. Where from this gastrin releasing peptide is coming? Parasympathetic system, which is stimulating the G cell, gastrin producing cell. It releases a neurotransmitter which is not acetylcholine. It is a GRP. So that's why we say that peptides is the most potent stimulus. Distension, calcium ion is also a stimulus, and GRP is also a stimulus. Carbohydrate has no effect. Important. Second, for CCK, CCK is released from the I cell of the small intestine. What is the most potent stimulus? Again, your answer is peptide is the most potent stimulus. Fatty acid is the second most potent stimulus, and carbohydrate has no effect for CCK secretion. For secretin, again, it is secreted from S cell which is present in the small intestine. Most potent stimulus. Acid is the most potent stimulus. Protein can also stimulate the secretion of secretin. Carbohydrate again has no role, and fat has minor role. So we can easily understand from all this discussion that carbohydrate has no role for secretion of whether it is gastrin, CCK or secretin. For gastrin and CCK, most potent stimulus is peptide. For secretin, the most potent stimulus is acid, okay, H plus ion. Now look at the function of all of them. So functions is not very important, but you remember the gastrin has main function for acid secretion from parietal cell of stomach, although it can stimulate the pepsin secretion from peptic cell of the stomach. CCK, the main function is increase in pancreatic enzyme secretion as well as gallbladder contraction. At least you remember these 2 functions. And secretin, very, very important. Look at For CCK, we are saying that what is the main function of CCK? The main function is enzyme secretion from pancreas and gallbladder contraction. But for secretin, the main function is increase pancreatic bicarbonate secretion. Got it? So, both of them, CCK and secretin, both of them has effect on pancreas. But CCK has effect on pancreatic enzyme secretion and secretin pancreatic bicarbonate secretion. Bicarbonate secreted from pancreatic duct. So this is the two important thing that you have to remember. Now, apart from the functions of these three hormones, another three hormones, sometimes they are confusing if it is coming in the examination. That's why I have kept these three hormones. Okay, all of them are not hormone actually. So one is pancreatic polypeptide, one is peptide YY, and another one is neuropeptide Y. Why these three? Because all of them are included in the same family. So they are in the same family peptide. But look at neuropeptide Y, it's a neurotransmitter in central nervous system and peripheral nervous system, and it's a potent stimulus for food intake. But look at the peptide YY, it is secreted from L cell of the distal ileum and large intestine, and it decreases the acid secretion and motility of the stomach. At least you remember this. So note down this important thing, peptide YY. This is known as ileal brake. So peptide YY is also known as ileal brake peptide. What is the meaning of that? So whenever fat containing food reaches at the level of this L cell of the distal small intestine, what will happen? It will releases the peptide YY, and peptide YY will causes inhibition of the motility of the stomach. So what is happening? So fatty food is reaching at the level of terminal ileum. From the terminal ileum, peptide YY is released and it is acting at the level of stomach to decrease the motility of the stomach. That means as if it is putting a brake at the level of stomach. That's why it is known as the ileal brake. That from the level of ileum, one peptide is released which is causing brake at the level of stomach. That's why this peptide is known as the ileal brake. Okay. Apart from that, this pancreatic polypeptide is secreted from pancreatic PP cell and it decreases the pancreatic bicarbonate secretion. So these are the important hormones that you have to remember in GIT. Now, apart from all of them, another important GI hormone is also there. Look at this MCQ. Which of the following substances is secreted in response to oral glucose load? So we have seen neither gastrin, CCK or secretin are stimulated by your glucose load or carbohydrate. So what is the GI peptide which is released in response to glucose load? Remember, the peptide is GIP. This is the only one GI hormone or only one GI peptide which is stimulated by all three different types of food. Carbohydrate is also a stimulus, protein or peptide is also a stimulus for this peptide, and fatty food is also a stimulus for this peptide. So this GIP is one GI peptide which is stimulated by all three types of food. Now, what is the function of this GIP? This GIP is a peptide which has action at the level of pancreatic beta cell for the release of insulin. So what I'm saying? I'm saying that GIP is a peptide which is secreted from gastrointestinal tract, but the effect of this peptide is at the level of beta cell of the pancreas. This kind of peptide is known as incretin. So what is incretin? GI peptide acting at the level of beta cell of pancreas for the release of insulin. And we all know that most potent incretin is the GLP, glucagon-like peptide 1. But this GIP is also an example of incretin, right? That's why you know that previously the full name of the GIP was gastric inhibitory peptide, right? We all know gastric inhibitory peptide. But now the name has been changed. Now the name of this GIP is glucose dependent insulinotropic peptide. Getting my point? Okay. So this name has been changed to glucose dependent insulinotropic peptide, means it has tropic action on insulin secretion. Okay. And it's a peptide which is dependent on glucose load. Glucose load is a stimulus for this peptide. Got it? Very good. Now next question, maximum contraction of gallbladder is seen with. All of you can answer that this is CCK. Any substances which causes contraction of the gallbladder is known as CHOLAGOGUE, cholagogues, right? So please remember, CCK is the most potent cholagogue, second most potent is the fat. So cholagogue is the any substances which causes contraction of the gallbladder and release of bile. But there is a similar kind of question, most potent stimulus for bile secretion, any substances which stimulate the bile secretion at the level of liver. This is known as choleretics, CHOLERETIC, choleretics. So choleretics are the substances which causes release of bile at the level of liver. Most potent choleretic is the bile salt, although bile acid is also a choleretics. Got it? So cholagogues, CCK, choleretics, bile salt. Just remember this. Okay. Now the last part of the GIT that you have to read a little bit is the GI secretion. So see, there are different glands in the GIT. All those glands are going to secrete various volumes of fluid, various composition. So I have to remember the secretion from stomach, pancreas, bile or intestinal. All of these secretions are isotonic in nature, but the salivary secretion is hypotonic in nature. First thing. Now, the volume of all of this secretion has been given here, but they are not very important for MCQ, but the pH of this different secretion is important for MCQ. So the most alkaline fluid which is secreted from pancreas, we all know the pH is H.3. The pH of the other secretion has also been given. So at least you remember the pancreatic secretion is the most alkaline and most acidic secretion is from stomach. Sometimes they directly ask what is the pH of salivary secretion, that is 6 to 7. Okay. Now, among all of this secretion, they also ask that maximum potassium is secreted from which secretion? Maximum potassium. So now this question, maximum potassium, has two parts. If they are asking that maximum potassium is secreted from which gland, then they are asking about the maximum amount of potassium secreted from which gland in one day. But whenever they are asking that maximum potassium concentration is present in which secretion, then the meaning is different. They are not total. They are not asking about the total load of potassium. They are asking what is the concentration of potassium. Okay. So maximum concentration, answer is colorectal fluid, colon and rectal secretion. Maximum amount of potassium is secreted by salivary secretion. So amount means per day, total amount of secretion. Got it? So please remember, this is very, very important for MCQ, has been asked multiple times. Apart from this, maximum sodium and least potassium is bile. Maximum potassium, least sodium is saliva. Just opposite. Maximum bicarbonate, obviously in the pancreas. That's why the pH is very, very high. Okay. And maximum chloride at the level of stomach. So at least you remember this basic minimum from secretion. Now after secretion, the absorption, the maximum absorption from which part, what substances, that is also important. So look at whether the question is carbohydrate, protein or fat. The maximum absorptions occur from which part of the GIT? Answer is duodenum, not the jejunum. I am telling you in my main lecture, I have given you the reference also, but for the timing, you just revise that maximum carbohydrate, maximum protein, maximum lipid are absorbed from which part of the GIT? Duodenum, followed by jejunum. Similarly, maximum folic acid absorption, maximum iron absorption also occur from duodenum. But we all know that maximum bile salt and maximum vitamin B12 or cobalamin absorptions occur from which part? Ileum. Got it? Now coming to the water absorption from GIT. So total volume of water which is reaching at the level of GIT per day is 9 liter. Total amount of volume of fluid from different glands, from your drinking of water, total is 9 liter. Within this 9 liter, 8.8 liter of water is reabsorbed by different parts of GIT, and maximum water reabsorptions occur from which part? Jejunum, 5.5 liter per day, followed by ileum, followed by colon, and only 100 ml of water is excreted with stool. Got it? So this question has been asked already, that what is the total amount of water absorptions occur in the GIT? So approximate 8.8 liter. Okay, and what is the maximum absorption of water from which part of the GIT? That is from jejunum. So this is all about your GIT. What you have to read.